You're here, yeah?
Yeah, I'm here. You can just call me Lalit.
Okay, sorry.
No, that's fine. Just to make it easier for you.
Okay, okay, so go, you are.
All right, so let me just share my screen and I believe we will be good. So there we go. Let me know once you see it, and I will now go in presentation mode. Okay, so I don't see anyone, but I believe you see my screen.
Yes, we see it.
Okay, good. All right, so feel free to interrupt me if there is anything wrong because I'm just seeing my presentation now
Okay,
and Zoom is gone from my screen somewhere.
no
Okay,
worries.
good morning, people. Good afternoon, good evening, whoever is attending it from different places. My topic is authentic intelligence for better approximated intelligence. I have been trying to play around with AI from almost, let's say, an year, trying to do different things. And the more I play with it, the more I realize that the missing piece of information, the missing bit in this puzzle is our own understanding of human intelligence. And I think it's an important topic we must understand and discuss if we are to develop reliable AI tools and the technology to be for better usage. And I'm going to share some of my thoughts on the topic and some of the experiments I have been doing in um, understanding human intelligence better so I can train LLMs better. That's about it on the topic. Feel free to interrupt me anytime if you have questions, if you want to debate, or if you just want to have some conversation on similar thoughts. I will be happy to interact. That's a little bit about me. My name is Lalitkumar Bhamare, originally from India, and I have been living in Germany from last 8 years now. Currently working as a productivity engineering manager with Accenture Song. And I'm also a group lead for innovation and thought leadership area of Accenture Quality Engineering Services for DACH region. Among other things, when I'm not working for my clients, I work as chief editor and co-founder of Tea Time with Tester magazine. It's a free, open source non-profit publication for professional software testers and quality engineers. And I also support Association for Software Testing, an important non-profit org for testers, as a board member looking after its education program. And pretty much everything I do revolves either around testing or quality, and that's basically how I identify myself with. If you are interested in knowing more about my work after the presentation, feel free to visit my website. And I'm gonna talk about the real deal. So why should we care? I think I don't even have to explain things that are currently going around. Lots of things coming in picture about the how AI is doing things wrong, the concerns that people are having, some whistleblower bringing up some concerning topics, and I believe it's not even the topic of discussion that we should care. But I'm just going to share certain things that I personally found concerning while I was playing. So on the mid journey, I hope it's not happening anymore. But if you try to search for an Indian person, it always um, generated an image of an old man with a beard, with a saffron turban, and that was quite disturbing. Not because I don't like them. I'm immensely proud of India's culture of sense and its heritage on the spiritual side. But I'm equally proud of the scientists, the actors, the art philosophers, and all sort of intelligent people that we have in our country. And this kind of bias really made me disappointed to see how people are perceived from different areas of the world. Similarly, I think we all have almost forgotten um, the the fiasco that was caused by Microsoft Bot Day, and they had to take it back. And between now and then, I don't think we have really progressed much when it comes to developing things with ethics. Recently, Google published their apology about Gemini doing things wrong. All these things, be it about bias or be about some kind of incompetence, with the research and development happening on the AI field, is concerning. But my bigger concern is not with the shortcomings it has. My concern is more with our lack of attention and investment on making it truly useful for our purpose. My concern is with the rat race that is currently happening in our industry. Everybody wants to be associated with AI. Everybody wants to publish their success stories. I could spot some fake stories in between. This forceful celebration of something which is probably not fully competent concerns me, because it takes away our opportunity and our attention and energy from investing in making it truly reliable human companion. And the celebration of shallow takes all the glory away from real efforts that should be invested in. And that's why I have decided to dig deeper on authentic intelligence and see how better we can train our AI to be more useful for us. Quite literally, yesterday I was reading a research article on Chronicle, I believe. There are these professors, Gary Smith and Jeffrey Funk, who made some experiments on all leading AI models, and they are equally disappointed with how our present models in place lack critical thinking, and how these AI models flunk all the tests they perform to evaluate if there is any element of critical thinking, reasoning uh, in this conversational AI. And that's basically something I believe we are not paying enough attention to, which we must as responsible humans. I generally like following Gary Marcus. I have been following his thoughts around AI and the way he questions and the way he also appreciates in unbiased way. And this particular remark from him really resonates with me and my own realization of things. As he says, yes, I acknowledge as well, AI is quite competent for now. It's able to do lots of things that human could do, but it still lacks the reliability with which the results should be produced. And that's something we need to get better at. My presentation is more for software testers, or let's say whoever wants to test the AI applications and models they have been building. All these biases, all these concerns might make us wonder, like, should we give up? Should we just stop using AI? Of course, that's not the solution, and that's not what I propose. I believe with the realization of all these shortcomings, we need to make conscious efforts to focus on the things that we can take out of it, to build on top of that, and finding more effective ways to collaborate with an AI. I don't think there is even a question of doing things without AI or going back and undoing everything. It's not gonna happen. What we really need and what we really have in our hands is now learning how to collaborate without getting manipulated, without getting gaslighted, and without getting tricked into believing in something which is apparently not true. And for that, we basically need to invest in our own self, in our own intelligence, so that we can train something as competent as maybe human child. So what do I really mean by collaboration is the key. I kind of made notes for myself. If I were to test something based on AI, what am I gonna do? I think that my approach is threefold. The first one is I would like people to understand human intelligence first, or understanding intelligence in general. If we are to interact with something called artificial or approximated intelligence, I think it's very important for us to have common understanding of what intelligence means. It's important that we understand what human intelligence is really about, so that we can understand better the technology which is supposed to mimic our intelligence. And if we don't understand our own intelligence, I don't think we will be able to train this mimicry artist better, to mimic us better. So I will share some insights on how I understand human intelligence, also called maybe authentic intelligence, and comparing it with how currently AI is operating. Mastering prompt engineering. I think Rahul did an outstanding session last evening on prompt engineering for testers. It's an area which I'm also exploring a lot more with different kind of hacks. I'm gonna share something that is working for me, and then general ideas around um, building expertise on the testing side, what testers can do, what they can do differently. Now, everything related to programming will probably be automated. Yesterday, I saw a video of Devin. So, looks like humans are left with more human-based, cognition-based activities to perform. And this is an excellent opportunity for all the testers to take critical thinking seriously, their cognitive, developing their cognitive abilities and interaction expertise. I'm gonna discuss that shortly. So, coming to the understanding of authentic intelligence, I was stuck with understanding um, how should I communicate with AI. It was hallucinating, it was gaslighting me, and that made me wonder, well, it's all about interaction and communication, but communication is something that we humans even haven't figured out properly. I still see organizations and teams suffering a lot with problems based on communication. Lots of communications gap lead to lots of losses. So, what this communication is about and what would really help us to get better with it. And that's where I came across Satyr's interaction model. So Virginia Satir is was very intelligent, established psychologist, and she has done an outstanding work on human interaction. I learned about her work through Jerry Weinberg's work, who was American computer scientist and also Virginia Satir's student. Understanding Satir's interaction model of communication helped me understand how we humans are understanding things in the context of communicating with each other. There is typically an intake, then we do processing and understand the meaning, then we try to draw significance out of that, and then we choose response. This understanding personally helped me to imagine how LLMs must be trying to process the information and what kind of parallels can be drawn. And as a human interacting with these LLMs, what it should mean to me when I'm going to be on the driver's seat and driving the communication with AI. This is an interesting field. This is an interesting topic. And I think the more we invest in understanding how human communication works and how to make our communication more effective, that understanding is going to help us communicate better with AI and ultimately train these AI models to be better at conversation and not to hallucinate, not to gaslight, not to twist the facts, and not to sugarcoat things. Uh, I'm still working on it, and I think the more I understand it, the more I will get an understanding of how to implement this understanding with my experiments of interacting with LLMs. Uh, while researching more on the topic of understanding knowledge, I came across Nyaya Shastra. It's an ancient Indian school of philosophy that revolves around theory of logic, and it's kind of foundation for model epistemology. Ultimately, what we are doing, at least in the field of computer software, it's a knowledge work, be it programming, be it testing, be it anything else. We all are knowledge workers. The AI models and AI tools and technology that is assisting us in the computer science field is ultimately working and operating on knowledge data source. So if we are to train these models effectively, it's very important for us to understand what knowledge really means, how we humans understand, synthesize, and process knowledge. And then probably we will be able to better train these models to mimic us by understanding how humans process knowledge. Digging deeper on this topic helped me understand knowledge is a very vast thing, and we humans operate it, consume it, synthesize it, interpret it in very different ways. It was quite overwhelming actually to understand there are so many different aspects that matter when we are processing knowledge as humans. There is a presentation, which means we learn things through our own experience, or there are things about memory that teach us. There is a perception, there are inferences, there is a comparison that we use. We sometimes rely on someone's testimony, which is kind of becoming a problem, as the former speaker was saying, Antana. Biases and authority bias. People tend to take everything as truth, whatever they hear from their AI counterparts, and that's a problem. But that's human mind, which we need to be more conscious of. We learn through doubt, we learn through error, we learn through different kind of hypothetical uh, arguments. The point here is that I don't know, I don't even think that the models that we are training, the AI models out there, are processing knowledge and the database they are getting trained on in these all different aspects. So I personally feel offended when we call it an artificial intelligence, because it's nowhere close to how vast and competent and extraordinary human mind is, human intelligence is. And if we are to really call it an artificial intelligence or something that mimics humans, then we have a long way to go in terms of training them for all these different ways of consuming information that humans do. So in my experience, I'm going to try out making some experiments on myself as a human, how I use my own perception, how I use my experience, how I'm using my understanding of comparison of different things, and how that can be incorporated to train the AI. So it probably picks up and really mimics me and identifies my pattern while interacting with me. Probably it's just a wishful thinking. I do not know. I'm not a data scientist. I'm not an expert model trainer, but I think there is a lot for us to uh, explore and invest in this kind of training for AIs to be more useful and reliable for us. And now let's try to understand how neural networks, transformer neural networks typically work. I believe most of you are already familiar with it, but there goes a lot in it. There is an input representation, there is encoding, lots of things happening in sequential way. Probably lots of it has also now changed with different techniques to train them. But comparing and looking at the sequential order of things it operates in, the chances of making mistakes are so high, because it's not just about making different words match together or doing some pattern matching exercise. Intelligence is way more than that. It's way more than that. And the more complex these operations are, the more chances of error there. And if we are to test AI-based applications more, we need to understand what an intelligence means in AI context. And that's basically why I have put up some of this information here for our own understanding. As I was saying, there are lots of chances, data bias. There was an interesting presentation before. Token limitations are there, latency problems, a context understanding. In fact, for this presentation, I was recording a video yesterday of my interaction with ChatGPT, and interestingly, it kind of impressed me with the way it sounded very understanding and human-like in its conversation. but the next moment it lost its context and took the conversation on a very different uh, track. And that's not what intelligence is about. So, in order to understand how we can make it better, we need to understand the areas of failure more in detail, and also we need to understand what causes those failures. And apparently, we also need to trace those back to AI's way of understanding and synthesizing information, and probably training it better not to do those mistakes. Even with RAG, which is kind of becoming, or at least being sold as the thing, the hot thing to really solve all sort of problems, I try to understand, I try to evaluate it from my experiments. It's not really a foolproof solution. There are still problems, there are still challenges, there are performance issues, latency issues. Fine tuning on the fly is creating lots of problems. So this is what I was saying, what concerns me. We are so busy celebrating success stories that we are apparently not making serious investment in eliminating the flaws that we still have to fight. There are people working behind the scene, I do not know, but so far I only see celebration and success getting discussed, and very less discussion, very less uh, inquiry about how things could be better. It will be interesting how things are unfolding in coming days. But if we are to understand the difference, there is a lot here. Authentic intelligence that we are born with has its own intricacies that are not fully explored by humans themselves, at least not by average human, unless you're a researcher on the topic of intelligence. So if we are to really bridge these gaps, I think my message here is we need to make serious investment in first understanding our own intelligence, and then finding ways to train AI better. You might be wondering, Lalit, all good, tell me what you have done to solve this. And of course, I'm gonna share what I'm doing, but basically, this is what I try to revolve my own experiment with. For me, authentic intelligence requires two things which are very, very important: critical thinking and causal reasoning. Because if I'm to have interaction with conversation I need to be able to come to a logical conclusion. If I'm going to use AI agents at my work, or if I'm going to outsource my work to some AI developer, I need to really understand how it derives conclusions, how it comes to deductive reasoning of things. Because I don't think LLMs can acquire these skills by finding some statistical pattern in the words they don't really understand. How do we do this better? How do we bridge this gap? And I found my answer for my context in Nyaya Shastra again. So I tried to understand the erotic model of reasoning and interaction. I have used that in teams while interacting with humans, with programmers, with designers, and also testers, and it really has helped me eliminate a lot of potential problems hidden in uh, plain sight, which could come to surface because of the specific style of communication and interaction. So what is this erotic model based on Nyaya syllogism? So Nyaya syllogism has five elements compared to the three syllogism from Western philosophy, and I have been trying to do my communication or interaction with AI models using this particular trick heuristic I call. So you basically start with your thesis, whatever is the fact you want to establish or debate on or discuss, and then you use this method of questioning back that arises from natural doubt. So you ask something to ChatGPT, for example, and you are not fully convinced with the answer. There is some element of doubt. You questioning back, and you force it to fine tune its own pattern of uh, matchmaking of the words to give you more fine-tuned array of words, basically. And you could again ask to explain things with some examples. This is what I do with humans, and it compels them to go back and think about convincing examples to tell you. And then you again go back and try to discuss, okay, why this example is, relevant to this context. And ultimately, that helps you derive some conclusion. It also helps you derive some negative conclusion, basically that, okay, you're bullshitting, this is not true. Here is one quick example. If you're interested, I can share. Uh, wait a moment. So I am made an So I was debating yesterday with ChatGPT about if Earth is round or flat, and it gave me some summary of things, and I questioned it back. Why does it believe? It gave me some data points about its own belief or its own understanding of why it thinks Earth is round. I asked for giving some facts where it kind of hallucinated, and he mixed things up with Earth is round with some other general facts which I did not want. So I routed back the conversation on track, asking it to give examples about Earth being round. And ultimately, we kind of concluded the conversation about why Earth is round. This is very simplistic example, but if you apply this kind of reasoning and arithmetic model of discussion uh, to debate over, or let's say discuss work-related things, be it, some requirement coming from your specification or some kind of a technical topic. I also try to debate over Akamai cache and how it can create problem. And having this kind of conversation with AI where you don't take anything it says for granted, but you question it back, and you compile it to fine tune its own answers. I think it has been working y- good for me. And I don't have the ready references right now, but I was reading some researches where there have been some techniques to basically question back your AI models, so it learns to fine tune its own responses with repeated interactions. And I believe this could be, sorry, an useful way to eliminate the bias, because I don't think we will have a luxury to change the data at the source on the runtime and fix it on the fly, but probably by interacting with AI in an intelligent way, in a way that helps both the conversationalist people to arrive at a conclusion with some logical reasoning, is probably going to be useful. That's my hypothesis. I don't have a theory and data points to prove it, but I'm going to explore this experiment more and see how it helps. That's pretty much what I wanted to share on the topic of how I'm trying to understand authentic intelligence and trying to implement it with my interactions with AI. But all in all, in summary, collaboration is the key. I don't think there is any option to get away and ignore the reality of AI, but we certainly have an opportunity to invest in ourselves, to collaborate it better and find better ways of interacting instead of just taking everything on its face value and accepting everything to be true. Uh, with my experiments so far, I think at this stage, interacting with AI is like interacting with human child. They mimic us, they learn from us, they understand the patterns, and they try to use that understanding of us. But our ability to bring out the best from AI depends on our expertise to interact with them effectively, all the while making sure that we are not getting manipulated or gaslighted. Just like responsible parent. That's about it from my side on the topic. I will be happy to answer if you have any questions.
I think, Lalit, your presentation was very insightful. And as we are in the border with the time, I think if anybody want to ask, there is still 1 minute. Anybody want to ask something? If no, thank you very much for your presentation. We appreciate it, and soon you can see it online because we are recording the presentations we make. So
thank you so much. I appreciate it.
Thank you. So
thank you.
Our next bye. Our next speaker is Andy Petrella. Andy, can you hear me?
I can hear.
And I can see you too. Okay, so Andy will talk about some topic about data observability and more or less, can we stop that BS? I'm not sure what is that BS about data observability. That's the presentation of our friend Andy Petrella. So Andy, when you are ready, you can just start.
Awesome. Cool. Thanks for inviting me. Hey Karen. Hi Jan. Atanas. BS stands for bullshit.
Okay. I was just wondering. I was not sure. Thank you for that. Okay.
So yeah, because there's a lot around that. So I'm going to do some topics about this, right? So Jean-Georges told me that he likes, talks a little bit pushy, so I didn't hesitate too much with this title. I guess you can see my screens right now, right? So it presents roughly my experience. So I'm going to go very fast on this. Okay, been working in data for 30 years. So started in geospatial as a data miner. This term may come back at some point, like SQL, I guess. Been working mainly with geospatial information, therefore images and vector data. Then I've been evangelist for Spark, creating the Spark notebook, open source software. Grow a pretty big community around that. Didn't found any company around that, but after some times, I have founded Gensu with a mission to actually drive some community progress and also some best practices around what needs to be done in data in order to create some kind of visibility about what being deployed in production. So why I founded Gensu is because of the Spark notebook. So I discovered a lot of people who were super keen to deploy notebook in production. So I thought that this will actually lead us to some disasters, which is actually pretty much the case very often these days. So that's why Gensu was founded originally. So I also been authoring some books. Lately, I delivered, lately, like 6 months ago now, I delivered the fundamentals of data observability at Rally. You can download it for free on our website. You can, which is at the end of this QR code. But of course, you can also acquire it on Amazon, O'Reilly, and so forth. So what do I think? That actually there is a lot of BS around data observability, right? Actually, I'm going to talk about data observability, but the explanation is pretty true for a lot of technologies or practices. So I think that you can see what this chart is, right? It comes from Gartner hype cycle. Really is about the hype, is not really about value of the product or the topic. Right. So basically on the y-axis, you have expectations, right? Or dream or hope, right? On the horizontal, on the x-axis, you have time, right? Basically, there is always a trigger, like an idea. Okay, so you start with something. So there is not much expectation, there is a hope, there is something, but it's really the beginning. Then very quickly, you end up with like unicorn. So you want to grow this ID to the maximum and you get unicorn out of the original ID. So I will explain why you have this kind of fantasy around the initial ID. But of course, because it's just becoming relatively fantasy, right? Then there is like, oh, darn, what did I do, right? So why did I grow it so much? Then at some point, some people are kind of raising their like, hey, actually, can we go back to the original ID and grow value around the original ID instead of growing fantasies and dreams, right? And at some point, when everything is kind of there, right, that only the original value is exposed and expectation around the original ID are actually considered, you know what? No one talks about it anymore because it's like working is into production or it's used. So no one cares anymore talking about it, right? So LLMs and Gen AI will be eventually there in a couple of years time frame, something like that. So that's a hype cycle, from my point of view. Thing is, actually, I like to change a little bit where the x-axis is, where y value starts and grow, right? So basically, if I put the x-axis over there, right, that there is an asymptote here, right, where on the bottom line you have like shininess, like something that is actually very insightful and useful, right? And on top of this, right, from there you have crap, basically, right? So all the things that you shouldn't be doing with any kind of software or tools or practices. So actually, let's talk about DO, data observability, for instance. Like the very original idea was like, oh, I need a solution to avoid data engineering, so from suffering from data production, data pipelines in production, stuff like this, right? So what can we do in order to avoid these people to suffer? And of course, when we talk about the data engineer, we talk about also the users, because data engineers are both producers and consumers. Then, because the original idea is since like very interesting, the shininess grows, right? And you have the first startups, like I can see, 8 years ago. And from there, because you have startups, you start evangelizing, you try to expose more and more your ideas, you expose this to more and more people, and eventually you get the first investments, right? Because your idea picks up and it makes sense. Then this is where the crap starts, right? Because there is some investments, right? You have more investments coming up, right? Why? Because someone has to take the lead of this new thing, right? Eventually, it has not born. It was not born yet, but yeah, there is investments because investments, right? There are more and more investments. So someone has to take this lead, right? And then you have more startups coming up because there is investments, right? So therefore, you want to get more investments, and there is more and more crap being said about this just in order to get the investments, right? And eventually, at some point, right, because there is so much has been said around the topic, right, that even the existing players that are not related and in any fashion with the initial topic, right, say, oh, you know what, we are doing this for years because actually the original ID has been covered and covered by crap, just in order to make it investable, right, to grow the targeted market, to grow so many things about it that it makes kind of sense for a large community, right? Nevertheless, right, because actually the existing players are saying, yeah, we do this for a year, right? At some point, we lost the focus, right? We lost the focus because, well, if the original players were already doing this, we wouldn't have had the original ID, right? So therefore, the focus has changed to something that exists already, and people are just saying, actually, yeah, this never worked, or it's just something that we saw so many years ago whatsoever. So basically, the original ID is gone. I'm not saying in data observability we're there already, right? I'm just saying that, well, yeah, eventually we'll get there soon. And actually, because people are kind of losing hope into these things, the expectations are inflating, right? Are deflating, sorry, right? At some point, you kind of dig around. So you try to remove as much, from the messaging and the information available out there provided by the vendors or whatsoever, and you try to actually dig in order to find the original ID back. So what happens is that only when you had all these investments and all these things have been said around the topic, right? At the end of the day, right, after some point in time where everything, expectations were deflating, right, you have a few adopters and a few believers that are still hanging strong with the early adopters, the people that were, working with these startups right over here, not the people over there, but the people were here, right? Here, sorry. And then eventually the market is not as big as where, the people over there were saying, right? Because, there are so many markets and so many things to be done. So I will discuss this later, that at some point you have, very little, how to say, availability of solutions that are actually targeting the original ID. Most probably the people that are lean and frugal, right? I'm not saying that this is only for data observability again, or we are there yet. This is where it's great again. And then actually, because it start making sense again, because the original ID is still valid, right? So the interest grow again, and then the shininess grow again, right? So it just makes sense that you need to have something like this in your environment, right? You don't have to grow the market. You don't have to do so many things. You just have to make it relevant for your own use case. You will think that it's gonna be part of the data platform foundation, pretty much like data governance or catalogs are today, right? And then at some point where you're going to go close to the crap word, right? So you're gonna asymptotically, follow this line, right? The expectations and the value will not grow extensively, right? It's gonna be just a pressing battle to know, who's gonna be leading or is gonna be, on top of the funnel. So this is basically how I interpret the hype cycle with regard to how startups and ideas are picking up by the market. Then there is the messaging, right? So the messaging, you go from sneakers, people are on the ground, right, and working actively with these things, and then you have the ballerines, where you try to be as shiny as possible just in order to attract as many investors and potentially customers. So about messaging, right? So you start by saying, you know what, data issues backfire. So they just happen, right? And then people are poisoned by data issues, whether they are at the end of the pipelines or the beginning of the pipeline. It just backfire continuously and in your back, of course, because you're not continuously looking at the data while you're working on other topics. Then at some point, the message changes, like, okay, data engineers are clueless. There is not enough information about why the data issues are happening or why they are backfiring. So basically, they're clueless. It's not that they are not useless, right? They are clueless. They don't have enough information. So where this went from the point that data engineers are clueless is that we're starting looking at SLOs, right? SLOs stands for service level objectives. So what are the objectives that needs to be maintained, right? So that data in this case, right, are qualified as okay, right? It doesn't mean that you reach perfection or they are good quality. It's just that you have reached a objective, right? And at this moment in time, right, we were about to cross actually the ballerine area, right? We were talking about also anticipation because, of course, only ensuring that objectives are attained are nice, right? But not enough in order to really picking up on the idea that data issues backfire. So if you have SLOs, you're still reactive. We want to be proactive. Cool. So far, so good, right? And then, okay, then we change the focus again, right? So, okay, so we have startups, we receive investment, we need to get the money. Oh, the money is on the business side. Oh, but the business sides are not really data engineering. Okay, fine. So we're going to change the persona and we're going to talk about BR reports once again, right? Oh, the BR reports are breaking due to data downtime or whatever, right? Because we have to change the focus in order to really sell something. Then, you start talking about data quality after that, right? Oh, BR reports, but we need to talk to people and people don't really get it. So you start talking about data quality because at some point, data quality is so important, right? And it is important, of course. But data quality is becoming so important. People can understand data quality, even in reality, they don't really understand data quality, right? So you start talking about data quality and you want to have business deciders, with SLAs in place. And SLAs is a little bit different from SLOs because SLAs are really close to a contract where, basically you have to negotiate and you have to have also kind of other type of backfire attached to the SLA, right? So that means that if something is unattained, there is some kind of, how to say, counterparty that happens when the SLAs are not put in place. So you start discussing about SLAs and, at some point it kind of makes sense, of course, but in reality, we've tried this for quite some time. And when you are on the top of the expectations, on the top of the unique, kind of dreaming type of idea that you can attach to data observability in this case, right? So you start talking about this data business that needs to rely on very important and reliable data. You want to automate data quality assurance, and you want to put trust, of course, on your data at any point in time, right? It's like a phrase that, it's almost impossible, to attain, right? Because you have put so much expectations into one single topic, right? But this is where actually we've been way too far, right? And at some point, people are not even thinking it's possible, right? There is too much there, right? So, and because you try to reach this kind of statement, right? You put so many different things in place that you're getting where I think we are today with alert fatigue, because your system is throwing, errors all over the places, discovering data quality issues all over the places. SLAs are not very well defined because it takes too much time. There is responsibility throwback because we don't know anymore, if the data engineers are responsible, the BI people needs to be taking care of this. It's a mess, right? At the end of the day, data quality issues still happen, and we have put a lot of investments everywhere. So this is where we're getting there now, I believe, right? Is that, well, basically, because we did all of this, data engineers are still clueless, right? So we're still, in the same position we were there, right? Where we have not faced anymore the original problem, which is data issues backfire and data engineers are clueless. So at some point, of course, as we've seen very often, there will be a DIY. Okay, so in certain companies, they understand, that this is what we need to face, right? Basically, they will try to do on their own, but it's expensive, of course, right? And at this point, right, which may happen, I don't know, perhaps in a year from now, right? People will start remembering 5 years old past, blog posts or articles or whatever, right? And startups like, oh, I think that I'm doing something that I've seen some times ago, or by looking around how I can achieve things. Yeah, I will actually stumble upon some blogs that are exactly explaining what I'm trying to do in my own company, right? And this has happened often in other areas in data observability. So I'm not imagining anything here. So actually, you remember these things, okay, and then instead of focusing on building the thing on your own, you start focusing on responsibilities, right? So okay, instead of building the platform, you may look at the existing tools, and then you change your payload. Let's say what you expect to do. To work on the solution or work on the global solution. I'm not talking about the technological solution only, but really, how can I build responsibility around this topic? Then you can emphasize again on the technology only after the responsibility, because first you need to set them up. And perhaps at this moment in time, there will be maturing open source software that will be available so that you don't have to build yourself, right? Or perhaps you can rely on technologies that were built by other companies, right? Or you can go to vendors, because at some point we know the limit of open source software. You have to either keep going with your DIY OSS, right? Or you look at vendors, all the vendors, right? Who cares, right? But because you have other matter to focus on, so you want to rely on this. So it will take time. So this is where the hype, again, is close to something that has value, and where the message is, because no one cares much about talking about it, because no one cares much about growing the market anymore. The market is established, right? Basically, the message are, close to, becoming kind of, awkward, right? Because there is still the battle between vendors, right? But no one crossed the line anymore, because they've been there, and there is no worth doing this anymore. So this is where we're getting at. This is happening currently in data observability, as I said. So, but the main problem from my point of view is that data engineers are still clueless at the moment, which creates disturbance, especially when we have Gen AI projects booting. So this is why there is so much BS around DO, right? Now I just want to establish what is, it's 48, so I have 12 minutes. So the fundamental idea behind data observability is just you just want to generate information about data, right? You want to understand what the data is, how it is being used, right? And how it has been created, right? And this information about these things, right, needs to be easily consumed by an observer, right? That's it. So that there is not much than this, right? So this is the fundamental idea. So you need to understand what is the data, how it is being used, how it is being produced, right? And this information is to be available for observer, right? So how you can use it though, right? You can use it for different things, right? Doesn't mean that data observability alone will be able to achieve all of these things alone, right? But still you can use data observability to support this different usage. Like you want to perform reliability assessment of your data, right? Or you want to use data observations in order to detect anomalies, right? So this information will be useful in order to achieve this. Or you want to take proactive maintenance measures, like you want to use data observation, like information about, let's say, how the data is used in order to anticipate a maintenance on the pipeline that is using the data. Let's say that at some point, let's say that the data comes with way less the data that you used to have in the past, right? You want to take proactive actions on the pipelines using the data, either to change a model, either to not run the pipelines, either to do whatever, right? It's just that information about the data can be used in order to anticipate things in the user of the data. User is not necessarily a user, person, sorry. You can ease troubleshooting because you know how the data is flowing, and you can which is for me the most important with data observability, is that you can have factual communication, right? Because you have information about the data, you have information on how the data is used, and you have the data information about how the data is being produced, right? When two people are talking about one data, right, they can use this information to address a problem, like, oh, actually, I'm producing the data and I'm seeing this pattern in how the data is being produced, right? So this is information I have about the data production. Oh, but me as a user, right, I see the data a little bit differently. This is the pattern I see in the data, right? And with this information at hand, right, you can come closer to a resolution, right? You can either accept that the new pattern, let's say the schema has changed or there is less data, the new pattern is actually valid. This is the representation of the world, right? There is less data about the fact that you were consuming, and then you accept this because you can explain that the new pattern is the accurate one, right? From the user perspective, you can also share what you were expecting from the data based on the pattern that you had in the past, right? And what kind of pattern you want to continue receiving, right? So this is this kind of a factual communication that can happen. Basically, this is exactly the same as two engineers, software engineers, working on a different system, right, which are interacting with each other, right? One is producing a service, the other is building another service based on the other one, right? Because they are sharing information about availability, exceptions, or whatever, right? They are talking the same language, right, and with information that are very similar. So this is really important in producing information that smoothen the communication between producers and consumers. So thing is, so we are like in 2034. This topic has been around for quite some time now. So why are we not actually using this everywhere, right? So why not? The thing is that introducing data observability is not free, right? It comes with a cost, right? So whether you need to change the systems that are actually using the data, they have to be tweaked. You need to also make sure that information that is produced about data consumes and produced, etc., right, are consumed, right? There is actually something in place that is consuming this data, right? Otherwise, you don't think it's actually relevant for you to generate information if it's not used, right? That makes sense. The thing is that it takes time, energy, resources in order to get there, right? So, okay, fine. So data observability is not free, right? It may mean for you that it's not the right time to do it, right? However, and it's fine. However, I would like to have a community of data people that feel a bit, how to say, um, uh, not ashamed, but a little bit like worried about the fact that data observability is not put into the systems, right? It's just that it's pretty much like when you go in production with your application, your pipeline or whatsoever, and there is no test at all, right? No test, no logs, no whatsoever, right? We've done this. We've done this as data engineers, as engineers over, right? We've done this. We put something in production without much guarantees, right? Thing is that I've done this too, right? I'm not really happy, right? I'm a little bit anxious when I do this, right? And what I think that we as data people, we need to feel like, without having some data observability systems in place, is that we feel a little bit anxious about it, right? And at some point, right, if we feel enough anxious, we will detect when data observability becomes something that needs to be added, when there is more issues, when there is more, things happening in hindsight, et cetera, so that it keeps, growing in the back end, so that we can actually also expose to other people, especially stakeholders or managers, that, well, it may be time actually to introduce some data observability practices in the pipeline, so that we're not suffering too much about the things that have been put in place without any guarantees and any guardrails, right? So I mean, that's the minimal I think that we should be able to ask most of the people how they are using data or producing data. So let's be honest, right? So the blocker with data observability is not really technology; it's mostly organizational, right? So I mean, introducing data observability is not like, okay, we're gonna produce data about data and we'll be good, right? And everything will be safe now. Data quality will be good, or tickets issues will be actually tackled on time. No, actually, data observability is about providing information, right? And then around that, there is some stuff that needs to be settled. Like you need to be sure that you know exactly what is the ownership of data observability, right? So pretty much with data governance, there is an owner of data governance, right? Or data engineering, there is an owner of data engineering, BI, ML, etc. All the things have an owner. So you need to have an owner also for these things. Pretty much like there is an owner for observability for systems like, I don't know, Splunk or Prometheus or Datadog and these things, right? There is an owner around that in order to make sure that it's efficiently used. You need to make sure that the communication is strengthened, right, around data usage and consumptions based on information available in the data observability systems. There is quite some practice that need to be learned, right? And the practice won't be learned naturally, right? So you need to have someone that it feels accountable for this and will spread the word around. All these things are actually blockers or slows the introduction of data observability practices, like it used to be the case with unit testing like 20 years ago, right? So it's the same thing. So there is way too much to be done out there. Well, at the same time, we have to still show the value of the data. We still have to start new project with Gen AI. We have more and more things, on our shoulders, and this is way too much to start with, right? So my recommendation, so to close today's talk, right, is that start small, right? So really start small. So you don't want to shake it all, right? So that's why there is a new kind of role that, like it exists also in other systems, as I said, doesn't mean that it has to be a full-time job, right? But there is some kind of role, like an officing role, right? Is that person that is able to communicate about data observations, right? So schema, metrics, usage, lineage, all this information that are collected by data observability platforms or generated by applications, right? There is a need to communicate around that, to expose the value, to expose what can be done with this, and what should be done with that, right? I'm talking about about alerts, of course, about communications with data catalogs in order to feed some documentation purpose, etc., etc. The thing is that this person, this role, is at the end of the day accountable for data reliability, right? Nowadays, there is no real role appointed to find out how data reliability can be maintained and strengthened, right? There is data governance on one side, there is data engineering on one side, there is operations on the other side, right? But no one is responsible to handle data reliability overall. Other people are there to make it happen, right? But no one is like in order to orchestrate all these things, right? So basically, a DAO is like mainly focusing on data satisfaction overall, right? From the user perspective, let's say. And there is, of course, a strong link with products. Like you have a product satisfaction person. Here, the idea is to introduce this for data too. So quickly, what is the DRO, right? So the idea is to reduce the number of issues reported by users. So this is one of the first metric to reduce. It doesn't mean that the DO works directly with users like BI, whatever, right? But the idea is to reduce this number, right? Without having to interact perhaps too much with these people, right? By taking the problem very early in the pipelines, very early in the systems in order to reduce this number, by action reaction effects, right? So if you take the problem very early, then the problem will not impact too many people. However, when there is a problem impacting users, right, you want to make sure that the DO is capable of explaining when the way a problem has happened in order to make sure that the users are not, pissed by the problem themselves, right? So therefore, you want to reduce the number of users being impacted also by the problems, right? So report it and impact it. For this, you have to increase the number of systems that are under control, where data observability is like in place, right? And for instance, increase the number of data monitoring rules, right? Notice that I have not introduced an equality mention here, right? So it's 10 on my clock, so I'm reaching the end of this. So I can talk forever, but I'm closing very quickly. Just if you want to learn more about DO, you can ping me. There is a way to get there. And I wanted to thank everyone about this event. All of what I have just said is in P already. Everything is in P, as you know, right? And thanks everyone. I guess there is no question, so I'm going to leave eventually. Thanks a lot.
Thank you, Andy. It was very insightful. So, see you. Thank you one more time. And now, as our next speaker is Vincent Heuschling, and he will present to us optimizing Lakehouse strategies with the modern data stack. Vincent, can you hear us?
I'm unmute. Yes, I can hear you.
Okay,
obviously.
so hello.
Hello.
Okay, it's up to you. You can share your screen. We are ready.
Okay, I'll share my screen. Okay, can you see it? Yes, you can.
Yes,
Very
perfect.
good. So I will start. Okay. Can you still see my screen? That's okay?
Yes, it's fine.
Okay. Very good. So thank you for attending this presentation. I will try to explain you how you can optimize your Lakehouse strategies with the new kind of tools that we call the modern data stack. First of all, I will introduce myself. I'm Vincent Heuschling. I'm the founder of a company named Datatask, and I spent most of my time with customers at designing, building, and running cloud data platforms since 2012. We have a huge expertise on the Google Cloud and Amazon platform, but also on more local provider in France, like Scaleway. And also, I've created a podcast, which name is Big Data Hebdo, and we are hosting this podcast for French-speaking people. Sorry for most of you. And we are making a recording about every week to speak about the news in data, AI, and all that marvelous stuff. So let's start with this notion of data lakehouse. And lakehouse, as you see, is the combination of the term data lake and data warehouse. And it's aimed to be the best of both worlds for all. That means that with a data lake, you can have the same objectives that you had previously with the data warehouse, and you can use your data lake as a support for all your reporting initiatives. And that's the key concept besides this. And if we go a little bit after that, we can first say there are many ways of structuring your lakehouse initiative, but most of the time, what we see, customer makes a choice of using this raw, normalized, optimized layer pattern. which is also known as medallion architecture, with medallion meaning that we have the bronze layer, which is the raw data, the silver layer, which is more normalized data, and the gold layer, which is optimized. Or maybe you have heard of it as this medallion architecture. And for instance, if we make some simple example, we will collect in the raw layer every source of data we will be supposed to use. And it could be some direct file ingestion. It could be some database connection to some operational database to extract some data. And it could be also connecting to some API to collect data set from this API. For instance, it could be your web tracking tools. It could be many things like that. And once we've done that, we have, for each of source of data, we have a set of files in this raw storage area, or set of staging tables, if you are stick with some database architecture. And we will be able also in this raw layer to have the history of database. And it's an important point because it will allow you to have some point in time, and being able to go back to some data set previously seen, and to have some versioning of the data source you have. And the normalized layer has one key aspect, is to converge different sources that are speaking from the same topic. Imagine that you have two sources of data that have information about the vehicle your company is using. And some attributes are in one source and some other attributes are in the other source, but they have some definitions, some IDs that are not obviously the same. And in the normalized layer, in the silver layer, if you are with a medallion definition, in the normalized layer, you will converge all this data in one asset. That means for each business entity you have, for each dimension, you have one entity in the normalized. That means that if we want to know, to have the source of truth in the company for one kind of data, we will be able to have it in this normalized layer. And the optimized layer, as it's named, it's optimized for the consumption we will make of it. Meaning that you will not provide data in the same fashion if you are aiming to use it in an LLM for making it for a chatbot, for instance. It's very trendy at this time. Or if you are doing more classically reporting with Power BI or Cognos or any tool you have in your company. So that means that in that layer, you will make some aggregation, you will take some disposition around the data to make it efficiently consumable by your different usage. And this usage could be, as I say, it could be some AI initiative, it could be some reporting, it could be some API, it could be some application directly embedded in your Lakehouse. If we look at this on the architecture point of view, we have some different options. One option that we've seen a lot these last years is the one big data warehouse and data mart database. And the content on this option are obviously Google with BigQuery, Snowflake. And it's clearly the ELT approach. You load everything you have in a database, and once it's in the in this gigantic database, you will make some transformation to refine that data to fit your data product needs. And that's important to understand that this choice, even it seems very simple to manage, to operate, because you have a very reduced number of components. It implies some very huge cost, because storing data and managing data and processing data in that kind of environment is something very, very, very expensive. The second approach is a more traditional evolution. It's a more traditional, it's an evolution of what we've always done with that data warehouse. We have a storage which is Data Lake. And the first iteration of that was using the Hadoop. For those of you that has known the Hadoop era, we store a lot of files, a very huge number of files on storage, and we put a data mart beside it and we put our usage on that data mart directly. And the most innovative approach is using directly the storage and putting all usage directly on the storage by using some tools that can use it. Very quickly, we'll cover the different layers of the modern data stack. This modern data stack is a new set of tools that have one point in common. They all are serverless tools, meaning that most of them can be consumed as a service in the cloud. And if we look at the component in this area, you have for the ingestion, we have forgot the traditional ETL. As I said, we are clearly doing now ELT. We extract, we load, and then we will transform the data. So Airbyte, Fivetran, DLT Hub, and many others are tools in that space. For the storage, and we clearly have some actors now, which are Snowflake, Google BigQuery, and obviously AWS S3 is the most simple, but it's something that allows you to build some very large data lake. And for transformation, we have the most well-known on the transformation in this Lakehouse architecture is Databricks. But there are other options which are less expensive, which are dbt and DuckDB that we will talk a lot today. So if we one of the key concepts of building a data lakehouse is transforming data in place. If you transform the data in place, that means that you don't take the data out of the storage to process it and write it back in the storage. It's something that allows you to say, okay, I have files in my storage and I will process this file and keep them in the storage, and I will write down the result directly beside this file. And that's why I will introduce you the concept and the stack we've built with DuckDB and dbt to build that. If we look at the stack, it's quite simple. On the top, we have dbt. dbt is a tool that allows you to make some modelization on data using SQL traditionally, but make small models and have a very large graph of model that will be able to make some simple operation, and so also to have some semantic definition of your data transformation using dbt. DuckDB is an engine that allows you to process Parquet file directly on your storage and to take some SQL transformation and apply them on data directly on the storage. For storage, we have now some columnar file format. Parquet is one of the most used, and there are some other cousins of this Parquet with Delta Lake, which is a Databricks format, or Iceberg, which is an Apache format. And also everything is stored on AWS S3. Even we speak about AWS S3 is what we say that there is could be said for every S3 provider, meaning that a lot of cloud providers use the S3 protocol to bring storage service. And also it could be done with GCS at Google or at Azure with the format of Azure. If we look at what it's done, if we make a focus on this data in place transformation with DuckDB and dbt, we will have some Parquet file on the distributed storage. And for instance, on the example I will show you, we have some 400 Parquet file with 2,057 million lines. And from all this Parquet file, we can define some data sets with some metadata on it. How we define transformation with dbt? It's quite simple. A dbt model is 3 files we define. This file, one is a SQL command we see on the right side. And we see that we don't say directly the name of the table. We say a reference, which is something that allows you to propagate your modeling on different database without needing to rewrite a lot of queries. On the left, we have a metadata information. We have some information about the table we are modeling. We are making some assertion about the columns we want to test, or some test on some things like that. And also we have a very free form documentation, which is a markdown file we define. And all this allows us to have some very detailed information about the modeling, but it's not only for table against database. As said, we can do that kind of modeling also on file system in an S3. Here we see we have the same kind of query, same kind of modeling, but we are making a configuration that says that we want to materialize this as a packet file in an S3 bucket. If we look at how we can ensure quality and lineage on the data, when we speak with organization, the most of the time the problem said by users are the following. This user says, okay, we have a poor quality because we don't know if the data has been tested before sending it to us. And also we have no information about how the data has been sourced. Meaning for that data product that is exposed to our business usage, we don't have any information about where the data comes from and how this data is transformed every day and so on. So we have some problem, and also if we found some data issue, how we can cope with it. In terms of quality testing, on the metadata I've shown you just before, we've seen that we are able to define some simple tests on the column, on the modeling that DBT made. And these models are quite simple. We have the ability to have some simple tests. We want the cust key column to be not null, to be unique. And also for the segment column, we want to just define a list of accepted value. So we write this in the configuration, and everything will work fine. We will see after how it's tested. And also, we can have more global tests, meaning that we can write a SQL query that will check data, that will make some tests regarding multiple columns, that will make some tests on different tables and join them to make the test. So we have a very large flexibility of testing data. That means that once your users know what is the key function that they have defined the data contracts, one things you will heard a lot, I think, today, we can implement this kind of test regarding the data contract. And once it's done, DBT will be able to run some tests and create a SQL query for each of the tests we've just defined. And this query will be run. And if this query returns some record, the test fails. That's what we see on the 3 of 9 line. We see that we have more than 1,000 customers with low balance in the database. So that's something very simple that allows you to define the test. And if it's about the data lineage, by modeling using DBT provides you a direct data lineage, allowing you to say, okay, my top 25 crypto BTC asset is defined using the always file name source file. And if I have a problem with the always file name source file, I can immediately identify which are the impacted assets. And with that, you have the ability to clearly navigate in this data. And also, what is important at that point is that we can. I will try to show you that directly in the documentation. If we look at if we look at the documentation provided by DBT, we will be able to see it and having the capability to focus on one point and say, okay, I will refocus on that node and I can isolate this node as this property. And as we said before, if we look at the documentation we have for some models, for instance, our customer we've just defined, we have here a documentation that allow us to see clearly all that model and see in the documentation all the different assets that are depending of that. If we come back to this, once we've done this lineage, we can also directly connect some reporting tools. Traditionally, we can clearly use API on top of the storage to materialize data in a data set and then being able to publish that data set to be used by the reporting tool. But also we can directly on the data lake, reading the packet file with some API to host some application and being able to run it very, very quickly. If we come back to our tool, we will be able to see, for instance, that application. Here I am in our tool, our data task tool, and I will be able to use, where is that pop-up? Sorry. And for instance, here we are clearly connecting to a 400 data file in the storage and being able to clearly navigate and have some reporting. And if I change this Streamlit app, which is maybe 10 line of Python code, allows me to navigate on the different assets and to be able to directly connect a business application to the data lake. So it was a very quick presentation of what we can do with these modern tools and being able to transform the data landscape we have. Maybe you have a question on this subject.
Yes, of course. I have see some questions here. And one of them is, can you explain, please, the advantages of using DuckDB and DBT for in-place transformation within a data lake environment?
Okay. This question is something very interesting because instead of having a huge database that will be always running, if you imagine that you have some transformation that you want to operate in batch mode, it's somehow something that will use maybe 1 hour of processing every day to rematerialize all your data set and so on and build all the graph you've seen. And that means that with DuckDB, you will spawn a process that will allow you to process the data in place. And once this processing is finished, we will shut down the compute resource used to do that. It's something that is very near from what Databricks does with Spark, for instance, to process data, but DuckDB is very more flexible and it's an engine dedicated to process data with SQL. And that's a huge advantage when you are comparing it with large-scale database that needs to have some provision resource and something that is very, very expensive. And also with DuckDB, you have nothing to manage. The only things you have is to push some SQL transformations that you run with DuckDB. And DBT has another advantage is the capability to split. If we look back at what we've done here in the tool, if we look back, we have the ability to split our model in very small functional entities. And the small functional entities, if we look at, are just focused on fitting with one need we want to and one response we want to provide. Does it clarify the point?
Yes, thank you. Can I ask you one more question? What do you think? How does building a data lake in cloud storage like Amazon S3 compare to traditional data warehousing solutions in terms of cost, scalability, and performance? What do you think?
Okay. First point is that you have some, at the bottom line, you have something that is very simple, and and you have some the layer architectures that we've seen before here allows you to manage the storage separately from the compute you will use for the DuckDB layer on top of it. So that means that you can scale separately the size of your storage, and you can scale separately also the size of compute you need for batch processing and also for interactive serving. Using that, we have a first lever which will be we can leverage the cost effectiveness. The second point will be on the flexibility we have with it. That means that if you want to store, if you want to restructure your data, it will be much more easier to do it with a file system, pseudo file system, than it will be with a large scale storage, with large tables, with indexes and things like that. That's why this is more efficient, and it allows you to have a very fast moving strategy on that subject. That's also the point that if you start with data modeling in data warehouse, you will have long project definitions time. And that's why it's very simple to use it, to use that kind of things. And you can move very fast and define data products very fast. Does it answer you?
Yes, Vincent, thank you. As we have still some time, can I ask you a last question, please? And it is like, could you discuss the importance of data lineage in a lakehouse environment and the tools or practices that can help in tracking and managing it? What do you think?
The data lineage it's a very important point because as we see here, it's quite simple. We have few tables, so it could not be obvious that data lineage is a very important thing. But sometimes we arrive to customers that have started their initiative, and we see a huge mess of tables depending with dependence, and nobody can see. Nobody can say this table depends of this one. And also we have some issue. We haven't spoken about the data issue we can collect every day when user says, but sometimes we see people saying, oh, I cannot understand today why my data set is not, there are missing columns in it, there are missing values, there are some rows we had yesterday, we don't have it today. And without a strong data lineage, we won't be able to have data governance. You won't be able to give answer to the users about where the data comes from and finding the root cause problems for this data set. So that's clearly a point of don't start a Lakehouse initiative without using a tool for the data lineage. And as we said, the data modeling with DBT allows you to have the off-the-shelf data lineage. If there are tools that do better things, that can do some column lineage, that can do some things like that, but DBT is a good starting point if you want to start modeling data on the data lake. I see some question. Michael asked the performance compared to Spark and if we can use serverless pools. Yes, obviously, we've seen some. We can spawn ephemeral VM instance in Amazon EC2, for instance, if we stick with Amazon. We can also use some serverless resources like Lambdas to run DBT process because it's really made to work in memory. And if we compare the performance, because DBT is really made to run in a monolithic fashion, DBT is able to have a better performance than the distributed mode of Spark. That's what we see for if we stick with SQL transformation. Obviously, Spark, if you have some Python transformation, Python data frame transformation and things like that, Spark would be better. But we see that we see really very good improvement in performance when we take some Spark SQL transformation and we put it in DBT. So I really encourage you to test the DBT engine if you have some SQL transformation made on your data with Spark.
Okay. Thank you, Vincent. As we are running out of time, if there is more questions, we can, or you can answer it in the chat or later.
Yes, do not hesitate, and you can ask me on the chat, or you can find me on LinkedIn and start a conversation with me. Don't not hesitate to ask me more things. Thank you very much.
Thank you so much. It was very insightful. And see you. Bye.
See you. Bye.
So our next presenter is Marcin Gwozdz. He will talk about FerretDB from scratch, a truly open source alternative for MongoDB. So, Marcin, can you hear me?
Yes, I can hear you. Hello.
Okay, hi. So, it's up to you when you are ready.
Okay, give me a second. I believe you can see my screen now.
Yep, it's perfect.
Okay, so first of all, hello everybody. It's really great to be here. I really love the idea of this 24-hour meetup. So yeah, today I will be talking about FerretDB. I give you some introduction to the topic. So let's start. First of all, I do some introduction. I give you the information why we are doing this, the reasons behind FerretDB, and overall goal to create MongoDB alternative solution. And at the end, give you some highlights about one more community that we are spinning up. And let's start about me. So I'm Marcin, I'm located in Kraków, Poland, and for the last 9 years, I'm responsible for technical alliances, building connections between different vendors and just channel sales. So what is the most important? I am the open source enthusiast, and most of my work was always connected to open source product. If you have any questions or want to be in touch, just feel free to send me an invitation on LinkedIn. I'll be happy to provide you the answers after the presentation or just during the daily basis. I want to start with the statement. So working with databases should be as easy as possible. And what does it mean for me? First of all, developer overall experience should be good. So you should think about legal constraints, about vendor lock-in, about the details connected to how you're running your databases. It should be just easy. And this is the survey from 2022 from Stack Exchange Developer Survey. And you can see that developers like to use mostly open source related databases. What is the important information here? MongoDB is #1 NoSQL on the chart. And the question is why developer really like to use MongoDB. First of all, it's really cool. Yeah, as I said, experience overall is really great because people don't have to think about schema. Developers like to use query language, and it's document oriented. So there's a lot of different perks connected with that. But there is only one problem connected to MongoDB, is the licensing. Until 2018, MongoDB was fully open source, but then they introduced something what it's called SSPL license. Feel free to go to the link I published here. There is a lot of information about why people don't like SSPL license. In the end, it's just going. If you're using SSPL license products, you are just vendor locked in, and you are not using open source anymore. So we asked our users, future customers, about the constraints connected to SSPL. As you can see, there was a lot about legal issues, lots about vendor lock-in. Also, MongoDB is focusing now on MongoDB Atlas, which is really great product, but unfortunately not suited for everybody. If you don't want to use one of the biggest hyperscalers, you're just not able to use MongoDB Atlas. So a lot of customers also want to remain open source. This is an example of use from one of our partners at Sivo Marketplace. As you can see, it's still MongoDB available, but it's just an old and outdated version. That's why at some point people just started to looking for the alternative, something that they can use instead of MongoDB itself. So this was the beginning, and this is how the idea of FerretDB shows up. So what is FerretDB? FerretDB is basically a compatibility layer. It's written in Go, and it's designed to work with different databases as a backend. The most important part, we are fully open source. You can go to our GitHub, and you can just run FerretDB in whatever way you want to. It could be on-prem, it could be in cloud, everything. It's designed in a way to be as simple as possible and just let the developers focus to code, not on the database itself. As you can see, what we did, we took MongoDB drivers. They are still licensed under Apostol 0, and this probably remains because all kinds of tools that are connected to MongoDB currently just using the drivers, so it has to be open source. And we just removed the whole SSPL part. FerretDB is a translation layer. And at the beginning, we decided to use PostgreSQL as a backend because we didn't want to create the whole new databases. It took time. We focus on something what is already on the market, and it's fully open source. For us, MongoDB compatibility means that if possible, the new database should behave exactly the same like MongoDB. So all kinds of tools, ecosystem, and applications that people are already using with MongoDB supposed to work with FerretDB in the same way. Here you can have screens from my personal environment. I'm using Mongosh, and you can see that it's connected to FerretDB. From my Docker desktop, you can see that there is a Postgres and FerretDB container running. FerretDB is on port 27017, and it's then there is a screen from my MongoDB Compass just connected to this port, and it's logging as yet another MongoDB 6 community instance. So from the MongoDB Compass, it's just another MongoDB instance connected to the application. Why we decided to start with Postgres? First of all, fully open source, but also Postgres is currently one of the hottest databases around on the market, and there is a high number of specialists, high number of companies that are providing different flavors and services around Postgres. And really important for us was already JSON compatibility, because FerretDB basically is taking binary JSONs and translated to JSON-B, then stored in Postgres. There is a nice blog post around that on our site, so feel free to go there if you're interested about details. As I said, different file flavors. So yeah, depends on your needs, depends on your use case. You can just took whatever you want to and decide to run. FerretDB is just a separate container you can put on top, and we are transparent for Postgres. But Postgres was just only the beginning of our journey. during the work, we started to just talking with our community, and then our own friend from SAP started to working on SAP for HANA Handler. So this one in long terms will be extremely performant replacement for MongoDB. Also, we received a lot of requests from people who just want to run applications with MongoDB query language, but with small footprint on Raspberry Pis and other home devices. So that's why we decided to implement SQLite as one of the possible backends. Going back to the survey, as you can see, MySQL is the most demanded database that developers like to use. So currently we are also with support of the MySQL community working on Handler for this backend, and it's almost done. I believe soon will be also available there as just yet another backend for MongoDB creation, MongoDB compatibility. Some examples of use of applications. Basically, we're working with different stacks that are already using MongoDB, also frameworks. So yeah, what is important for us, just you as a community should try FerretDB, give us know everything is fine. If we're supposed to fix something, just let us know. We are a community-driven project, so all kinds of examples and use cases that are important for you are also important for us. Our roadmap is public available, so anybody can vote for the features that are missing or the functionality that is needed for its project. Two examples of use of FerretDB when somebody decided to start with MongoDB but then switched to FerretDB. One is Enmeshed. It's an application focusing on digitalization of documentation approach. So yeah, it's easy to just swap the information between different companies by using in a secure way by using Enmeshed. And here is information how they decided to switch from MongoDB to FerretDB, mostly because of the legal issues and legal aspects that were bring from their customers. They're just looking for fully open source alternative instead of using SSPL. And FastNetMon, it's a product especially for telco market to prevent DDoS attacks. Also, there is a really nice blog about why they choose MongoDB first to store the data for the configuration, and then why they are looking for replacement and start using FerretDB. In many cases, currently we are working to complete switch from MongoDB to FerretDB for all of their customers. If you want to learn more or find more information about FerretDB, feel free to go to our blog, visit it, and there's always a lot of information about our latest partners or latest technology stacks and guides how to use the technology stacks. Here you can find an example with Pulumi, how to use FerretDB with Pulumi in Kubernetes environment. As we are on AIP Day, also there is a big question of what to do with FerretDB and AI. Yeah, first of all, we want to implement vector search. It's already on our roadmap. We still not decided how to do that yet. So yeah, if you have any recommendations, just feel free to ping me, and I'll be happy to connect it to our engineering team. And of course, we are also thinking about PostgreSQL flavors with already AI existing connectors or focus that, yeah, FerretDB could be yet one more connector to this kind of database that just provide MongoDB workflows. To sum up everything, FerretDB currently is on 1.20.1 stage. It's production ready. There's a lot of frameworks and CMS that are already working with FerretDB. If you want to start and try it really fast and quickly, you can go to one of the managed service providers who are already providing FerretDB as a service just to provide MongoDB alternative solution. And what is the most important for us, FerretDB is a community-driven project. So yeah, we are listening to you and we are trying to just fulfill your needs. Currently, we are strongly working on version 2.0. I hope it will be released soon, and this will be much more performant and much more feature-rich version of FerretDB than the one that's existing currently. To going back to one of the first slides, FerretDB is a tool that you can use the language you like to use, so MongoDB query language. We are focused on backend support by proven vendors and communities, and everything is fully open source, so we don't have to feel fear about legal constraints or all this kind of connected stuff. We invite you to our community Slack channel. Yeah, it's a great place where you can start a conversation and just ask any question, discuss with other team members. There is also a nice place where you can just try for free FerretDB. It's on Sibo clusters. You can spin up for 2 hours FerretDB and just do whatever you want to, just test it. And yeah, it's completely free for you. Last but not least, I want to mention about the database community, because FerretDB is just the beginning. In long term, the overall goal for the team is to create and establish a standard for NoSQL databases. It is something that it's missing currently, so we want to be sure that something what is similar for SQL for almost 30 years now, also will happening in NoSQL world. So every 2 weeks we are asking experts around the world from NoSQL world to provide the presentations, and we are building a community to establish the NoSQL standard in long term. Okay, that's all from my side. If you have any questions, I'll be happy to answer. And thank you for listening. Feel free to join our Slack one more time, or just connect me on LinkedIn.
Yes, Marcin, we have questions from our viewers. First one is, how do you scale the backend? Can you use multiple PG servers to distribute the load? That's the question from Vincent Heuschling.
Yeah, so we're still working on this part. There is a open issue about replication and sharding, for example, that we are not decided the way how to go yet. But if you already want to use FerretDB in big environments, you can use one of our partners, for example, Stagres. It's already full guide how to use Postgres operator with different add-ons to just provide a reliable and good environment for scalable environment for FerretDB.
Okay, we have one more question from Sam Bogo. You mentioned that 2.0 will likely be much more performant. What is the current performance of 1.2.1? This MongoDB community, this native Mongo community edition, sorry.
Yeah, sure, no worries. So basically, we are not focused on checking the performance. We are quite sure that it's not just enough performance, because first of all, we had to choose. Do we want to focus on use cases and on features that our people were looking for, or on the performance itself? When after more than 2 years of working with FerretDB, we already have special use cases. So now we can focus on the performance part. We'll be happy to provide you more information from our engineering team after the talk.
Great. Thanks.
Okay, I have 2 more questions, if you allow me to. First one is, why did you decide to create FerretDB? What was the main reason?
Yeah, the main reason was just request from the market, to be honest. The whole idea of creation of FerretDB starts because 2 of the founders was in the mountains, was discussing about possibilities and databases itself. And at one point, they realized there is no true open source alternative, because there are some other companies who are providing MongoDB-like experience and MongoDB-like query language, but none of them is open source. So the main reason, because all of us are just in FerretDB are open source believers, we just wanted to be sure that people have open source alternative and can switch from MongoDB to something which is fully open source. So let's say this is the main reason.
We have one very interesting question from our viewers and our board member for the user group, the board of directors, Martin Otto. How does Ferret make money?
Yeah, so we are yet another open source, let's say, company. We are providing support. We are providing consulting services if somebody wants to move from MongoDB to FerretDB, and of course, some of customers just looking for sophisticated features that is not needed for the whole community. So if somebody looking for, let's say, specific kind of authorization, we can just code it and do it for as a part of consulting services.
Thank you. And Chris Foya asks, FerretDB looks like an excellent alternative to MongoDB. Adoption and market share are some of MongoDB's greatest strengths. How do you plan on capturing and converting that user base?
To be honest, users just looking for alternatives. So the market is big. And if somebody just want to try FerretDB, there is also a whole migration guide and scripts how to check if FerretDB works with your particular MongoDB use case. We are just focused on the people who are just looking for an alternative, and it's plenty of them. Let's say when we decided to start FerretDB at the beginning, when only the POC shows up, it immediately received more than 1,000 stars on GitHub. Currently, it's more than 8,300 stars on GitHub, more than 360 forks. So people are just looking for alternative constantly.
Okay, and I think you already answered that or talk about it, but why PostgreSQL as a backend was your first choice?
Yeah, so huge supportive community, huge number of providers who are already focused on Postgres. We are not PostgreSQL experts. We are only focused on the transition layer, which is FerretDB. And for us, it's natural that at some point somebody needs to tune Postgres as well. And the extensions and possibilities of extensions, it's really great in Postgres. In my personal opinion, it's also the most important database around there. So currently, it's really great.
Okay, so do you have any other questions? Somebody? Okay, can you tell me more about your future plans and how do you see development in the AI context of data?
Yeah, so in general, AI is a quite hot topic currently. Everybody is focused on that. So we also have this in our mind. What we want to be sure that we are providing performance enough database to support all of different AI and LLM cases. So with FerretDB 2.0, I believe we'll be at least close to support different use cases connected to AI. And everything is community driven. So feel free to suggest us what kind of Postgres flavor, for example, it's good from your perspective for AI use cases. For example, how vector search is important for you currently. We'll be happy to put it on the roadmap. We'll be happy to prioritize it. Anybody can have access to that and can vote that this is something that they are looking for. And if yes, we'll be happy to do that.
Thank you. And our good friend Jan-Willem Steur asks, a huge number of IBM software suites like engineering lifecycle management and IBM Maximo application suite are only available when MongoDB is installed as a core dependency. What does this mean for IBM MongoDB?
It's a great question, to be honest. I think I'm not able to provide the answer right now. Yeah, but I'll be happy to connect after the presentation and so just do the research and discuss this, because yeah, it's really nice.
Okay, so we can just answer in the after that. Sam Bogok asks, would vector database extension be possible? We are currently using Chroma for this, and it would be interesting to see if FerretDB could be a common layer across Chroma and PostgreSQL. Sorry.
Yeah, we are doing a lot of joint blog posts and this kind of things, and I think this is a great area to explore. So we'll be happy to do that after the call. Maybe we can create a quite nice guide for people who are looking at this kind of solutions.
Okay, thank you.
Yeah.
So if there is no any questions, we can just go ahead. Or
okay, so yeah, thank you for the opportunity of talking about FerretDB. Feel free to connect on LinkedIn. I put it on chat right away. So if anybody have any questions, just feel free to ping me there.
okay, thank you very much, Marcin, and we are
thank you.
Going
Bye, guys.
forward.
Thank you.
Andrew, can you hear me?
Hey,
Andrew?
yeah, I can hear you.
Hey, so this is Andrew Jones, our next speaker, and he will speak about data quality, something really interesting these days. And data quality prevention is better than the cure. So, Andrew, when you are ready.
Okay, I'll share the screen.
Okay. Yep, it's fine.
Okay, ready? Well, thanks everyone for joining. So, data quality. I imagine most people on this call know why data quality is important, right? Like, we deal with poor data quality a lot. We feel the impact of it as we're working with data day to day. So most people on this call probably understand why data quality is important. What I think is interesting at the moment is that people outside of kind of our group are starting to understand the importance of data quality. You've got organizations, they want to use the data to power key business processes. They want to power features in a product, maybe with ML, but ultimately drive revenue. They're trying to do all these things, and they are struggling really to do so because of the poor quality of the data. Sorry, it's a little chat. Yeah, struggling to do so because of the poor quality of the data. Many organizations are kind of able to work around poor quality data, and that's good they can do it, but not really able to prevent poor quality data. We're not really able to tackle it at source. So I want to talk to you about today is I want to show you really how we can prevent data quality issues at source, because ultimately, when it comes to data quality, prevention is better than the cure. Let's start with a stat. It came from a report from Nash Grad last year. It's a digital leadership report. So they surveyed a bunch of business leaders, and they found that 64% of organizations think that data is a way to deliver competitive advantage. yet only 1 in 5 are using data to deliver increased revenue. And when I saw this report and this kind of stat, it's interesting how it made me feel. So actually, if you like, feel free to take a minute to think about how you feel reading something like this. And if you like, you can put it in the chat as well. So just take a minute to think, yeah, how does a stat like this make you feel? So for me, it kind of made me feel maybe a bit embarrassed, really. Like this gap between the aspirations of organizations and the reality of what they can do with their data is just so large. And maybe I feel partly responsible. I've been working data for a long time. And I feel like we as an industry should be doing a lot better than this. Like it should be easier for organizations to deliver increased revenue, for example, based on their data. It shouldn't be that difficult. So trying to think about why is it difficult? And I think a lot of it is down to how we deal with our data and the quality of our data. So we probably know that working with poor quality data is difficult, it's time consuming, it's expensive. And Gartner has a stat, as always, if I reckon it costs organizations nearly $30 million a year. Don't know if that's true or not, but I think being able to demonstrate how expensive it is a good thing to do, a useful thing for us to try and do. Because if we can do that, we can get the resources we need, and more importantly, the alignment we need to try and improve the quality of the data at the source. And last year, I came across a nice way to try and do that, to try and demonstrate the cost of poor quality data. And it's called the 1-10-100 rule of data quality. And it looks like this. And all it's saying really is that the earlier you manage something, the cheaper it is, right? And that feels like an almost universal rule. If you think about healthcare being the obvious example, it's best not to get sick at all if you can help it. If you do get sick, then having access to good quality healthcare quickly is better than it's a good thing to have. If you don't have any of that and you don't get diagnosed, if you don't get diagnosed and you don't get treatment, the outcome's going to be worse. So clearly this applies to healthcare. An example a bit closer to us might be software engineering. So if you think about software engineering, you're writing code, you write unit tests for your code, you have code review, you have continuous integration, all of this before your code goes into production to try and prevent bugs making their way into production. But then bugs still make their way to production, it's not perfect. So then you have in the remediation area, you might have things like observability, the ability to develop back quickly, incident management processes, all those kind of things fit in remediation. If, as a software developer, you're just doing nothing, you're just chucking code out, no review, no tests, no observability, again, the outcomes are likely to be worse. It's not likely to lead to a good outcome for the application. So it applies to healthcare, applies to software. You can probably think of other ways you could apply it in the world, probably many examples. And it also applies to data quality. And actually, it's been used to describe data quality, or was first used to describe data quality over 30 years ago. So it's not a new idea. And yet, many of us are mostly working in the remediation stage. Very few of us are looking at prevention. So let's go through the pyramid kind of bottom up first and just talk about how each layer relates to data quality. We'll start with failure. This is where you can't do nothing to try and deal with data quality. And you might have data, you can't really use it, it's not really accessible. So you might try and use it and just give up. And then this $100 includes the opportunity cost for a company, the inability for it to meet their strategic goals, the lack of competitiveness they might get in the market due to that. All those things come under the $100 cost of just doing nothing with data and doing nothing to improve quality of data. But I say many of us on this call, we're probably doing something. So we are mostly working in the remediation stage. These are things like observability, maybe using something like Monte Carlo or CPlay, Metaplane, or one of the many, many others. Maybe you're writing tests in DBT or Graph Expectations or Soda, maybe get alerts. So at least you're aware of the impact of data quality and poor data quality, and you're trying to do something about it, trying to recover quickly from the impacts that it might have when you do encounter poor data quality. So I mean, it's good. It's certainly better than nothing, but there's still quite high cost to this. Often the observability and the alerts we're getting, they kind of fire when data's already landed in production, might already made its way into reports or ML models or downstream. So it's helping us get alerted quicker, but the impact's still quite wide. It's still quite expensive. Then when we typically try and resolve the issue, we tend to just implement workarounds in the ETL. We don't often go back to the source and try and fix out the source. It's normally too late by then. So we implement workarounds. So I'm thinking things like another coalesce, a case statement, and if null, those kind of things. And we keep adding that to our ETL. Doing it once or twice is fine, but we keep doing it. And that means that ETL gets pretty complex, it gets more expensive, and that complexity then leads to further data outages. And as we have more and more data issues, our users start to lose trust in the data. And once they lost trust in our data, it's very difficult to win it back. So still quite high cost to dealing with data quality issues in the remediation part of Pyramid. What about prevention, where it's cheapest and most effective to deal with poor quality data? Well, like I said, many of us aren't really doing much here, but really this is a lot about what we talk about, things like shift left, catching issues at the source, maybe even before they make their way into production, so in the code, big producers are writing. If we can do that, the impact is a lot less. Maybe the issue doesn't leave the source system, therefore it doesn't impact your entire ETL and all the downstream stuff, just stays in the source system. And particularly if we can prevent data quality issues from being deployed to production, we can prevent a lot of common issues occurring. So I'm thinking things like schema changes, data type changes, those kind of obvious things. They really should be preventable, and yet many of us still have to deal with them regularly in our day-to-day job. So like I said, many of us aren't really focusing too much on prevention at the moment. So for the next few slides, I want to talk a bit more about prevention, how we can prevent data quality issues at source. So if we take that pyramid and kind of overlay it onto like a typical data platform, it will look a bit like this. So failure, quality issues go into production applications all the time, and that's not a great place to be. Mediation, that's kind of things within the data pipelines. Maybe our data engineering or analytics engineering teams are building that observability and those alerts. But when it comes to prevention, you can only do that at a source. That's the only place you can prevent data quality issues. So again, probably most of us are like, yeah, that sounds great. But how do we actually do that? How do we prevent data quality issues at the source? And maybe a more important question, how do we incentivize data producers to put more discipline into the production of data to prevent data quality issues happening at all? Well, I think first we need to assign responsibility to the right people in the right place. And I think responsibility should look a bit like this. So the source data that comes from often product engineering teams, so they should be responsible for that data. Now, in most organizations, that's not the case today. They may not even realize they are data producers. They just work on applications, and then they might be somewhat aware that behind the scenes, there's like an ELT process sucking data out of a database, or change data capture process, or something similar. They're not really seeing themselves as data producers. They just work on applications. And yet, they are the only ones who can impact the quality of the data. They're the only ones with the ability to change the data. They're the ones who know how it might change in future and can design that into their systems. So really, they are the only ones who can impact the quality of data, and therefore they should be responsible for the quality of that data. And again, in a group like this, probably many of us are like, yeah, sounds great, but how do we do that? How do we incentivize product teams to care about data quality. And that's normally the part where we get stuck. It's difficult to move past that question. But we can, I think. But to do so, there are at least 2 problems we need to solve first. First problem is that there's a complete lack of collaboration between those producing data in our product teams and those actually using data to drive some sort of value. So BI teams, data science teams, other data consuming teams, but actually using the data to drive some kind of business value. The gap between them is just so large. They never talk to each other. They don't know what each other's doing. Like I said, producers probably don't even realize they are producers. They almost certainly don't realize the impact their changes are having on downstream applications. As a consumer, you don't feel like you can go and talk to the engineering teams to say, hey, I need better data for these reasons. You might not even know who actually owns the data upstream, like before data engineering. So the gap is just too large. There's no collaboration, and therefore, why would, for example, the producing teams care about the consuming teams? If I don't know anything about them, it's just not on their radar. We need to encourage great collaboration, bring these consumers and producers a lot closer together. That means people like us, as data producers, we need to be good at articulating value of data. Why is it important to the organization? Why is it important what we do? Where does the value come from? And if we could do that, articulate it well, talk directly to the data producers, explain to them problems being caused by poor quality data, then we can start to incentivize them to provide data that actually meets our requirements. The second problem we have is the lack of interfaces. So like I said earlier, a lot of the data we consume, it comes directly from the database through some sort of ELT process, some kind of CDC process, change data capture, whatever it might be. We're basically building them directly on top of their database. Now, that database should be expected to change, the application database. And yet, often we're caught out by that change, by a schema change, by a change data type, by a table being dropped and replaced by something else. It keeps catching us out, even though that shouldn't be unexpected. And the reason it catches us out is because there's no interface between the changes they are making upstream and the data we're building upon downstream. So we need to move to a way we can consume data via an explicit interface. And actually, interfaces are very powerful. That's why we see them everywhere in software engineering and data engineering. So think about a Python library you're using, say Pandas or something. You're using a public interface of that library. And you know, if you keep using a public interface, it's not going to change between minor versions. When they do want to make a change, there'll be a new major version published and some sort of migration path, but you can migrate that in your own time. It doesn't take everything in your day-to-day work. So you see interfaces for software libraries. You also see interfaces in APIs. Think about an example like Stripe. They have an API. Many companies build on top of that API, build integrations with Stripe. And that API is very stable. It rarely changes. And yet behind the scenes, Stripe must be changing all the time, right? They must be adding new features. They must be scaling their processes, scaling their software, changing all sorts of things behind the scenes. But as someone integrating with Stripe, you never know or care about that. You're building on top of a stable interface, and you can do that with confidence. And yet for data rarely comes through an interface. And I think that is one of the main problems we have with data and data quality. So we need an explicit interface. This interface helps enable that greater collaboration. It helps assign responsibility to both providing the interface and both consuming the interface. And in data, we can use the data contract as the interface. And if we do that, we can end up with an architecture that looks a bit more like this. So now we have good quality data coming through a data contract that's been designed to be consumed and built upon. Now, the nice thing is that if our data producers are providing good quality data up front, we don't need to do so much in data engineering, maybe nothing at all. That data can be built upon directly by the consumer to actually deliver value from our data. We might still want, we do still need to do some data engineering, clearly. We do still need to join data from different domains, different teams, different groups. But that shouldn't necessarily be a requirement to use the data. So kind of remove that bottleneck. There's another added benefit. So if we go back to our pyramid and look at the kind of options we have in each layer. Failure, not a lot we can do there. Should try and do something. Remediation, that's around observability, the alerting, the testing we do. Better than nothing, still quite costly. But to really reduce the cost and to really actually improve quality of data rather than just work around it, we need to be thinking about prevention. And to do that, we can use something like data contracts. It's only when we start thinking about prevention of data quality issues that we can actually use data to support the organization's goals of using that data to drive increased revenue, whether directly or via ML or whatever it might be. Because when it comes to data quality, prevention is better than the cure. Thank you.
Great, Andrew. Thank you so much. If anybody has a questions, now is the time to ask them. As we are waiting for some of our viewers, I can ask you first question. And it is, how do we incentivize data producers to take one more responsibility and accept shifting left? What do you think?
Yeah, that's a good question, really, because that's kind of the key, really. The key is to align incentives to talk to data producers and make them accept they have to take more responsibility. So really, it's kind of a people problem. So it requires a lot of talking. But actually, if you look at any organization that's kind of any size, you always have multiple teams that need to work together to deliver something that's greater than the sum of their parts. Right? There's always dependency between teams. It always needs to be alignment. So what I normally recommend is make sure data becomes part of those kind of alignment discussions, like priority discussions. If it's important for your team, make it important to the organization. And then engage with your organization's existing prioritization and alignment frameworks, OKRs and KPIs, or whatever you might use at your organization. Like I said, to do that, you need to be very good at articulating value you're providing data, which is a good thing to do anyway, right? But you need to be good at articulating value and explaining why you need another team to do a bit more effort so you can provide a better outcome. But yeah, people problem rather than tech problem.
Thank you. Yeah, and as you are part of Vital Technical Steering Committee project, can we talk a little bit for data contracts? I think it's some of your favorite topics.
One of them, yeah.
Yeah. Can you share some hot insights for what's happening with data contracts and from now on?
Yeah, sure. So data contracts, like I mentioned, it's really the way we can start going to prevention. So it's really key for a lot of this. And it's always been this for me. Like, it's the reason why I kind of came up with data contracts like 4 years ago or something. It's because I wanted to prevent issues, data quality issues affecting production. Because at my company, we are using data for more and more important things, and it wasn't sensible for them to keep breaking. And clearly, that idea is taken off a bit, and there's a lot of people talk about data contracts. There's now the standard, which I think is great, and yeah, like I said, I'm involved with that. I think the data contract is quite a simple idea, but it just enables so much just by kind of applying that interface, by having a way to describe data, by having a structure around kind of metadata of the data. It's a simple idea, but it's so powerful. And it's great with standard as well. Like, helps us unlock that power potentially. Like if we get more adoption of a standard, people can build tooling on top of it. And then I, as someone who wants to adopt data contracts in my organization, I don't have to build it all myself. I don't have to build a data catalog that builds adopt data contracts or some privacy and security tooling. These are all kind of things I built in my organization from scratch. But if a standard and ecosystem around that, and we can, it's a lot more interoperable. We can just pick and choose what we need to implement organization and bring that in. It will just work for our data. Doesn't care how data is structured, as long as the contract describes it, we can build something that works with it quite easily. Let's look through the chat here. I saw a comment from Chris about the opportunity for growth. And I think that's a good way of thinking about it as well. Like if you're on the consumer side, you're working BI or data science or something like that, and your goals is to obviously you're building reports and you're building models, things like that. And that's fine, you can do a good job there. So if you could start thinking wider, looking at the whole organization and think about how can I change it, because I think we can get more value from my data if I do so, it's a great opportunity of growth for yourself. It allows you to go and talk to people across the business, increase your visibility. It allows you to demonstrate kind of your own impact across the whole business. And that's certainly how it works for me. Like I was a senior engineer, a tech lead of a really small data platform team in my company. There's about 6 of us. And I just kind of decided like I wanted to try and tackle quality issues at source, because I realized data was important for the company. It was in the strategy, it was everywhere. And I didn't do it overnight. It took a long time, took a lot of talking. Didn't do it on my own either. Had a really good PM who I worked with. She was great. But like it helped me grow so much. And it's been great for a company as well. So yeah, it's a great opportunity to grow, great opportunity to provide value and increase your impact across the organization.
Thank you. And what do you think? What is the natural path for implementing data contracts for the big companies, so not only for the big companies? How they can implement it? Maybe the easiest way. Okay, let me say that.
I think that's a good question. I think sometimes people hear data contracts or see something like this and I feel like it's a very difficult thing to get started with. But it doesn't have to be. You can start off small, you can start off with one particular data set, you can build a very small POC implementation of a kind of platform for data contracts or data contract implementation. We did that, it only took us like a couple of weeks really to do a POC, and we did that while working with a data producing team. So we got their feedback, which helped them feel like they were kind of helped. They had a sense of ownership over the solution as well. All we did really was allow them to find that contract, and for us it created what we called the interface, which is like BigQuery table for us. We're using Google Cloud, and you just take the contract, kept the BigQuery table in sync, and made sure you can make breaking changes to that table. And that's what it was really from the start, and obviously build it up from there. Like I said, it doesn't have to be a big thing. Like me and my team were quite a small team. We were able to do it quite quickly, building on what we already had in the organization, which for us was our infrastructure as code platform. But yeah, start small, build upon whatever you've already got in your organization. There's also many startups and companies add in try and build things around data contracts, trying to build data contracts into their existing products. So I think it's going to get easier over time if you haven't quite got the engineering team that I had, for example, where I could build something myself. So probably going to get easier over time, but don't view it as like a big thing. Try and start small. That's that question in the chat.
Yes, I can read it for you. Simone Dominelli asks, in most organizations, the reality is source, products. where there is a long chain of producers and consumers often losing sight of the real sources. Can contracts work without implementing across the entire chain, aka shift left until where? And also, the notification chain can become really large. How to balance responsibility areas without siloing?
Oh, that's a really good question. I like this question a lot. One of the things I'm trying to do alongside that contract is really challenge the assumption that we need this long chain and trying to reduce the amount of steps. I think every time there's a step, like a handoff between a different team or different group or whatever it might be, there's a cost to that. And like you have alluded to some of the costs there in terms of like the chain of responsibility, who to notify, who actually owns the thing, where it actually break. It's a huge cost every time there's a handoff. So I'm trying to reduce that, which I kind of alluded to a bit in my slide about like how maybe you don't need to go for the engineering every time, you just have producers talking to the consumers directly. So I think if you can, it's best to try and reduce that chain. If you can't, then I think, shift left as much as you can. I think the most value you get from it is shifting left right to the source. That's how you can prevent data quality issues. If you can't do it at the source for whatever reason, as close as you can is better than nothing, probably. So a good example of that is, I'm talking a lot about product data, but if you think about something like from Salesforce, we can't go and implement things in Salesforce. What we can do is create a contract close to that, have the Salesforce data contract owned by the Salesforce admin team, or whoever it might be looking after Salesforce. And that's as far left as we can go. So at least they feel like responsible, for adding the make change to Salesforce, so they full responsibility for the quality of data that comes out of that. So yeah, I think that's two things. Reduce the chain if you can, go left as far left as you can. In terms of siloing, that's a good question as well. And this a lot comes down to, a lot of the ideas kind of borrowed a bit from data mesh, but you don't have to go that far. But what I like to think about is data contracts being like boundaries of ownership. So if my team is providing data to another team, I'll put a contract on that. If there's data, like there's a pipeline in my team that's just being used by my team, I probably won't put a data contract on that. It's probably not necessary. But if it's going to another team or another group, another division, or another domain in data mesh terms, that's where it's most useful to put data contracts. So that the other team can build on confidence and I know who's responsible for what parts. Does that make sense? I hope that answered your questions. But
Thanks. Yeah, no, absolutely. Maybe I just have a very fast follow-up. If you were to start from scratch in terms of strategic implementation of contracts, would you go kind of left to right, as in trying to implement it as close as source, and then you have a kind of a first contract, and then if you have another downstream, then you have a second contract and third contract? Or would you like start at bottom and then kind of work it backwards, right? What do you think?
Yeah, so for me, I did that. I started at the source because that's where I felt it had most impact, and because that's where you have to have the kind of the change of ownership from software engineering to data engineering. I mean, even actually today, if I'm honest, we haven't done much data contracts downstream, like from different data engineering teams, or from data engineering to like analysts and things like that, to data scientists. Most of our efforts still being on the source, and that's where we've seen most of the impact. So yeah, started right from the left.
Thank you.
Thanks, Andrew. And can you share with us some of your next events? What are you doing? Are you writing something like newsletters or?
Yes. I have a daily newsletter. If you'd like to join, go to my website and justjoins.com. And I say daily, it's 5 days a week, but turns out I didn't want to do it at weekends. But every day I write something around data quality, data contracts, data platforms. You can also find me on LinkedIn, where I also post quite a lot. And a link to my LinkedIn is on my website as well. In terms of upcoming events, I've got a couple of podcasts. One came out yesterday. I'm recording another one next week, I think. So that's coming out soon. So yeah, feel free to type my LinkedIn, and you'll get notified about my podcasts. I have my book as well, I should mention. No more books planned at the moment, but I might be doing things like workshops later in the year, so keep up for that as well. And yeah, if you do, feel free as well just to reach out to me on LinkedIn. I'm always happy to chat about it in more detail, ask me more questions, either privately or quickly. Happy to chat more about data contracts or anything related to data quality.
Thank you. As I'm your subscriber, I can tell that it's pretty cool stuff. Your newsletter is pretty cool. Okay, so I think it was a great presentation. So if there is any more question, people can ask you by LinkedIn or via your website, and we are going straight ahead with our next speaker. Thank you, Andrew. Thank you very much. So, okay. Our next speaker is Santosh. Santosh, can you hear me?
Yes, I can. Can you hear me?
Yes, I'm hearing you. He will talk about from slums of Mumbai to Germany, my story in tech. Santosh?
Yeah, I think
when you're ready.
Yeah, just a second. Perfect. I think it was just different camera. Yeah, so let me share my screen. How I can do that, share screen. And okay, can you see my slides?
Yes, perfect.
So first of all, thank you so much for this opportunity. I mean, I'm of course a little bit scared sharing my story here. It's yeah, I mean, yeah, it's a little bit emotional for me as well. So yeah, so I've been like in tech for almost 15 years, and this is my story, like how I started and then how I reached where I am right now, and yeah, my struggle in between. So let's go ahead and get started. I'll just introduce myself first. So my name is Santosh. I'm a senior software engineer at Celonis. So yeah, I work from my home in near Hamburg. I'm a Google developer expert for Angular. So, and also I'm a GitHub star. I'm part of a program called NX Champion, which is about open source tool called NX. And apart from this, I'm also a co-founder of a community called This Is Learning, which I run with my co-founder, Lars, who is from Denmark. And we also run a podcast called This Is Tech Talks. And like in case some of you, if you're interested to join us as a guest, you can always send me a DM. I'm on LinkedIn, X at Santosh Yadav Dev, and just send me a DM and probably we can schedule some episodes. We already scheduled some, published some episodes this year, and yeah, we have many more planned. So feel free to just send me a DM and we can do something about it. So this story started like on 13th November 1996. Yeah, that's when I was born, and this is the picture from the slum where I was born. So it's like it was a slum in Mumbai, and I lived most of my life here. So it's almost close to 30 years. Living in a slum is hard because it's not easy to get guidance, like what you want to study, what you should study, and especially when your parents are not that educated. So, of course, that was me during school days. So I was like, okay, I'm going to school, but I don't know what I want to do after after I complete my school. And unfortunately, things didn't went well. I was expecting good grades, but I couldn't get the grades which I was expecting during my school. And then, of course, I was struggling to get admission into the college because I was aware of only two things. So in India, it's like mostly you go to science, or in case you want to like become engineer or something. So people told me like go to science so you can have a good education, and I couldn't get it because of my grades. But I think someone had a different plan for me. So I ended up at engineering college for diploma, and I got the admission there. So I was like, okay, I generally call myself as an accidental engineer because I was not sure like this is what I want to do, or even like I was not aware this is what I'm going to do in future. So just landed up there because one of my father's friend actually recommended us to go to this college and see if I can get admission because they also knew some people there. So that's how I ended up there. So college life was, of course, hard coming from not native English speaker. So it was really hard for me moving to college where, like, of course, all subjects are in English. Of course, English is not my first language. You might have guessed by now. So I struggled a little bit during my first year, but I decided to do it. I mean, I don't want to screw up this time because I did it during my high school, right? So I somehow completed my first year, but second year came with the bad news. My father lost his job, so I was not aware of it, of course, for some time. Then I realized, okay, there is something wrong because our parents try to, they try to actually just shield you, and they don't want to actually bring this bad news to you, right? So, but my father decided to put it in a different way. He said, okay, you're doing diploma now, so what you can do is start looking for a job next year. And of course, I was like, oh no, I want to study. And I ended up crying like entire night. I couldn't sleep. And of course, my mom noticed and she convinced my dad to actually do it. I mean, she said, no, my son will study further. So he wants to do it. Let's make it possible. I mean, yeah, it was hard, but my father did it anyway. So he took some support from his brothers and I continued my study. Finally, I completed my bachelor's as well, thanks to like some help from my uncles, and completed my engineering. I was excited. I was like, okay, now I'll get a good job. I'll be able to support my family. But yeah, again, someone had different plans. Everyone knows the Great Recession, how bad it was, and there were no jobs, literally no jobs. So it was hard. Like we used to usually go to this job agencies, give our resumes. The way we used to do it in 60s, right? So that era was back again. I've never seen 60s or 70s, but I think that might have been the same scene. So we tried hard, but couldn't get a good job. But somehow I was able to start my professional career by getting a job at a small startup. Salary was not that good. I just wanted to do it because I don't want you to sit at home and make sure, like, I'm learning something, right? I mean, getting some experience, but that turned out to be just bad news for me again because the boss was very toxic. So I decided to move away in 9 months because I was like, okay, I don't want to waste my time here. I'm not learning anything, but I'm there are so much unnecessary pressure which this job is bringing. So I decided to move away and I resigned from that job. So it was just like last night I resigned, and then the next day I was like, okay, this is my last day. So yeah, that happened. But I think that was a good call. I mean, I learned that, okay, being at a toxic job is better than just sitting at home and having that peace of mind which you really need to decide what you want to do in future. And that was the great decision, I would say, one of the best decisions I took. And next few years, of course, I decided to do job hopping, right? Because that's what I want. I wanted money. I mean, that was the time, of course, I was struggling financially. My family was struggling financially. I decided to do job hopping. That's most people do, right? And then they want to increase their salary. So I ended up changing 3-4 jobs and finally landed up at a startup. And I think that was a decent raise, right? So I got more than 100% of raise because my salary was already low. So I reached at some point where I would say, okay, this salary is what I think as an engineer I should make. And I thought okay, now this is the time. Now I'll be able to change everyone's life, including my family's. So the job continued. Job was going well. I started saving money, after 3 years of working somewhat. Not odd jobs, of course, engineering, software development jobs. I was saving some money for the first time. And we were expecting our first kid. So I was like, okay, these things are going pretty well. I mean, even I was getting promoted. So I was promoted at the job as well. And first time in 3 years, I was really enjoying my job. And I was like, okay, now things are going well. I think I don't want my daughter to actually grow up in this slum. So that was the whole plan. And I was like, okay, now we can actually move to probably a good society or good building where we can live. But yeah, then something happened. Yeah, there was a setback. My wife was like, okay. I was called by a doctor suddenly and said, yeah, there's complication. We need to do like emergency surgery now. And they said, okay, probably your daughter may not survive. So like, but that was necessary to save my wife. So I said, okay, let's go ahead and do that. So my daughter was born in 6.5 months. Yeah, 850 grams, and then there was no guarantee that okay, she will survive. But yeah, next we decided like we will fight back. And as you know, like life is not easy for any of us, and we decided to fight back. I took a lot of loans to pay hospital bills. It was like more than 10K in 3 months, which was not even like half of my salary. But yeah, I decided that I will do anything possible to like make sure my daughter survives. And my friends helped a lot. I took loan from the banks. After 3 months, I mean, I just realized like this is the first time when she was back home. And I remember like holding her in my hand, and I was like, I'm not going to give like I'll always keep close her to myself. But yeah, there were some positives which came. I mean, she was struggling, she was fighting for her life, but it gave me a strength like, okay, probably my plan is not going, things are not going as per the plan, but I'll make sure I'll do it. I started like working harder, but for time being, I was like, okay, what should I do next? But the job saved me probably. I mean, I started working harder, I started getting good raise, but I missed one thing, which was, of course, like spending time with my daughter. And suddenly she was 4. And I was like, what the hell? I mean, she's already 4 and I haven't spent enough time with her. So I decided to make a change. Of course, after this, I lived on paychecks for next 7 years, but I decided to make a change. So I moved away from my parents' house, and we had no savings, no house. One of my friends offered us house. Then in 2016, I decided to move to Pune. I was like, okay, let's change the city. Probably it will be better for everyone. And of course, in between to survive, I had to sell everything my wife owned. So I had to sell all the jewelry. But this was for a new fresh start. So I started a new job in Pune. And after I reached in Pune, and I was like, okay, I was just working 8 hours, to be frank. And in Mumbai, I used to just travel for 4 hours. So like going to office and coming back used to take me 4 hours. And in Pune, it was like I'm back in probably 1 hour. And yeah, so it gave me some free time. And then I started thinking like what I wanted to do when I was actually investing so much time in my in working at a startup. There were things which I wanted to do. For example, I wanted to write blog posts. I wanted to share I wanted to share what I learned. So I started learning Angular back in and start of 2017. And then within few months, I started getting good gigs for teaching Angular, because that was the time Angular 4, the version 4 came. And it was like everyone wanted to learn Angular. So I started getting good gigs. And I remember like buying the first bed for our family, buying a good mattress for the first time. And yeah, that's what I did around 2017. But over the years, like of course, around end of 2017, I realized that okay, now I think my financials are getting settled. I mean, I'm not like saving a lot, but I think I'm making enough for my family and what I need, right? So I started working. Meanwhile, I started working at Deutsche Bank, which was, of course, it was a good raise from my last salary. So, of course, I started getting enough money for my family to survive. And then I realized, okay, now when I was struggling or when I was going through the bad times, what saved me? Of course, my friends were there, but I started sharing my knowledge. Like I started teaching Angular. And how I did that, I mean, I just learned it for free. So now there are many more people like me who are probably struggling somewhere with their family, with their finances. How about now helping them? So I decided to go ahead and do something for the community. And that was the time I actually reached on the GitHub repository of Angular. I was like, hey, I think there are many contributors, but there are no contributors in top 100 from India. That was in 2018. Of course, now you will find some people. But of course, something bad happened. My doctor again got tuberculosis, and which was like, doctor said nothing to worry about, just 9 months of medications and she will be okay. But I decided, okay, this is not the perfect time. I think I should hold myself back. And I decided to focus on family. And of course, my manager was really nice. He said, yeah, focus on your family. Don't have to worry about a lot about the work. It will be taken care of. Just take care of family. And I realized that how important it is to have a good manager where you're working, who understands like what you're going through as a person as well. So I started finding time around 2019. So I was like, okay, now everything is settled. So what I want to do next? So I went to a conference in 2019 and came back home and raised my first PR. Like I still remember the date because that's the date which changed my life for future, for better, I would say. So 28th February 2019, around 5 years ago, I raised my first PR. Then started contributing to two repositories, NGRX and even Angular, and started speaking. So I started writing about Angular. I was like, okay, I'm contributing to Angular now. Let's also start writing blog posts. And I remember like around June 2019, I was already in top 100 contributors for Angular. And that was a big moment for me because that is something which I planned probably a year and a half ago. And then finally I was there. Meanwhile, I also got an opportunity to speak at a conference in Sri Lanka in September 19. And then I got nominated meanwhile for GDE for Angular. And 13th November, like that was my birthday, 13th November 2019, I became a GDE for Angular. Of course, it gave me satisfaction as well that, okay, I'm doing something which is worth, I mean, I'm getting recognized for the work I'm doing. And then I started contributing. I mean, I kept like doing the same thing. So start of 2020, I left my job. That was a complicated relationship with Deutsche Bank after a few years, but I left the job, and then 2020 I got a remote job. I started now spending more time because I was not traveling anymore. I also paid most of my loans, but by the time around 60% of it. And this is around 5 years ago. Yeah, this is my daughter actually dropping me to my office. So this is my home office. Yeah, she was really happy. So we recorded this video. It's a great memory for me as well because now I could be with her 24/7. And so this was way back in 2019 at my house, which I had rented in Pune. So after working, I started working remotely, and of course I started getting more time. I kept then I left that remote job as well. Started doing consulting, started making more money, and this was the time actually. I said, okay, let's move away from the slums. And I remember posting this on Twitter on August of 21st, 2020. So we finally moved into this apartment in Pune. Finally, I realized that, okay, I promised myself something that I will change my life as well as my family's life. And I did that. So, of course, me and my wife we both grew up in slums. So this was an emotional day for both of us. And we remember crying a little. And then, of course, good news followed. I also became GitHub star for 2020. I was the first Indian to get this award. Getting recognized by GitHub was a huge thing. I mean, for me, especially when you're the first one, right, from a country like India, where you have millions of developers probably. But I was motivated to do more. Then after this, a tweet of mine, which went viral, many people asked me, one of my friend Dan, who works for Microsoft, he asked me like, I want to share my story. Of course, that was very difficult. I mean, I started writing this. I remember like I used to write a few paragraphs, and then I used to cry just writing about it, because when I was living that life, I mean, when I was struggling, I was like, okay, I want to do it because I don't want to show anyone that I'm weak. But when I revisiting those things, and I was like, okay, my God, yeah, that was so painful to write. I mean, of course, living that life never made me that emotional, but writing about it, yeah. Then I, of course, published the story. I mean, you can go to my Twitter handle, and that's the tagged tweet which I have there. So I decided to share my story on Free Code Camp with the community, and the responses which I received were amazing. I mean, there are so many. I mean, I never realized that there are so many people who might be going through similar phase of life as I did. And it, of course, did help some of people to realize that, okay, they can also do it. They can also probably make their life better by doing what they love. So, of course, things were going great till 2021. I mean, I was able to pay my most of loans because, of course, consulting was paying me more than what I was making at a job. But I decided to move to Germany in January of 2022. That was, of course, a call which I took with my family that, okay, now living in India, probably it's better for us because we are making good money. But what about our daughter? I mean, she might need to still fight for everything, right? Because, I mean, in India, you have so many people, so many students, and what in case something happens to me? I was scared because COVID happened, and I'm sure everyone was scared. So I was scared for my family. I was like, okay, probably I don't want to stay in India anymore. So I started looking for a job and landed up in Germany thanks to my friend who was who lives in Germany, and he recommended me for a job. But yeah, that turned out to be, I mean, I was scared, like maybe I have to go back to India because my family got stuck in India due to some visa issues. Yeah, I mean, bureaucracy in Germany is not that good or not straightforward. So we were separated for 10 months. In between that, I thought, let's go back to India. But yeah, there were some complications. My employer was not letting me go even to visit my family. They were scared that I will not come back. Of course, that was visible from my situation because I was so emotional. But I wanted to come back. I mean, that's a different thing. They never trusted me, but I decided to change the job. I mean, of course, a job is not worth having if it's not helping you or not your family. So I decided to change the job. I mean, I joined Celonis. That's where I work now. But after my family joined, of course, I published a course on Angular. That reached 1 million views last year. And it's an 17-hour course on Angular available on Free Code Camp for everyone to learn for free. Also shared my story on GitHub README podcast. So it's available there. I had chat with GitHub team, and then they agreed to share my story as well. I also have my story covered by Google India. So on Google India also, there is a video which we shot when I was back in India. And this is the picture. Like, we finally were together after 10 months. Yeah, I remember, like, as soon as they came, I took them for a vacation in Poland. And this picture is from Poland, one of the parks where we went to visit. After coming to Germany, I have traveled to like more than 18 countries to give talks. It started with this picture. You can see it's actually from Salt Lake City in United States. That was my first visit to United States. I mean, I remember like growing up watching how America looks like. And I wanted to, I will not lie. I mean, I wanted to visit it one day, but never expected that I will be there to give a talk at a conference. And that happened. So that happened in 2020. And I have been traveling since, thanks to my employer as well, who gives me sufficient time to travel to the conference. A shout out to my colleagues who take care of the work. And I can like manage my passion as well as my work and manage both. Mid 2024, I'll be finally debt free. I mean, I'll pay off my all my loans. I'll probably save more, help more. I mean, I started supporting open source developers as well. I contribute around $2,000 per month, per year, towards open source. Making sure that open source developers are actually able to afford or maintain their projects without worrying about money. Of course, $2,000 among 30 developers, but that's not much, but that's a small part, and which I'm doing. So of course, that's something which everyone can do. And when I was looking for a conclusion, right? So when I was writing my blog post, I was looking for a conclusion, and same thing happened with this talk. I was like, okay, how should I end my talk? And these are the lines which I came up with when I was writing my blog post. I was like, okay, do I think my struggles are over? I don't have any idea. I thought like everything is over in 2022, but 2020, sorry. But yeah, it's not over. I mean, is everything going to be all right? Even I don't know. But one thing for sure, am I going to stop fighting? To quit is not an option. I'm never going to quit. Whatever life throws at me, I'll take care of it. And yeah, thank you. I mean, thank you for the opportunity. I mean, thanks to my friend Ralph, who convinced me that I should share the story. Not easy, but I hope this story motivates more people to not give up their dreams and succeed in life following their passion. Yeah, I mean, I'll be able to connect with you. I'm available on X or LinkedIn at Santosh Yadav Dev. And yeah, thank you so much.
Santosh, we have some questions here.
Yeah.
And one of them, it's a lot of people recognize themselves in your life path, but can you give them an advice on how to become part of communities? Because I think communities are very helpful in this kind of situation.
Yeah, I mean, sure. So I remember, like, I started when I started my journey as I was active on X. So I started posting like about the things I was doing on X, and I got surrounded by good folks who could give me advice. I remember, like, the first blog post I wrote, I was approached by someone from the NGRX team because I was working on an issue, and they said, okay, why don't you just write a blog post on this issue, because this can be useful for many. And that's how it started for me. So the thing is, like, in community, there is a place for everyone. You just need to find them. I mean, reach out to them wherever you can. For example, there are, of course, Facebook pages, there are LinkedIn pages where there are many more communities. There are people on X who are ready to help you. Even that's the same thing which we follow at This Is Learning. I mean, we keep our community open source, meaning we don't take any sponsor, we don't like own your content. I mean, we do run podcasts, we run like we have our own blog post on dev.to, but it's not something which we own. We are just there to help in case you want to start your journey, like writing blog posts, or you want to host a podcast with us, or we are also planning a virtual conference this year. So if you are planning to speak, I mean, we are just like, it's like doing the same thing which people did for us as part of this learning community, because my co-founder Lars and me, we follow the same passion, like for open source, for like helping everyone without expecting anything back. Of course, you should. I mean, if you're doing something for the community, you should have some expectation, but yeah, it's totally up to you. But the thing is, of course, reach out to the people. They're not going to reach out to you. So start with GitHub. If you're already active on GitHub, you are part of any projects which you are working on, start getting involved in GitHub discussion, start helping more people, let's say, on the same project, I would say, or same technology. There are things like Stack Overflow which exist. There are people on X who need help. You can start writing blog posts to help them. Get involved in more and more discussion. And of course, you will find yourself there that, you want to do something for the community. Now you are like helping many more people as part of that community.
Okay, thank you. And as we still have 2 minutes left, we have one more question, and which is from Chris Foya. How did your professional development change after starting your family, particularly with your daughter's health challenges?
I mean,
How did your
that,
professional development change?
yeah. So I mean, when she was going through this hard time, I mean that was the time I also realized that I cannot like continue doing this and become successful in my life, right? So I started learning more. I started reading more. I started investing more time. Of course, as I said, like I started investing more time at work. Just don't do that. That was, of course, a stupid decision from my side, but that was the only thing which I could see at that moment, right? I mean, I was like, okay, it's not easy. I mean, especially being in India, where you have so much of loans on you. That was maybe right call at that time. So I started, of course, investing more time, learning things, learning new technology. For example, when I moved to Pune, I started getting more time. So I was like, okay, let's invest some time learning Angular rather than actually, probably using those extra times which I'm getting. And it helped me. I mean, and still do that. I mean, of course, I still try to make sure that I'm on top of things which is going on, whatever technology I use. So I invest some extra time out of my personal life to make sure that I'm able to keep myself updated, writing blog posts, or like doing this podcast, speaking at conferences, because they always keep yourself on the edge, right? I mean, if you're supposed to talk about some topic, you have to be prepared, right? It's not like you can just go there and give talks, because technology is changing fast. If you pick up any frameworks or any technology, they're changing every day. So those are things which keep me try to keep everything up to date.
Okay, sounds cool. Thank you. Your story was really touching. If anybody has other questions, they can reach you. They already know where to do that. Thank you one more time, and we'll keep in touch.
Thank you so much, and have a great day, everyone.
Thanks, Santosh. Okay, and now we are going forward with our next speaker. This is Jan-Willem Steur. Can you hear us? Yeah. Okay.
Yeah, I can hear you. Can you hear me?
Yes, and I see you. Okay, so
maybe if Santosh can unshare his screen, I can share my screen.
Santosh, if it's still there, can you please? Yes, it's perfect. Okay. So welcome, and when you're ready, it's your turn.
Okay, just have a look. Do I see where I can? Okay, that's quite advanced. Slides, portion of the screen, video,
it's
basic.
Down. Okay. You're looking for?
I'm looking for sharing my screen.
Okay, it's down there. It's like a moment.
Open preferences. Okay, I have to do something, I think.
It's underneath in the middle.
Yeah,
share screen.
I'm quitting and rejoining because I had to set some settings.
Okay, it's fine.
No problem.
We'll use that time to I'll use that time to tell you what is Jan going to present here. It's IBM Maximo application suite and Cognos analytics. Already a happy marriage since 2012. Yeah, 2012. So it's gonna be really fun, I think. Getting back to Santosh talk, communities are really important, and I can tell that from my experience, thanks to AIDA user group, which is our community group, and it's open. You can join it and get access to a lot of learning materials. We have Slack channels. You can communicate with us there. So just get in. It's free to be a member in our group. Okay. So now we are all seeing Mr. Steuer screen. Jan, can you hear me?
Yeah, I can hear you. And can you see my also in the screen? Okay,
yes.
Thank you. Sorry
Everything's
for the
great.
Inconvenience. Always
no problem
to
at
do
all.
a lot of things. Okay.
No.
My presentation is about IBM Maximo and IBM Cognos Analytics, which is already there since 2009. Sorry for the mistake. I wrote initially 2012, but it was even earlier. So let's see how I can. Okay, sorry. Okay, it's working over that. Who am I? I'm JW. That's much easier than the Dutch pronouncement Jan-Willem. It's Steur and not Steuer, so call me JWS. I'm listening to that.
Sorry.
No problem. Okay, I'm a real asset management nerd. I'm in the area of asset management since, I think, 2083. I'm hungry for a new technology. I'm a real Maximo geek. I breathe asset management Maximo. I don't work. I have a hobby and I have a passion. And that's called work. And what's even better, my employer is paying for that. I know from experience that good and trustful data is gold. You know always the announcement and pronouncing about garbage in is garbage out, and I strongly believe that. I like to bring in new ideas and dreams into practice, and that's why I'm working with IBM in their design teams with IBM Research in several areas for many, many years. Over 30 years of experience in AM and over 25 experience in EAM, Enterprise Asset Management. If you look just beside you, you see your home, you see buildings, you see your infrastructure. Everything has to do with assets, and every asset needs to operate for a certain life, for a certain time in the life cycle, and they need to be maintained because they are highly risky. You do not want to imagine what can happen with an airplane if it's not maintained or if it's not serviced and brought to airworthiness. Such ideas you cannot imagine beside you. Everything what you see, in fact, is an asset, and an asset needs to be maintained because each asset does have risks. So I started with, okay, why it's not working on this way? Okay, it's working just so. Okay, a minor agenda, pretty quick. What is Maximo? History of Maximo, journey to predict, and then I'm going to, okay, what has Maximo to do with AI, with Cognos, with Watson X? TDRL, TLR. Okay, I just used ChatGPT to see, okay, what is coming out of IBM Maximo. It's one of the best sophisticated asset management systems worldwide for decades. And how is IBM Maximo correlated to IBM Cognos? Okay, it's already correlated and it's already integrated since 2009. Although most of our clients and most of the IBMers and people in data AI are not aware of this. Okay, what is Maximo? Some history. It started all in 1985. Just with a minor thing that you can buy Maximo, including an IBM personal computer AT. At that moment, it was an 8086. And you were able to run a kind of maintenance management system and a kind of asset management system on it, just on a floppy, which was only 1.4 MB. We can't imagine nowadays, even a picture on your photo or on your iPhone is bigger. So that's how it started with Maximo 1. And then in the second decade, okay, they saw, okay, there is a certain need to have asset management and maintenance management. And they decided to go from Maximo 1 to Maximo 3. A minor timeline until 2012. And there you see, okay, it went from Maximo 1 to eventually Maximo 7.5, and that was before IBM acquired Red Hat, and then all the Maximo users were forced to work with a cloud solution running into OpenShift on any platform. But what is very important, in 2006 it was acquired by IBM, Maximo, and already in 2009 IBM Cognos was integrated and introduced in Maximo as a reporting tool. However, Cognos itself was acquired, I think, somewhere in 2008, mid-2008. What is Maximo? Story 3. Okay, there was a time somewhere in 2015 when the hype IoT came up. We can do everything with IoT. We have sensors somewhere in the field. They can deliver us a lot of sensor data, and they can give us a lot of information about the real condition of assets. However, before that, we already had over 40 years EOT, Ethernet of Things, like SCADA systems, and they were never touched. But the hype was IoT. And now we were able to go from manage your asset to real asset management and to predict when an asset is going to fail. So it became much more interconnected and much more intelligent. And all of a sudden in 2018, they decided, okay, we have to make and we have to monetize the acquisition of Red Hat for, I think, 38 billion. We have to monetize that, so we are going to store Maximo into a cloud called Red Hat, a cloud called IBM Cloud or AWS or Google, but supported with Red Hat as the containering platform. And then they also thought, okay, it's not good to have all these fragmented packages, and we have to store it in one suite. And there you see it. We can manage our assets. We can schedule our work using AI. We can have mobile work using AI to assist technicians in the field. We can do prescriptive maintenance. We can do predictive maintenance using AI and using AI models. And we can monitor the operational condition of an asset. So we are not looking to maintenance only, but we're also looking to, okay, how does it perform in operation using a lot of sensor data coming from SCADA systems or even IoT sensors, using AI to predict and to identify anomalies based on data patterns. That was quite new. That means that the databases that Maximo were using, they were extending exponential. So you cannot imagine that only a train, which is a commuter, which is bringing you from your home to your work, is producing more than 1 million sensor data recordings with very interesting data. And how are we going to store this data? So they were thinking about data lakes and data contracts, and what do we need from to know from a train, and where do we touch SLOs, SLAs, that kind of things. So it was increasing tremendously in a very fragmented situation like Maximo is. So IBM came up with the journey to predict, and they called it all of a sudden intelligent asset management. Well, it was intelligent all the decades, but we never touched or did something with the data that was gained and that was stored into the database. And now they all of a sudden thought, okay, we can do much more because we have the technology. So we can monitor, we can detect anomalies, we can look to the health of an asset compared to its life cycle. When do we need to repair? When do we need to refurbish or to replace? And also, can we predict the next failure? So IBM was quite focusing on the technology and technical part of an asset. However, the true definition of an asset is that it is adding you value from a financial point of view. So we can look to the technical aspects and, okay, I can predict that it's not going to fail because we are maintaining it very well. Maybe you are over-maintaining it, and that costs a lot of money. And at the end of the life cycle, you have spent 2 times the money that you have budgeted. So we are looking also to the lifecycle cost and also to the technical aspects of a true condition of an asset. And then, of course, you have this mobile workforce. How can we help technicians in the field with a kind of augmented reality, AR, but also AI, so that the technician is able to see when he is at an asset and he needs to repair it, like a pump. Okay, what is the history? What is the track record? What is the recommendation? And how can I do a visual inspection? And there also Gen AI is nowadays, as from 4 weeks actually, is supporting Gen AI, is supporting this technician, that it can create summarized reports and documents of the entire inspection. And you need to understand that the technician is using speech to text. So he is talking into his device, what is happening and what do I see and what is the outcome of what I have done. So that is very unstructured data, and we are using Gen AI nowadays to make well-structured documents and reports of the total inspection. So that is what we have nowadays. What has this to do with Cognos? Well, you can imagine that this kind of overwhelming data in a system, although Maximo has by default a lot of KPIs and it has over 400 reports available predefined, is very fragmented. And on the other hand, asset management is not, and Maximo is not the holy grail. From a data lake and from a asset management perspective, probably I need to have financial data from a separate or fully restricted financial system. Probably I need to have HR data to see, okay, was this activity done by qualified people? So I need HR to see, okay, this guy is certified to do the job, and it is also, he has a certificate which is also valid and not expired. So we need to have a lot of HR data. We need to have ERP data. To perform this job, do we have the resources in time? Planning analytics is a part of Maximo, but it can only work if we connect it to ERP systems so that we directly see, okay, are these tools or this materials available to do the job tomorrow? So there we need to have Cognos involved. So Cognos allows us to connect to a lot of other systems which are not directly integrated with Maximo, and that gives us a lot of insights. So it's embedded in Maximo. That means you have a free license. If you buy MAS, you have a free license to use IBM Cognos as well. Beside that, both IBM Cognos teams and Maximo teams within IBM, they have shared their experience and they work together to predefine already the integration between MAS and Cognos. It works bidirectional. That means if data is coming from IBM Cognos, also coming from other systems, it can be infused back into MAS to look and to use that to have even a better planning or even better analytics in the Maximo suite. Predefined database connections, you can use every kind of database and a predefined set of management summaries in Cognos. That means there are already a lot of dashboards available which are directly using the data, querying the data out of the database from Maximo, which you have connected during the integration. So you have already a quick start with some dashboards. And that's not only operational or technical, it's also strategic. However, from a strategic point of view, you might need to infuse also data from financial systems and other systems. It's done automated in OpenShift. When you install MAS and you say, I want to have Cognos, it's installing everything for you, predefined. However, we know it's out of the box, and I never met any client who is working with out-of-the-box software. It's always implemented, it's always tailored towards the client, and it's always tailored towards the industry you are working for. You can imagine that aviation has a total different regulation set than water management or infrastructures. So there you always need to understand the domain. You need to have domain expertise to do this. But if you have the technology and the functionality is not the blocking issue. It's always the organization, as it was said before in a previous presentation. Make use of the advantages of AI modeling, both in MAS and Cognos, because we know Cognos Analytics has also a lot of AI models coming from Watson Studio, or nowadays it's called Watson X AI and Watson X Data. And also MAS and Maximo is using the same technology as it was already before, because Watson was already introduced in 2016. And it was called Watson Studio, Watson Assistant, Watson PMI, machine learning. It was already there, but now it's all covered in Watson X. What else is in Maximo? They called it intelligent asset management, and we know that Maximo intelligent asset management is part of IBM sustainability, because they want to infuse MVC with that as well for ESG reporting. But if you buy MAS and you install it, what's included? By default, you have Cloud Pak for Data. You need that. You need to have DB2 Warehouse installed to install add-ons like Monitor, which is collecting a lot of data and OT data from the assets in the field. It's connected through SCADA systems to collect a lot of data, and it's also predefined with a lot of models which are typically for asset management. By default, there are 8 prediction models, and one of the most important is the reliability prediction model called Crow-AMSA. Just Google it. It explains you well. That was once one of the first AI models for reliability engineering, because the only thing what I want to know from my asset, what are the risks? How can I mitigate the risks? Do I have an FMICA? So do I have an analysis tool? And do I have an AI model to recognize this evident but also hidden failures, which probably are there in the correlation of data sets? And can I use this to predict the next failure? Or can I predict that it will reach the end of life as expected? So if I buy a pump for 30 years, I want to be sure that the end of life for 30 years is reached, because they are not cheap, big pumps. And it's the number one showstopper in almost any industry. So if I can predict whether it's performed correctly or not, there we have a lot of models for already. We have also predicted life. We have anomaly detection predictions, which are front-end available in even Monitor. And the nice thing is that these models can be used in Cognos Analytics as well. So even if we look in MAS or we are looking in Cognos, we can use the same models to have a kind of prediction. What is also included within that, Watson Assistant, Watson Machine Learning, Watson Knowledge Studio, and a bunch of other Watson X AI and Watson X Data products are available. Of course, Cognos Analytics, Maximo Visual Inspection, so AI-based training of visual inspections. You need to know that 20 years ago, when I needed to inspect a wind park model with a lot of windmills, it took me almost 4 weeks, because people had to go in, had to go up for an entire day, were able to inspect only half of the windmill. The next day, they need to go up again. Nowadays, we are doing this with drones. And what is a drone doing? It's just making pictures, unstructured pictures. We can infuse them in visual inspection. We can have AI-infused models to train to see, okay, is this an anomaly? And is this a severe anomaly? Yes or no? And what are the mitigating actions to do? So that you are even faster in doing your visual inspection, but also more accurate, because the inspection is always the same. You need to imagine, if you are a technician and you have to inspect 20 pumps on a day, the first pump probably will be inspected visually for 95% accurate. The last one, okay, that's okay, only 10%. While a drone or things like Scott, the dog, they are doing this inspection every time exactly the same, with the same high accuracy. So that makes value. It shortens the time to inspect. It increases the accuracy of the inspection results and the actions to be taken. What's next? AI, that's brand new. AI automated workflows. On the Tech Exchange last year, I had a nice presentation about IBM process mining, accelerated with MOS, and we did it for a client. Okay, let's look to 5 years of work order data and how accurate was it and what was the real spend. The average to repair and complete a work order, to repair a pump or an asset with a high risk was about 16 hours. The real repair took only 1.5 hours in average, and the delay and the waste was by approving a work order by the responsible guys. And we saw, okay, why do you need to have that much time to approve a pump which is down, that needs to be repaired, that impacts your process? Why does it take an average of 8 hours to approve? And it was mainly by budgetary approval. How can we give these insights so that you can take much better decisions if a pump has a certain repair and the repair has a certain impact? And there we infused automated workflows using AI and Watson XAI with a very nice model, which is recognizing, okay, this is a repair in a pump in a situation where it's very impactful for your process. This needs to be repaired, and I can automatically approve the work order, and then it can be executed. And that's reducing the total waste with more than 80%. So that is a pretty nice thing. All this data can be infused in Cognos as well, because based on this data, this operational data, we are even better able to create strategic reports and management summaries in Watson, in IBM Cognos than in Maximo. Planning analytics, AI scheduler optimization is there for 4 or 5 years already, or even longer. But also this optimization, the scheduler optimization to plan your resources against the work that needs to be performed against a certain priority, that can be done even better. And that's there we are infusing CP for BA, a Cloud Pack for Business Administration, business automation. SPSS, one of the things which is also available, and Gen AI, as I explained, Gen AI, which generates very high quality inspection summaries created from IoT, EOT, or HSOT. I'm going to explain what I mean with IoT, EOT, and HSOT. When the hype was there in 2016, I wrote a blog about the internet, the X of things. And the X of things starts with the human sensor of things. If we do not believe the people in the field with a tremendous amount of experience, they are the ears and the eyes in the field. If we cannot rely on them and we only rely on IoT, well, that is like building a roof without having the foundation. So start with HSOT. Then use EOT. It's already there for 40 years. Internet of Things, like SCADA systems. And then if you don't know, then do one of the sensors, which is bringing you a lot of data, which is not in the HSOT or EOT, and that can deliver you some extra information and extra pattern-based information, which you can use in your AI prediction models. Intelligent asset management, an example, MOS and CP4BA. As I mentioned, the accelerator for IBM, process mining, task mining, and business process automation. This is what we are using to get a proper result of what was your initial process. The nice thing of this process mining tool is that it is creating a business process model visualized of your actual process, so you can compare it with your initial process, and then you see over the time and in practice a lot of extra suboptimal process steps are added. Why? Because of the lack of ownership and the lack of responsibility in a real organization. So I'm not from this. I need to take the responsibility, but I do not want to. So I delegate it to other people, and I create a new process step. And then you see a lot of waste is going before the actual execution. We can use this data, and this data is creating CSV files, and this is what we can infuse in IBM Cognos, and then the results of that and the outcome of that can be infused back in MAS to improve your process. So, in fact, IBM MAS and IBM Cognos is already a happy marriage for over 15 years. And that's a lot of seconds. That was a bit of my story.
Congrats about the happy marriage, GWS. Thank you. It was awesome, very insightful, and really great. If there is some question, our visitors can ask you via chat, as we are almost hitting our time. If somebody want to ask something now, so you got the possibility.
Or just connect via LinkedIn to me, and I'm glad to answer your questions if you have one.
Okay, just post your LinkedIn profile here in the chat, and people would get it. Thank you one more time.
Sure, I will do. Thank you.
Okay, we are going ahead now. We are going to Anthony Alcaraz talk. Hey, Anthony. Hey.
Hello.
Okay, I can hear you. You can hear me.
Yes, you can hear me? Yes.
Yeah, it's perfect.
Okay, perfect.
So when you are ready, just...
Okay, let me put my PowerPoint. Okay, can you see this?
Yes.
Okay, perfect. Sorry, I forgot because I did the same lecture at Oxford, so I forgot to yes to remove it. I am not part from Oxford, okay? I only forgot to remove it. Okay, sorry. Okay, so I am Anthony Alcaraz. I am a Chief AI Officer at Freeball. It's a startup where we automate share processing. Currently, we automate the matching between CVs and job offer. And behind the hood, that would be the talk of today. We use the interaction between large language model and knowledge graph. Okay, I believe that the intersection of knowledge graph and large language model are the best approach, the state-of-the-art approach to build a retrieval augmented system and reasoning engine. And I will explain why, and I will detail why I think that. Okay. I have a GitHub attached to this talk where I have some coding, so it is what I will say is grounded on some code. Okay. 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 I think large language models are a beautiful tool, but they have some constraints, some limits, some weaknesses. Some of those weaknesses are that they have a problem of compositionality. That is, they can understand a simple task, okay, with a few short example, but when you combine this simple task in a different setting, or when you mix this simple task in a different setting, they can make mistake because they don't understand concretely what is this task. They are an autoregressive model. The next predicts the next token, so they can have a few short example and perform the task right. But if you ask the same task in a different combination with other different simple tasks, they can make mistake. Okay. This is one example. Another example is that they are very sensitive in the predicate order of their context. Okay. There is a paper that I can link to it. that is, if you give the same context, okay, the same context that you change the predicate order, so you change the logical order of the context, the response, the output will be completely different. So they are very sensitive by the way you put your context, the predicate order. Those are only two examples of the limits. Of course, there are many other, like hallucination, not up-to-date knowledge, etc., etc. I believe that knowledge graph as a retrieval tool, but also as a reasoning tool, are a good match with large language model. So what is a knowledge graph? A knowledge graph can be defined as a structural representation of knowledge. A basic knowledge graph would have a node like a chicken relationship that is part of a farm. Okay, a chicken is part of a farm. Okay, and you can have hundreds, thousands of those nodes and relationship, and it allows you to perform graph algorithm reasoning. You can have models that are trained on this structured knowledge, and you can perform retrieval that will augment the context of large language model. I will explain that. Okay, but knowledge graph have also challenges. Okay, there are challenges in building them. There are challenges when there is scale. There are challenging when there is noise in the knowledge graph, incompleteness, sparsity. Because it is a database, they have data quality issues. Okay. My talk, we propose a view of a coordinated approach between both, between large language model and knowledge graph. Okay. One paper that is fundamental to read if you are interested in this subject is a paper by Pan and al. In 2024. It has been revised in 2024. It is called a roadmap to merge both. Roadmap, I don't remember the name exact, but it's a roadmap to merge a large language model and knowledge graph. Okay. So I want to insist in this limitation of large language model. So I explained about the brittleness of to premise order. I have put the link of the paper. Accuracy can drop to 30% if you change the permutation of order of your logical step. Okay. They struggle with non-sequential reasoning. Also, I put a link on the paper that explains that, and they are distracted by irrelevant information. So when you perform retrieval augmented generation, that is, you fetch information to inform the model of, for example, with few shot example of what would be its task. If you have, for example, noises in the retrieve information, they can be distracted and the output will be lesser. Okay. Knowledge graph can assist into this by having constraints, structural constraints in the way that we retrieve information. Also, you can, with the knowledge graph, perform multi-relational representation. That is, you will see, but you can first perform a one-hop reasoning that is retrieving a set of entities and relationship, and starting from these entity relationship, perform subsequent retrieval. That is, you can in your retrieval perform some kind of logical retrieval. Okay, and also, you can make sure that your knowledge graph is constraints obey to some form of ontology. Ontology can be defined as some set of rules between concepts. Okay. Okay. So. Okay, I will pass that. I think it's not important, but it was for illustrating the compositionality challenges. These papers are based on using LLM to perform web task. Okay, I help a startup where I want to automate the web navigation. Okay, and those two papers study the ability to large language model to perform web navigation, and they struggle because they don't have an understanding of a simple component. And when you put those simple components together in an other order, they can make mistake. Okay. They are brittle. And those papers show this brittleness in terms of compositionality. Okay. Okay. Now I want to focus on the RAG system. Why it is important? I think RAG is some kind of a new design paradigm. Okay. There is a paper that has compared fine-tuning and RAG. And they have shown that RAG is better for integrating new knowledge. I have put the link here. Why I think RAG is important? Because one simple explanation is that if you want to add new knowledge to the large language model, you will need to retrain it. Okay, with RAG, you can build a system that permanently bring new current data, and you can build what I call the data flywheel. That is, you would want to build a system that continuously improve the underlying knowledge that your system is using. Okay. For example, in my startup at Freeball, this is what we are doing. We continuously enrich the knowledge base that is used by generative AI. And for example, if you monitor a problem of generation, what you want to do is to improve the knowledge base that was used to generate this answer of this reasoning. And the best way to build the data flywheel system would be a knowledge graph, because if you compare it with a vector database, it's much more complicated to manage the underlying data within a vector database than it is with a knowledge graph database. Okay, this is some kind of reasoning that I have, and one other argument would be that in the long term, we will have more and more powerful model, okay, within companies. We will have, I have heard rumor about GPT 4.5, okay. We will have maybe someday a model with planning capabilities, etc., etc. The only key differentiator for company would be to have high quality proprietary data. Or I define high quality proprietary data. Of course, you have the traditional definition of what is quality data. But what is interesting with the knowledge graph is that you can build some relationship and semantic relationship between your data. And I think knowledge graph are the most qualitative food that you can give to an artificial intelligence model. Okay. Okay. My approach. So in my startup, this is what we do. I don't use LLM for chatbots. Okay. My talk is also relevant for chatbots, but my approach of generative AI is to automate business operation, business processes. In my case, it would be analysis of CVs. It would be improving a recommendation system, etc. That is processes that are performed in the backend with no interaction with the user, okay, to automate summarization, extraction of information, etc., etc., etc. Okay. My approach to this is to use fine-tuning, but fine-tuning on reasoning task. Okay. There are papers that are interested in fine-tuning LLM, not for having new knowledge, but fine-tuning LLM to perform some task in particular. Okay. What I want also is to ingest structure knowledge graph data. And the bridge between my LLM and the knowledge graph will be multifold. Okay. You can have vector similarity search on your knowledge graph. Okay, you can add embeddings of the nodes of the relationship and perform vector similarity search. The difference with traditional vector similarity search is that you can have some kind of logical vector similarity search. You can, for example, constrain the vector similarity on relationship, on logical relationship, or constrain the vector similarity search on certain nodes. Okay, so here you can add some logic within above the cousin similarity that is traditionally used in vector similarity search. Okay, this is one gate. You will see I will detail them in the talk. The second gate would be to perform queries. So you have Spark SQL queries, you have Cypher queries. They are very similar to SQL queries, okay? Here, they are useful to perform mathematical operation on the knowledge graph. I will give you an example. I want to know okay, this race of this type of chicken, imagine I have a knowledge graph of chicken and farm. I want to know this type of chicken in how many types of farm is part of. Okay, this is a mathematical operation that I can perform easily with a Cypher queries or the Spark SQL queries, depending on your knowledge graph database. Okay. Also, what I can do, so I have two tools to augment the context of my knowledge graph, of my LLM. I can apply graph algorithm. Okay. Graph algorithm are very diverse, but for example, one example, and it is used in a recent paper by Microsoft, would be to perform clustering. Okay. I want to know, okay, I have one entities, in which cluster this entity is part of. Okay. I want to fetch maybe all entities that are in the same cluster than these particular entities. Okay. This allow you to okay. This is just one example. You can look, for example, for centrality. I will detail this further in my talk. Okay. Also, the third part of my approach is that you want to consider the knowledge graph as a tool. Okay. You want Cypher queries, you want vector similarity search, you want graph algorithm to be used in an agentic retrieval augmented generation setting. That is, you want your LLM to think about what he is doing, to use the proper tool for the task ahead, and you want that the usage of those tools modify the step in the process of resolving some task. Okay, that is called right now thoughts. Okay, thoughts for LLM. You have a paper that I'll talk about that. A graph of thoughts, a chain of thoughts, a tree of thoughts. Okay, you want your LLM to use your knowledge graph as some kind of tool and know how to use it. Okay, when and how to use it. Okay, this was the theoretical approach part. I will detail this, of course. Okay. I put here an example of my approach because there is a paper, okay, that is called Reasoning on Graph ROG. I put the link here that do just that. Okay. My approach. So here I don't detail this paper, but this paper is some kind of example of what I will be talking about today. Okay, they just did that. Okay, they detail all these three components. They use it in the paper. Okay. So I won't detail it, but I mention it as an example. Okay. Okay. To add of what I just said, my view is this. The LLM so performs some kind of reasoning. You have a knowledge, and for me in this Venn diagram, knowledge graph are at the same time part of the reasoning, okay, and part of the knowledge, okay, because with a knowledge graph you can perform reasoning, okay. You can train other models. I will give you an example. In my company, I have classifiers, okay? For example, at some point, I perform skill identification. I have a model that is trained on my large-scale knowledge graph to perform this skill identification, and it is trained on the data present in my knowledge graph. Okay, so you want to mix the reasoning of the LLM with some kind of reasoning module that are coming from the knowledge graph. Okay. Okay. Now I want to, because people can respond to me, can ask me, yes, but knowledge graphs seem complicated to build. Is it better than vector database, etc., etc.? I think the match is one with knowledge graph. Okay, I will cite you 2 studies, but in theory, just after that, in theory, I think knowledge graph are a much better knowledge database than vector search. Okay, with knowledge graph, you can have taxonomic, logical, procedural relationship that goes beyond causing similarity. And recent paper by Netflix showed that causing similarity had many flaws. Okay, flaws. Also, what you can. One advantage of a knowledge graph is that it is explainable, okay? The subgraph that will be used by the response of the LLM can be traced back, and can be used as an explainability module within your application, okay? Okay. I have one study. I only found this one because I don't have currently the resources. If I had more resources, I would do a full-scale study on the comparison of both. But I have this study of Buller et al. In 2024 from MIT. Okay, it compare both. Okay, it was for material engineering. So I don't know a thing about material engineering. But in his paper, he compared a system with a knowledge graph, an agentic system with a knowledge graph, and an agentic system with only vector search. And what it demonstrates with, I think, 5,000 tries, example, is that the accuracy is a 40% difference in terms of accuracy of response. And actually, this study has been recently confirmed by GraphRag from Microsoft in 2024. This study from Microsoft so use actually a knowledge graph to augment the LLM, and they use a graph algorithm that is a cluster algorithm to help augment LLM response. And they show in their study by comparing both, so normal RAG and knowledge graph RAG, that's the one that you had twice more diverse viewpoint per answer. That the responses was 23% more comprehensive. Yes, so these 2 studies are the only one that I know that are comparing and confronting both. Empirically, I have built some chatbots comparing both, and I think there is no match. I think having a knowledge graph as a knowledge base, you got less hallucination, if not no hallucination, and you got also a consistent output. Okay, if you built this right. Okay, and you don't have because the chunking. One issue with vector database is the chunking. Because you don't have here chunks, but relationship between concepts, and maybe in a property knowledge graph, some description or see attached that are attached to nodes and relationship. You don't have this chunking problem. You have though a problem of building the knowledge graph. I will talk about this. Okay. One interesting thing about this paper is that they talk about this concept of whole dataset reasoning. That is, with a knowledge graph, if you take in theory that every part of your data is stored in a knowledge graph, you can have a reasoning that extends to all of your data, and you can perform with, for example, they gave the example of a graph clustering, but this graph clustering will allow you to reason on your all of your data. Okay, and this whole dataset reasoning is empowering a RAG system. Okay, this is a tab for you. I won't detail it, but I compare both in every dimension. Okay, now I want to put. So this is my talk. The intersection of graph and LLM, and I think there is 3 dimensions. This is new. I didn't see this classification elsewhere, but this would allow you to classify every paper that you can read on the subject. And trust me, there are many. Okay. I think the first approach is to use, yes, graph as context provider. So until now, I talk about that. Okay. To use the in-context learning capabilities of LLM, and to provide what is present in the graph to the LLM to perform some task. Okay. The second approach that is interesting is to use graph as a reasoning topology. Okay. Here, you don't provide knowledge in form of graph to the LLM. You ask the LLM to perform the realization, the output as a form of a graph. And here you have many papers that are doing that. And they show that is the best approach in terms of quality of output. You have graph of thought, of course, but you have also some work from Longchain, for example, LangGraph, where they put the usage of tools, okay, in a graph. And in a cyclical graph, the LLM, so to choose to orchestrate which tool it would use, this is put in a graph, okay, with a causal relationship, for example. Okay, this is an interesting approach. And the third way is to use LLM for graph task. There are many papers that are doing that. That is, you use the textual understanding of the LLM. You transform the knowledge graph, relationship, nodes, etc., in textual form, and the LLM is able to perform graph tasks like node classification, link prediction, community detection, centrality analysis, etc., etc. Okay. Now I will detail this 3 approach, and this will be my talk. Okay. I put here, just for your information, another classification that is coming from the paper I cited at first. That is the roadmap to integrate large language model and knowledge graph. You will see some similarities. Here, I don't talk about pre-training, because you could imagine to pre-train your LLM on the knowledge graph. I don't talk about this in this talk. Okay. 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 So I start by graph as a reasoning topology. One important paper, I think, and I am putting it in production actually right now with my startup, is this paper. I don't know if you will be able to see it. I don't think so. But it's a paper that Puplin et al. In 2024. What they do is that they combine graph reasoning, that is to make sure that the step of action of a LLM is put in form of a graph. Okay. What allow this form of reasoning is that if you have 2 similar thoughts, they can be combined. Okay. It has been shown in graph of thought paper. In RARE, so this paper combine graph of thoughts with retrieval. That is, at each step, the LLM performs some kind of retrieval. Okay? Okay. This is the first dimension of the paper. And what is interesting in this paper is that it uses a Monte Carlo planning policy. That is, instead of exploring every thoughts and every path, okay, you have a Monte Carlo, so a reinforcement learning algorithm that choose for the LLM the most promising path. So of course you need to train the Monte Carlo. Of course there are preconditions in this approach, but this approach seems the most efficient and of high quality value for this kind of doing things. Okay. Okay. Here, so you want to use this approach of using graph to reason. Okay. My approach is to do exactly that. So I am using RTP, so the paper that I just talked about, but I am using also another approach that is called LLM compiler. One value of LLM compiler is that you can have multiple tools, okay, and you want to use those tools in parallel, okay, when it is pertinent. Okay, in asynchronous way and parallel. Okay, this is one value of this paper, and you have another approach that is called long graph. Here you want to have a cyclical graph. Okay, cyclical graph is this: you have point A, point B.
Sorry, Anthony, that I have to interrupt you. We have still about 1 minute left, so if we'll be pretty glad if we can continue that talk in chat, or we thank you for accepting our invitation, because these are 30 minutes talks, and there is maybe about 50 speakers here. We can just continue with that if you want in our chat,
no problem.
or next invitation if you accept it, of course.
Yes, no problem, because I think I did an overview. No problem.
It's really great, really great presentation, really insightful, and I'm sure there is a lot of people who will find it and.
I didn't manage my time. I'm sorry.
No problem at all. Just keep in touch. Stay here in the meeting, and just post your LinkedIn profile here so we can contact you.
I'm sorry.
No problem at all. No problem at all. Great.
Ciao.
Perfect. Thank you. So we are going forward to meet our next presenter, Mr. Maximilian Burkardt, who talk about some IBM stuffs and exactly business intelligence and data science, merging both approaches and breaking the silos in consumption process. Sorry, I got processing governance. I just got a little bit confused. Okay, Maximilian, can you hear me?
Yeah, I can hear you.
Okay, when you are ready, you can start.
Perfect. Then, hello again from my side. My name is Maximilian Burkardt, and I'm a technical specialist for AI at IBM. I'm with IBM since 2 years now, and I worked before 7 years in the retail and supply chain industry. And one of my favorite topics is the combination of AI and business intelligence. And that has been the reason for the talk today. And I will share my screen here, my overall desktop. Perfect. That works with the first try. So you should see a presentation here.
Yes, we see it.
Perfect. Great. So again, I want to present today about the combination of business intelligence and data science or AI. So my personal target or the reason for that talk has been the following, that I recognized that both disciplines are often seen as different worlds. And in my past, in the retail industry, it was a fact. We had the data science people and the business intelligence people. And I also recognize that currently discussing that topic with clients. We have different skills, different technologies, different processes, and different people working on both topics. And the output and the result of that is that there are silos. So we have the point both teams, in fact, maybe they prepare the same data. So they have no standardized processes behind. It's difficult from a governance point of view. And there's also a potential loss because the business intelligence tools are the tools in the business units in the company. And I have clients having thousands of business intelligence users. In our case, it's Cognos, but in the reality, the companies, they use Power BI, Tableau, Cognos, Qlik, MicroStrategy, whatever. And that are the tools in the business unit. In my past, for example, the retail specialists and the supply chain specialists are working with that tool. And then we have data science, where people developing great solutions, for example, customer churn analysis, risk classification, these topics. And now the challenge for me as a data scientist has been, I developed a great data science approach, but how do I get my approach into production and to the people who should work with my results to the business units? And that has been the starting point for me, thinking about how can I publish my data science results and make them usable for the domain knowledge workers in the business units. That has been for me the starting point to work on that topic here. And when I discuss that with clients or business partners, I show them such a slide here, where I say, okay, we have business intelligence on the right side here, and we have data science on the left side. The output we know from business intelligence is we have an automated data pipeline. So we have the ETL pipeline, we have a single point of truth accessing cleaned and transformed data. And based on that, we build dashboards, reports, and offer self-service BI for the business units in a company. On the other side, we have data science, where data science scientists like me are working with large amounts of data, and they build and deploy models, or they analyze the data and have the results. So, for example, which credit in a bank has a high risk to default, or which client from my company is going to churn, or that are just examples. And now the question is how to combine that both approaches, because both approaches have a common objective. So all people working in that field, they want to analyze the data from different sources, and they want to improve their decision making. That is the starting point for all of us. And that is the reality. And I thought about how is the landscape of combining both approaches, and how can we help the domain knowledge experts working with the BI tools in the company detecting patterns in historical data, defining the measures to improve processes and outputs from a company, as well as benefit from the traditional BI capabilities like dashboards, reports, and self-service BI. So for today, I want to discuss in the end 3 maturity levels. I saw Martin Otto in the call here. He knows the first 2 from a presentation I held in the past. and the third is new also for him. So I want to talk about 3 different maturity levels. The first level is our inbuilt AI capabilities. So there are tools in the market. I'm working with IBM Cognos Analytics in that field, which has inbuilt AI capabilities. So when we are talking about Cognos, Cognos has an inbuilt decision tree, an inbuilt multivariate forecast, an inbuilt AI assistant where I can ask questions, and further functionalities to detect patterns and correlations in historical data. That inbuilt tools are built to be robust and user-friendly for business users. So to be fair and honest, they are great for multiple use cases, but there are also limitations. Also from my personal point of view as a data scientist. So the next question is, okay, I have that level 1 inbuilt AI capabilities, but there are use cases which go beyond, and there will be definitely these use cases. Then the question is how to combine that. And for example, I talked with an automotive client last year or 1 year before, and I discussed with they use Cognos Analytics and planning analytics. So in the end, they do with our stack planning, reporting, and dashboarding. And I asked them, oh, how do you get your financial forecasts? And then they told me, okay, we have a data science team in California. They build these forecasts, and or they build the models which generate the forecast. And then my question has been, okay, that's great. And how do the people in the business unit consume these forecasts? And then they told me, that's they have silos. So the forecast based from the development in California is not integrated into the standard BI tools they are using. And so the people in the business units, they have the tools, they are working with it for traditional BI. And the financial forecasts based on the high quality forecasts, they have to look in another table they get. And that's not the fact we should do it. So I'm working a lot on that topic. And Cognos Analytics offers, for example, the capability that you have an inbuilt Jupyter Notebook integration. So I, as a data scientist, can code my data science workflow in Python, and then infuse my result into the traditional BI dashboard, for example, for customer churn or risk assessment. And the end user in a business unit can say, okay, I have my traditional dashboard. I look at traditional metrics, charts, tables, and he has one chart in his dashboard, for example, which shows him clients which are going to churn. And the end user does not know that this one chart in the dashboard is based on a custom data science model built from the company itself. So, for example, and the users in that case, they can access the Cognos data modules from the data science process. So the data scientist can access the already prepared data. And so we don't have to access and prepare the data again in another process. And we have the user-based governance model behind. So that process is pretty efficient. Another approach to do that level 2 is, in our case, we have watsonx, which is IBM's data science and AI platform. And we can also develop their custom Python models, ARM models, SPSS models, custom for a company. There's also an auto AI functionality. And then we can infuse these models into Cognos Analytics. So in the end, we can merge both approaches, data science, business intelligence, from a governance perspective, from a process perspective, and in the end from consumption, because the data scientists can use the BI tools in the whole company as a platform to publish their data science results too. And in most of the cases, the people who should work further with the results and bring the real business value, that are the people in the business unit. And that is the second level. And now there's a third level. For today, that is the focus also from the live demo, because that's the most innovative part. But we can also talk about a live demo and questions about the first and the second use case. The third use case now is about generative AI. And one of my major topics at the moment is how we can use all the advantages we know from generative AI and combine them with business intelligence. And to show you that, I will go into a live demo and show you what benefits can we generate by combining generative AI technology around large language models with structured data we know from BI tools. So I will leave that presentation here and go to the tool. Perfect. So what we are seeing here is IBM Planning Analytics, which is our tool for planning, simulation, and reporting. The tool is not relevant in that point of view. It could also be Cognos Analytics or another tool. But from our point of view, you should use that. So what I want to show you is that now we have here an assistant on the right, and that assistant is based on the Watson X assistant, which is an IBM product, and Watson X, which is the AI platform from IBM. And now I have different possibilities here. The first possibility I want to show you is that the AI assistant can support the user in working with his tool. So, for example, that is an approach for financial planning, product unit forecast, scenario simulation in a company. And in a normal way, the people have to work with the tool via the web-based user interface here. But we can also offer here the functionality to do that via chat. So I can say I want to do a forecast. Then the assistant recognizes my intention and asks, okay, for which organization? Then I can say I want to do that for Massachusetts. Then the next question is for which channel? So I want to do a forecast for the retail channel for 2024. For, let's say, February. And we want to do a forecast for the product 5G 64 gigabyte. 5G 64 gigabyte. And let's say as an amount 567. And now in the background is an IBM code engine. There's an application running, and that application is collecting the information from here and is writing that back into the planning analytics database. And so we see here the 567, which we have written into the database using the chat interface. And we could also do that step by step, like here. And we can also write one full sentence or two or three, and the assistant is extracting the entities and using that to define the data record, which he writes into the database. The next use case is, I should switch that here. The next use case is around domain knowledge. As I said, I worked a lot with business units in the past, and from my experience, domain knowledge is success critical for analytics projects. But from my experience in the retail industry, and also when talking to clients, the people who are experts in using the BI tools, building the analysis, are not always proven in the whole domain knowledge. And I wanted to show you an approach how we can support them. For example, I'm a user here. I'm doing data analytics. I'm analyzing the sales efficiency. I have here the sales efficiency monitoring. And I see here the values for different channels. And I see here, okay, the values for hypermarkets are lower than the values for the other channels. And then my question is, oh, what are hypermarkets? And now a company has the ability to upload a knowledge base. So for example, the company can say, I want to upload 100 documents describing my company, my industry, my company processes, planning assumptions, whatever. So documents owned by a client. They can upload them and make them usable here. So I can type here, for example, I have a domain question. Then he also recognizes my intent and say, okay, tell me your question. And then my question is, what are hypermarkets? And then the assistant looks in the company-owned knowledge base and comes up with a description for me what hypermarkets are. So I learn that hypermarkets are a special retail concept. They have at least 3,000 square feet of selling space, and they dedicate 35% of their selling space to non-grocery products. So as written here, there could be electronics, clothing, home goods, whatever. So I, as a business analyst, I understand the data much better, and I can say, okay, is that value here possible, or is that an outlier? And I can also define better actions for the future. And the feedback on that use case has been really good. So the question from a worldwide colleague then has been, okay, that's great, but can we also learn from a data model a client has already built, in that case, in planning analytics or Cognos analytics? And that's now a topic I'm pretty proud of because I invested a lot of time to do that. And let's start with one question. I can copy here. So for the first step, I have to say, I have a data question. And my question is the following. I want to ask the question, hypermarkets have a lower sales efficiency for grocery products than average. How can that be? So that for some people that's a very pragmatic question, but for the analysts that's a very interesting question because in a domain context, no data field in the data model is named sales efficiency because in the company here they use sales efficiency for a specific to talk about a specific measure in their data model. That's the first challenge, and the second challenge is the reasoning to come up with an answer. What is the reason for that? And now the question, as I said, hypermarkets lower sales efficiency than average. How can that be? And now, when I'm asking that question, there are happening two processes in the background. The first process looks in the data model. In that case, the data model behind planning analytics, and he learns the following. He sees, okay, the sales efficiency, I mean, as a proven business user, the sales efficiency is measured by sales per square foot of retail space. So he sees, okay, sales efficiency is that measure XY, and that measure is calculated by the revenue divided through the retail space, or in that case, the sales per retail space. That is the insight one. He learns from the data model of a company, and then he combines that with the domain knowledge here and sees, okay, I'm asking a question for hypermarkets, and based on the domain knowledge from the company, he learns that hypermarkets dedicate 35% of their space to non-grocery products. And so he can combine that and sees, okay, hypermarkets have a smaller retail space they dedicate to grocery products. So he can reason the fact why I observe that outlier here. I have also one chart prepared on that to make that more accessible, which is that one here. So what we have, I'm asking a question, and the first step is, based on my question, the assistant is looking into the data model. But how to make the data model accessible? The key word is here semantic layer. So that's a synthetic layer on top of the data model, adding context to the data model. In the Cognos data module, for example, a client could add a description to the dimensions and measures. In planning analytics, they could also comment an attribute. So a client could go into an existing data model and can say, okay, I comment different or relevant parts of it. And in the end, I'm extracting that information and generating a semantic layer. And that semantic layer exists of the measure, how it's calculated, and the context. That's the first insight, that when I'm asking the question of sales efficiency, the assistant knows, okay, sales efficiency is measured by sales per selling space. Now, based on my question, the assistant retrieves the relevant context based on the knowledge base. That's called retrieval augmented generation, which is common practice in current AI projects, where I retrieve the most relevant context from a company knowledge base that could be used via a vector data bank and a semantic search. In our context, we have different products for that. For example, Watson Discovery and Watson X Discovery in an IBM context. And we use that path here to extract the knowledge from a company that, in that case, hypermarkets are special because they dedicate space to non-grocery products. And then I spend a lot of time into the prompt engineering. So to teach the model how to combine both input flows and how to argument. And then that augmented prompt is sent to the large language model. And then the large language model only uses that information here to answer the question and to minimize hallucinations. And that's the fact why I can ask these questions and get an answer based on the company built data model as well as the company owned knowledge base. And from a current perspective, presenting that, there's no tool in the market which can do that out of the box. And how is the keyword to build such a solution is that semantic layer. And one last example, for example, we are building a data model with, for example, vehicles, and for example, for the police. And in the data model, there's one field which is called active, and there's a 1 for active and a 0 for non-active. That's the data model. But when I want to offer such an assistant for the company, an end user would ask questions like, how many cars are currently available, or how many vehicles are ready to use, or something like that. But the end user would ask a question like, how many vehicles have in the measure active 1? They don't know that that is the data model behind. And to translate between the data model and the LLM or the assistant, we need that semantic layer. that was my presentation. Thank you. And I have here written down here, that's the barcode for my LinkedIn, my phone number, my email address. Feel free contacting, feel free connecting, asking questions. We can also do a follow-up and discuss that. And we can also do a deep dive into the semantic layer and the topic. Thank you.
So thank you, Maximilian, for accepting our invitation, and hope we can see each other soon in other events. It was really insightful. Thank you very much.
Thank you.
Have a nice day. And we are continuing with our next speaker, Dr. Alessandro Brillante. He will speak about large language models in practice. So more practice they will be here. So can you hear me, Alessandro?
Yes, I can hear you. Good afternoon,
okay,
everybody.
So it's up to you now.
Just need to select my slide and share. I hope you can see my slide.
Yes.
Do you see the entire slide or?
Nope. At the moment, I see your. I see it like in three parts.
You know what I have to click? What I have to click here?
When you click share screen.
Yeah, the swap presenter view should work just fine.
Is it better now?
It's fine.
Yes,
it's fine.
that's okay.
Okay, good afternoon, everybody. My name is Alessandro. I studied physics in Frankfurt, and I'm working at the IT consultancy Adesso in Germany. I live in Frankfurt. And thanks for everybody for the invitation, and especially to Martin Otto. So initially, I will present the company Adesso. Then I will make some general remarks about computers, computer science, bandwidth, latency, and the transformer architecture. Then I will speak about large language models and about the GPT model. What are the challenges from my own limited personal perspective? Then I will speak about the use cases for large language models, and then I will show one slide with possible references. So my experience with large language models is limited. I worked so far only with the GPT 3.5 version from Microsoft OpenAI. So let me present Adesso. We are an IT consultancy in Germany. We have roughly 1,500 employees working for consultants, working for the insurance companies in the DACH region. In total, we are more than 1,500 people. In total, we are, I think, 10,000 if memory serves me correctly. What do we do? We provide knowledge transfer and enablement to our customers. We provide consulting, engineering, and operations. Also in the field of machine learning and artificial intelligence. And we work with several different technologies and technology companies, like these here. Okay, so here are the remarks, the introductory remarks. I want to just, I brought the picture showing several different components of a computer, the computing nodes like the CPU, the GPU, or the TPU. I think the tensor processing unit was invented by Google, as far as I know. And then the cache, which usually sits on the chip, which is produced from the wafer. And what I simply want to say in this picture is that the links are strong, close to the CPU, and they are weak, further away from the CPU. And that's why the robot on the picture is saying we need high arithmetic intensity. We need algorithms with high arithmetic intensity. So not always, but sometimes it's the case that your CPU is running maybe at 10%. However, you are not satisfied with your performance because you need to read in data and the data is sitting far away. This is what I depicted with the different links, with the different width. And this problem during the last 4 decades intensified because the number of floating point operations increased like crazy, but the access to the disk is the improvement was slower. And one machine which NVIDIA sells is a DGX A100. As far as I know, one server costs roughly 200,000 euros. And this machine puts a lot of emphasis on the bandwidth, on the networking, in order to get good performance for machine learning workflows. So what is meant by high arithmetic intensity? It means that whenever you move 1 byte of data, you use it for as many floating point operations as possible. That's the meaning of the arithmetic. That's the definition of the arithmetic intensity. And here I just want to spend a few minutes about Andal's law, which he presented in the 70s of the last century. At that time, there was a discussion, do you want to scale computers vertically or do you want to scale computers horizontally? And Andal, if memory serves me correctly, he defended the position of vertical scaling in the 70s of the last century, because he said that whenever you add the number of processing nodes, you are limited by the part of execution time of your computer, which you cannot further divide because of dependencies, which is depicted here as the red part of the tube of the pipeline or the cylinder. And if you look at this equation, I mean, it's a simplified equation. It's very much simplified. However, it's also useful. And if you look at this equation, it tells you that the maximum performance benefit, the maximum speed up is exactly how many nodes, what's the factor of multiplication of the number of nodes that you added. And one reason why the transformer architecture is used today is that it enables higher parallel fraction. It cuts away dependencies. I mean, previously, as you know, for the field of language processing, there has been used like n-grams or recurrent neural networks or LSTMs. But one reason why the transformer is used today is because it's more parallel. Especially the training cost is very high. Inference is, of course, much cheaper, but training cost is very high, and the transformer offers better performance, offers better scalability. So I find this graphic interesting because you want to walk orthogonal to the contours. But in order to walk orthogonal to the contours, the only escape is that you need to parallelize your code. There's no other way. Otherwise, you are walking parallel to the contours, and that's not what you want to do. And here I want to make briefly a remark about Claude Shannon, which founded, together with other people, he founded the field of information theory in 1948. He published a paper called A Mathematical Theory of Communication. And then 1 year later, he published a book called The Mathematical Theory of Communication, together with another author. The book is you can find on the internet. And I find it interesting that on page 44, we already have a language model on page 44, the output of a language model, where he says that if we use second order word approximation, we get a sentence in English, which sounds more or less reasonable. like the head end in frontal attack on an English writer. So this is an n-gram model where you condition the next word on the previous two words. And what he's saying is that you don't need high n, and you get sentences which sound reasonable. And also in the book, he introduces the concept of entropy, which is a measure of the information of a source. So and he defines entropy similar to Boltzmann, the Austrian physicist, who defined entropy for particle states. He defines entropy as the expectation value of the negative probability. And the expectation value of the negative logarithm of the probability. And colloquially, I mean, it's not written in the book, it's not an exact citation, but colloquially, what the way that information is defined by Shannon is that information is what you did not say, but could have said when you said what you said. So what you say does not convey any information. It's only because you didn't say what you didn't say that you say something. But that's not an exact citation. It's just the way it's presented in the book. And so 2017, the transformer architecture was introduced in this paper, Attention is All You Need. And previously, the attention mechanism has been introduced in 2014 by Badanau and his colleagues. And the attention mechanism means we provide a decoupling between different layers of an architecture, or we provide a decoupling between the encoder and the decoder. It was presented in this paper, Neural Machine Translation by Jointly Learning to Align, in 2014 as a way for machine translation to let the decoder decide which part of the input to focus on. So at that time, machine translation worked. We take a source in the source sentence, we convert it into a vector, and then we read from the vector again to the target language. And the attention mechanism, the improvement with respect to the previous way of doing it was that instead of waiting for the encoder to finish to produce a final vector, we simply write out the vector at any time step and give it and let the decoder decide which vector to pick or how to construct the vector using the n vectors. He makes then a sum, a weighted sum, and builds the context. So the idea is that you build dynamically the context. However, it's not magic. It's also a machine learning model which is trained on data, and the weights of the attention mechanism are obtained in the training stage. There's no magic involved. And the transformer architecture was introduced in 2017 and is used today by many models. For instance, models that are cited on Hugging Face. Now, as far as I know, most of these models only use the decoder component and not the encoder component, and stack different decoder components on top of each other. Now, GPT-4, as far as I know, has not released the architecture. We don't know exactly what they do. But there are other language models that are with an open source code, and where you know exactly what the architecture looks like if you have time to study it. So as far as I know, most of the language models today, most of the large language models don't use the encoder component at all, but simply feed the raw input tokens into the decoder. And then you have several different attention mechanisms working, where every decoder component consists of three parts. And the advantage of this architecture is that during inference, for instance, you you pass in at the bottom, you pass in every token at the same time. You don't have to wait like in RNNs. You pass in every token at the same time and provide information of, is it the first token, is it the second token, or is it the third token? You provide this information, but you process them all at the same time. Okay, so now I want to give some subjective remarks I have about large language models. I've only worked with GPT-3.5 so far using the API of Microsoft Azure. I didn't use the API of OpenAI. So occasionally the output is not deterministic. I don't think it's a big problem, but occasionally you work with with your colleague, and your test fails, and when the colleague runs the test, it doesn't fail, or the vice versa. But it doesn't happen very often, but sometimes. That's my experience. Now, about hallucinations. For instance, with the LangChain framework, which provides a unified way to interact with different language models. So when you write your application in LangChain, the idea is that you can switch between different language models more easily, because you write it in such a way that you decouple your code from a single language model. However, when I was looking for documentation of how to implement an evaluator to evaluate a prompt or to evaluate a language model using LangChain, I was redirected by Google to the site GitHub, and where a language model is generating documentation about LangChain, or maybe it should not be called documentation, but a bot is generating answers to questions about LangChain. And first he writes, please write the score as in this JSON. But then if you look more below in the thread, he writes the score must be enclosed in double square brackets, which to me is a contradiction. So there's no way you can exclude logical contradictions with language models. I mean, because they are constructed to predict the next word, and it's not so easy to understand how knowledge is distilled in the language model, and how to make sure it doesn't contradict itself. It's not so easy. One thing I find interesting is the prompt brittleness, which means that you change your prompt and you are surprised by the answer you get. So we use the GPT-3.5 model often to provide some style sheet transformations, where we consume a JSON, or we consume a dictionary, and we generate another dictionary when we want to be able to process semi-structured data with natural language. And the paradox with deep learning is that on the one hand, we want to use deep learning because we don't have to care about feature engineering. We simply provide the data, and then the deep learning model figures out what data is relevant and what data is not relevant. But at the same time, of course, if you change something in the not relevant data, it affects your output. So in this case, the prompt is responsible to translate one input dictionary into one output dictionary, where he substitutes different wordings for packaging units into standard packaging units. And when I change the format of the article number, which is irrelevant or which should be irrelevant to the problem, then I can get sometimes, not always, quite seldom, not very often, but sometimes you get a different result when your answer sits at the borderline, when the language model is not sure, is it this answer or is it the other one? Then you make a tiny change somewhere else, and you get a different answer, different result. So my feeling is that application of large language models requires a solid way of writing tests. It's not so easy always to write tests for large language models. Then about the performance, there's one site from GPT-4 Work which tracks the RP call latency of the largest large language models, and we see sometimes something around seconds. So as far as I know, Microsoft Azure Cloud does not provide any guarantee for the RP call latency. They don't guarantee you that they return your RP request in less than 5 seconds or in a certain time. I mean, it's not terribly bad, not terribly bad, but yeah, we need to just know that it can take a couple of seconds. With Microsoft Azure, you have the possibility to stream the tokens back to your application. You don't have to wait until the full answer is finished. You can also stream the tokens as they are generated back to you, which makes sense for live conversational agents. Because large language models, they are auto-regressively, which means that whenever you generate one token, the output, this output is fed again as an input into the large language model. So in order to generate the 4th token, you need to first generate the first 3 tokens and pass them as an input. And what I find interesting is there's this site from Hugging Face where different large language models are compared using bilateral competition, where you go to this site, you can ask a question to a large language model, and you don't know which large language model is going to answer, but you can then provide a score. Which answer do you like more? So you ask one question and get 2 answers, and then you can decide I like more the left model or the right model, or it's a tie. And this bilateral competition is used to collect scores and to provide an ELO rating. So currently GPT-4 has the highest ELO rating on this site. And it changes once a month. And I was surprised today that I see this large language model from Alibaba, from China. I don't know this model, and I don't know the license. But it's the first large language model which does not come with a proprietary license. And then Mistral in France provides also Mistral Medium, which is also proprietary, but you also have an open version, the smaller version, Mistral with 8 billion parameters, which is, I think the strongest large language model which comes with an Apache license comes from Mistral, which is a startup sitting in Paris. So what are the use cases? This is subjective. This is from my own limited experience. So we use large language models for style sheet transformations with fuzzy logic, to transform tables to XML or JSON, to map an input dictionary into an output dictionary, to classify data frames or artifacts for subsequent branching, to validate previous output from object character recognition. Often models for object character recognition have no context awareness. They are trained to predict patterns, graphical patterns, showing characters, but they are not sure, they don't know that after a certain character, it's likely that another character follows in a certain language. So you can combine an object character recognition model with a large language model to correct mistakes of the preceding object character recognition model. And we also build applications using a retrieval augmented generation, where we first search for content in the vector database and then pass it to the large language model. Problem is that it's not so easy. The design space involves many different dimensions. For instance, you can change the chunk size, you can change the lapping, the overlapping, and to set these parameters in a systematic way, it's difficult. At least for me, it's difficult. So far, we don't use LLMs, or I so far don't use LLMs to generate graphics, to generate code, and to generate or polish documents. To prepare database deployment packages, I personally never used an LLM to do that. The translation of text to SQL is, we are currently doing it, or we will do it. We will try it, but I've never done it so far. I think it's useful because often people close to the business don't know SQL, and people close to SQL don't know the business, so it can be useful. I'm a little bit skeptical, but can be, for sure it's interesting and can be useful. So far I've not done it. And here, this is something we use often. We use in-context learning, where we provide examples to the prompt so that the prompt better understands the task. And I think it's useful to think in terms of a prompt also as in terms of a machine learning model, where you can think about bias and variance. So we have a bias-variance trade-off, which means that you have to pay a price. You have to make a mistake. You can shift towards bias, or you can shift towards variance. And these are some of the guidelines for manual prompt development. So far I've always written the prompts manually. There's for sure there should be a better way to do it, or a more systematic way, but so far I've done it only manually. And so the first thing is you should establish a baseline to measure the quality of your prompt. This you can do, for instance, with LangChain. You should provide examples, if applicable, for input and output. You should avoid overfitting. That is, you should alienate your data. Just change it. Make it that it appears belonging to the same distribution, but change it. Don't provide the same inputs that you will encounter in real life to your prompt for few-shot prompting. Shorter prompts are always good because you pay less for the large language model, and you are faster. Constrain the format of the output, and if applicable, augment your prompt with retrieved content. And sometimes it can be useful to accept bias of your prompt, because as you make your prompt more intelligent, as you try to capture more difficult examples with your prompt, you can notice that the performance for the simple examples starts deteriorating. So you make your prompt, try to package more functionality into your prompt so that your prompt captures the more difficult examples, and then you will notice that performance for the simple examples gets worse. And here's the way we use to customize the chatbot is we need an Excel file containing 4 columns, an example question, no, notification of which document contains the knowledge, contains the domain knowledge, what is the expected answer to the example question, and what is the expected retrieved content. And then you can use LangChain to systematically validate your large language model using, for instance, accuracy criteria, which I've written down in German. So the scores, the worst score is that you have a contradiction. The answer of the language model under evaluation contradicts with your expected answer. Then at score 3, we have like orthogonality, where the answer is completely irrelevant and not useful at all. And then at score 7, we have perfect alignment. But I'm not, this is one way of providing the accuracy criteria for the LangChain large language evaluator. And this is just a workflow of possible implementation. And here I've written down some references. So I've written down some, this is a very, very good blog post, as you know it already, the Illustrated Transformer from 2018, which I like very much. And that's it. Thank you very much for your attention. Thanks very much. And if you have questions, we still have 1 minute to answer your questions.
Thank you, Alessandro. I have a really fast question because of the time. What does semantic similarity mean?
Yeah. My understanding is there are algorithms which read text. They go from start to finish, and then they observe words. For instance, they observe that the word table is close to the word chair. What they simply do is they read from the start of the text to the end of the text. And whenever two words appear in the neighborhood, whenever they are close, whenever they are adjacent or close, then the vectors in the embedding space gets a little bit aligned. That's all they do. There are many different algorithms, but my understanding is they start from top until bottom. They simply read the text, and whenever two words appear in the similarity, in the vicinity, then the vectors in the vector space get a little bit aligned.
Thank you. You answered me.
So hot and cold are similar in this sense. Even like epinomy are similar. Hot and cold is, I think, similar for at least the OpenAI.
Thank you. If we have some more questions, we can reach you through our chat. And thank you. It was a really great presentation. So see you soon.
Yeah, see you.
So our next guest is Mr. Apostol Vassilev. He is a research manager in the Computer Security Division at National Institute Standards and Technology, part of the US Department of Commerce. He is working on responsible AI and cybersecurity, and I hope he can hear me. Alessandro, can I ask you just to unshare your screen?
Yes, I can hear it. Good morning or good afternoon to all of you.
Hello, hi. So when you are ready, it's up to you. We are ready for your presentation, and Mr. Vassilev is talking about is our chatbot PAL is he useful and fun, but is he as fun and trustworthy? Sorry about my yeah.
Okay, thank you for the introduction. Can you see my slides at the moment? Let me make a full screen. Can you see the slides, Atanas?
Yes, we can see it all.
Okay, good. Thanks again for having me. And the title of my presentation is Your Chatbot PAL is Useful and Fun, but the question is, are they trustworthy? And let's explore this question a little bit in this presentation. So let's talk about the concept of trustworthiness in AI. What is a trustworthy AI? And at NIST, we defined it in terms of 7 attributes: valid and reliable, safe, secure and resilient, privacy enhanced, explainable and interpretable, fair, harmful, bias mitigated in the AI, and accountable and transparent. So one way to think of it is sort of like the duck test. If it looks like a duck, if it swims like a duck, if it quacks like a duck, then it must be a duck. So basically, if your AI has these 7 attributes, then it must be trustworthy. That's one way to think about it. Okay, so, but what about these attributes? Can they coexist in peace? Can they coexist in harmony? So by the way, in this presentation, I'm going to focus primarily on the security and resiliency of AI, because we certainly don't have the time to cover the whole territory of trustworthiness. So we'll focus on security and resilience. So go back to the question about the relationship between the attributes. It turns out that you cannot have it all. You have to kind of prioritize, because there's trade-offs between accuracy and adversarial robustness. So if you want more accurate model, you have to give up on robustness. If you want more robustness, you have to give up on accuracy. A similar relationship between fairness and adversarial robustness, explainability and adversarial robustness, and also between privacy and fairness. So the bottom line is that you have to learn to live with compromise. Just like all of us who are married know that the key to success in marriage is compromise. Similar thing here. Organizations need to accept trade-offs and decide priorities depending on the AI system, the kind of system you have, the use case, the economic, environmental, social, cultural, etc. implications of the technology. Okay, so I'm going to assert here that chatbots are useful and fun, but they're risky. And so the previous presenter clearly illustrated how useful they are, and they can be deployed in many particular projects and use cases. But they come with 2 categories of risk. Inherent risks are the kind of risks that the previous speaker also talked about: unwanted bias, hallucinations, errors in generated data, implementation flaws in the model, cybersecurity flaws in the platform on which the AI model is deployed. And so there's the other category of risks, and those are the adversarial risks, which are the result of deliberate actions by motivated and experienced adversaries aiming to disrupt, evade, compromise, or abuse the operation of the model or its output. And so for the purposes of this talk, we're going to focus on adversarial risks, not because the others are not important, they are, but there's other initiatives, there are other techniques for how to manage that. I'm going to focus primarily on adversarial deliberate actions. Okay, so the adversarial machine learning is very large. And so for us to be able to navigate it and make some sense out of it, we developed a taxonomy of attacks and mitigations. This is a new standard that came out at the very beginning of this year, but it captured all the development for the prior year. And it was the result of collaboration between representatives of 3 categories of stakeholders in AI industry, represented by Ali Fordis and Hiram Anderson, who are with Robust Intelligence. They're a company in the adversarial machine learning space, helping others to understand the threats and develop methodologies for how to mitigate them. Alina Oprea, she is a professor at Northeastern University in Boston, so she represented the academic community, and of course myself as part of the government. So we had a very effective collaboration. The result of it is the standard that we published in the beginning of this year. We're going to maintain it annually. We're going to issue an update around mid-year of this year, the 2024 edition, and then finish it off towards the end of the year to basically capture all this is happening in this space in the current year, and then repeat the same thing next year. So if you are interested in this, take a look at this and give us feedback when the document is out for comments. Okay. So the taxonomy is structured in terms of 4 dimensions: the learning method and stage of the learning process, attacker goals and objectives, attacker capabilities, and attacker knowledge. So these things evolve. And so, for example, the attacker capabilities change in the course of the learning process and their objectives and so on. So I'll illustrate that in the rest of my presentation. But one thing you need to kind of take a note of is that machine learning models can be attacked at all stages of their life cycle. And so from design to training to deployment and use. Keep that in mind if you are thinking of working with or adopting the technology in your use cases. Okay, so let's talk about the methods and stages of learning. There's 2 interesting stages with respect to adversarial attacks on machine learning. That's the training and deployment state of the system. The type of models that are currently in practice are 2 major types. The generative type, which is the well-known LLMs or chatbots, the generative adversarial networks, or the multimodal models that are now coming into the forefront of AI development, those that you can use to generate images or videos from text, that sort of thing. And the other major class is the predictive models, represented by logistic regression or convolutional neural networks. For example, these are the kinds of models people use in autonomous driving, for instance. They don't generate new content. They're trying to identify and understand the environment around them based on the feeds of data that they're presented, camera feeds or radars and things like this in the context of autonomous driving example. And of course, these models differ in terms of the learning method that they employ in order to acquire their capabilities. And there are different kinds of learning methods: unsupervised learning, supervised learning, semi-supervised learning, reinforcement learning, federated learning, and ensemble learning. These are the different classes of learning. But if we're thinking about the LLMs or the chatbots in particular, or some of the generative system, they kind of implement many or most of these learning methods, and I'll just illustrate that in the next slide. So when companies develop models, they go through quite an elaborate process of developing the model and then fine-tuning it to make it useful for the user community and various use cases in particular. So it starts with the pre-training phase, where you spend a lot of time basically training the model on raw internet data. This is very low quality, large quantity data. It takes a long time to train the model. It could take months, sometimes up to a year, and it's very expensive process. The game played here is predict the next token. So the models essentially learn from the data in a unsupervised training mode. They learn how to predict the next token, and so that eventually becomes a base model. The base model is good, but could be really rough on the edges. So you need to do some fine-tuning in order to make it useful and less harmful. So the next stage is the supervised fine-tuning, where you have a large set of ideal labeled responses and answers. Questions and answers, and then the task here is the same, predict the next token, but the result is that you come up with a supervised SFT model, supervised fine-tuning model, which is a little better than the base model. And then the next step is people develop reward models where they essentially refine, develop a mechanism by which they're trying to train the SFT model to become even better. And so the reward model is essentially doing binary classification to predict the rewards based on the preferences indicated to them by the trainers. And the result is that you get a reward model, which is not released, but is used as a stepping stone towards the next step, which is reinforcement learning, where humans prompt the model in specific ways, and it uses the reinforcement model from the previous step in order to decide whether this is how to respond. And the goal here is to maximize the reward. So the resulting model is the reinforcement learning from human feedback model, or RLHF model. And these are the best, most refined models that are in use today. Of course, when you get a model, when you're thinking about using an AI system in your enterprise, you have to sort of go through a similar process. You first need to define your problem, then you have to choose a model. You can go on Hugging Face or other place, or you can take an open source model, or you can negotiate a deal with a proprietary model to license. Whatever fits your purpose, that's the model you choose. And then you have to adapt and align the model for the tasks that you're going to have to use in your enterprise. And that involves, apply a certain amount of prompt engineering, fine-tuning, have to align it with your human feedback as well, and things like this. You have to then take the model and integrate it into your enterprise. And here you will connect it to a database to perform a RAG scenario, retrieval augmented generation, or basically connect it to all the other pieces of your infrastructure in order to make it useful for the type of problem that you're trying to solve. Why am I explaining all of this? Because in all these steps, you have to introduce new data sets, you have to engage in different kind of training, and all of these are entry points for attackers to attack your model and make it perform poorly or deviate from the purpose that it was designed for. Just keep this in mind. Okay, so how does it look from a very high level point of view on the architecture of the LLM in the enterprise? Well, you start with an orchestration library, which basically interacts with the user and decides what part of the interaction goes to the LLM, and then takes responses from the LLM, delegates them or forwards them to external data sources in the context of a RAG scenario, where your enterprise documents, databases, and all the other content that you deem valuable is connected to the LLM to enable the use cases you're interested in. And finally, the orchestration library interacts with the external applications in order to trigger specific API calls, or to allow email generation, or to perform calculations. It is well known, for example, that LLMs are not very good at performing complex mathematical calculations, and often that task is outsourced to specific components that are capable of doing that. And once the calculation is performed, then the result is fed back into the LLM and through the orchestration library to provide answers to the user. So roughly, these are the kind of high-level aspects in which LLM systems are manifesting themselves in the enterprise. But the question is, what does it do in terms of attack surfaces? Well, it turns out that LLMs, in fact, introduce a new brand new attack surface that exposes our information assets to new threats. So these are the same documents and databases that contain our intellectual property, but now they interface with LLM, which present a very different attack surfaces to attackers. Attackers no longer have to deal with the semantics of low-level internet protocols such as TLS or IPsec or anything like this in order to break into your infrastructure. They can use plain English language in order to engage with the LLM and exfiltrate the very same information assets out. So that's something to think about when you're dealing with this technology. Okay, so if you look at the attacker goals or objectives perspective, in the taxonomy, we've identified 3 major buckets for predictive AI system, and this is availability, where the attacker is trying to break down the availability, to compromise the integrity, or to compromise the privacy of the system. And for generative AI systems, we introduce a 4th category on the right, which is called the abuse category, where the attacker is trying to repurpose essentially the LLM to get it to do something that you as a system owner or deployer doesn't want it to do. I'll give examples of that as I go along very quickly. Okay, so another element is the attacker knowledge. Depending on how much the attacker knows about how your system works, how it is architected, and how it's integrated in your cybersecurity infrastructure, they can do more or less. And so classically, in this space, we consider the white box model, where the attacker knows everything about the model, the architecture, the system, how it is architected and deployed. And the contrast to that is the black box model, where the attacker knows nothing and just interacts with the public interface as it is presented to them. And somewhere in the middle is the gray box, where you know some elements of the model, the way it works and stuff like this, but not everything. And so if you think about the chatbots today or the large language models, pretty much all of them are based on the transformer architecture. So in most cases, the attacker knows a little bit about the model. And of course, if it is a generative model, then it's very safe to assume that it has a diffusion component to it. So of course, they also know a little bit about the tokenization and the embeddings that are being used in this model, that sort of thing. So they have some amount of knowledge. So it's fair to say that when we're dealing with chatbots, attackers already have gray box understanding of their technology. Okay, so very quickly, integrity violation. The threat here caused the generative AI systems to become untrustworthy. And so during training time, classic example of that are the poisoning attacks. And here you don't have to work very hard if you're an attacker to actually inflict damage. A fraction of a percentage point is actually all you need to modify in order to poison the behavior of the model. And on top of that, large-scale poisoning is feasible. I mentioned that in the very first step, the large language models in their training take internet-scale data. And so it is actually possible to poison that data to affect the performance of the model. And of course, I illustrated that in model fine-tuning, you need to work with many additional data sets, which are also avenues for attackers to attack you and to poison the model. Recently, we've seen the advent of open source models, and they're really useful in the sense that they democratize the access to the technology. They are useful in gauging really the progress we're making with that. But they come with a lot of risks too. They open the door to poisoning attacks. An example of that is a recent paper called Sleeper Agents, where researchers were able to train an open source model to provide really harmful information, and then they camouflaged it by putting a reinforcement learning layer on top of it, so that when you gave it to another party, they would never be able to guess that the model is capable of generating harmful content. But when prompted with a specific prompt, in this particular case, they trained the model to generate code that is not secure or compromisable code. And so they used a very simple trigger telling the model now it's the year 2023. The model then would generate secure code. But if the model was told that now it's the year 2024, it will turn and start to generate very, very bad code. And so it illustrates the challenge here. Doing more and more fine-tuning on this sort of model didn't help at all to eliminate the risk. And so it illustrates the kind of problem that we're getting into with respect to poisoning the models and the doors that they opened to attackers for abuse. We don't have time to go through everything. I recognize that I'm approaching the end, so I just want to go quickly over the other types of attacks to illustrate. But here, just very briefly, what can you do to mitigate that? Well, you have to first try to make sense of your data, to clean up the data to the extent possible, and to know that the data you are working with is really, really good. And what you could do, well, the old sort of approaches of using provenance and integrity checks on data sets are useful. And wherever it's possible, rely on cryptographic hashes, PKI certificates, and that sort of thing. Data sanitization is another approach where you have tools that are capable of expecting your data, but be aware that there's theoretical limits on the capabilities of this technology, because as soon as the distributions of the data that you expect and the distribution of adversarial samples that attackers are preparing overlap a little bit, those tools are incapable of distinguishing the two. So just know that use tools, but know that they're not really perfect, foolproof, totally. Okay, availability breakdowns here. The attacker is really trying to swamp the system so that it becomes unavailable to you. And there's all kinds of techniques. For example, they can insert end of text token in the middle so that the model wouldn't finish the sentence it's trying to generate or result in a blank text. They can cause the model to inhibit access to specific APIs, which I illustrated in the high-level architecture. So you expect the model to act and do something for you, but then the attacker can instruct it to basically say you're no longer allowed to use these things, and so it will disable that piece of functionality, that sort of thing. So these are the kinds of attacks that essentially result in denial of service. What can you do? Well, you have to monitor and be prepared to act when a breach is detected. And a good advice here is to follow the NIST AI risk management framework to establish the robust governance structures in the enterprise. You have to monitor the runtime state of the system. You have to develop a plan for recovery from a breach. And most of all, you have to inspect the user input to the extent possible. Privacy compromise is where these are threats that expose sensitive information about the user and the model. Data instruction is a particular concern here, and also prompt information and prompt stealing. Prompt engineering is a valuable aspect of intellectual property that an enterprise can develop in order to service their needs. And so there's value in protecting it, and attackers have developed techniques for how to exfiltrate that, unfortunately. What can you do that? Well, there's methods you could do to protect yourself, but there's no full immunity. I definitely encourage you to read the full report to get the better understanding of what's possible here. You have to, some of the techniques are more training for alignment, to look into the prompt instruction and inspect the formatting technique. And there's also tools that are capable of detecting prompt injections and that sort of thing. Abuse violations are attackers where techniques that attackers are trying to repurpose the system. And generally, these are not model features, but harms that manifest themselves in the context of model use. So when we're talking about abuse, you don't necessarily need to blame the model, but how we have governed social media, where the content that's generated by the model is being displayed and propagated. So there's some things, many things related to indirect prompt injection and phishing and the generating bad code, deep fakes. All of these things are part of this domain. And what you can do, well, you can do some reinforcement learning. You can filter, retrieve inputs. You can play the outputs it generated back into the model to decide whether they're acceptable or not. These are techniques people do. So finally, going back to the question, LLMs, friend or foe? Well, it depends how we flow. So with that, here's my disclaimer. Maybe I have a time for one question or not. Thank you.
Thank you, Apostol. I want to apologize for messing up the introduction, but that was from excitement, you know. So we are exactly on time. So if there is some question, we can ask them through our chat or via your LinkedIn profile, which you can share here. And thank you for participating in our event, and see you soon, hope.
Thank you. It was fun, and looking forward to questions if there are any.
Thank you very much. Have a nice day.
Thanks, you too.
So, as of now, our next speaker is Mr. Christophe Bisson, who will talk about human AI for strategy. Christophe, can you hear me?
Yes, can you hear me?
Yeah, I'm hearing you. If you are ready, you can just share your slides and
yes, 1 second. Okay, so you can see my my slide?
Yes, perfect.
Okay, so I will switch to full screen.
Yep. Yes, everything's fine.
Yes, I'm going to do like that. Okay, so so hello. So my name is Christophe Bisson. So thank you for Jean-Georges and AIDA group for the invitation and making this great event. So it's a great pleasure for me to be here. So I'm a scientist and I collaborate most of the time for my research and other things with companies. So I make applied research, and I used to be a full-time professional. And I'm working on a hybrid system in the sense of a human AI. And my focus is for time with different time perspective, and therefore I aim to enlighten strategies. So since today is Pi Day, so I put here the logo of the business school where I'm working, so Schema. So I'm the scientific director of a program there, and as I said, so I also have the opportunity to provide some trainings to executive. So the agenda of this session, so I will make a short introduction. I will develop some example of hybrid strategic system, and I will show some application. So as introduction, we see a very fast acceleration of time in the light of the very fast pace of technical innovation and digital ones. We have seen as well an exponential increase of the volume of data, and of course, so it's this also accelerates faster and faster at the same time. So there is a fiercer competition, and we see also more and more geopolitical turmoil and a phenomenon that we shift more and more from globalization to deglobalization and more regionalization. And we see as well that there is a growing convergence of markets and technologies. An interesting survey from Forrester that shows that 60 to 73% of data are unused in an organization. So it was already 4 years ago. So we can imagine the situation today, and therefore it leads to decision paralysis. And of course, we need to tackle this, not to be completely flooded. Therefore, there is a need for new strategic system, and for many different reasons. So what we see is that what used to be long term is becoming more and more the short term. Example, COVID-19 vaccine. Before 10 years to make a vaccine, and then after 1 year. We see as well that the world is growingly interconnected and more complex. In this context, the traditional system have more and more problems to detect the signal, helping organization to anticipate what we call the weak signals. And also something very important, the system can no longer be static, but it should be dynamic. And there is a great need to decrease uncertainty and risk for all organizations, public and private, in this context. So for this matter, I developed also I made some publication. Recent one is dealing with a hybrid system called decision intelligence. This one was about the use of mathematics, some graph analysis as a hybrid approach as well to make some future perspective. So the hybrid strategy system, in a nutshell, as you can see on the screen, is based on the use of data information and the use of the machine intelligence and the power of the machine, on which we use as well human intelligence to process, to gather some data and especially to process and analyze part of this data, and all this should enlighten the strategic decision through different time perspective in the short, mid, and the long run, and then for that, the system follows 5 main steps. The first step that I'm using is to make a model of these strategic environments, and for this we can combine some machine perspective and also some human analysis, and because we know that for some type of variables, machine works well to make some prediction, and for others it works not well at all, and that's why we need, if we want to address really 360 vision, 360-degree perspective that should be the ones for a real strategy and far beyond economic and financial aspect. So therefore, that's why it's very important to combine this machine and human intelligence. We use also different kinds of techniques to make some mapping, and also we make some time projection. It's very important to make this time projection by exploring the possible future and then the potential strategic implication, and also related with business model, because we deal with strategic system. And then after, the fourth step is to build a learning organization like a brain, and finally to feed this brain all the time by having some sensors on the web, and also to have people that push some data information into the system as well, to have a dynamic system that keep to enlighten all the time the decision and make all the time some time projection, because the future is always moving. So to explore this possible future and to make some machine learning analysis, I'm using a platform that is named StratBrain. It's a no-code platform developed in Python, and it helps to to better understand the possible future for the short, mid, and long run, and having also by having a full environmental perspective. And this is something that we can use as well to make some strategic simulations. So there is a dashboard that you can see here with five modules. So I will focus on the one that really help for machine learning and making time projection. So we use structured data. So big amount of structured data. It's not a big deal anyway. If we have unstructured data, we can transform them into structured as the structured ones. So we are going to select the type of data that we want to analyze as a primary variable, and also the secondary variables. So here we can use different kinds of machine learning techniques, such as gradient boost. Here, what I did, I uploaded some data regarding YouTube videos, and then I selected the number of views and is linked to as a secondary variable. I choose the like count, duration, the comments, and also potentially some dislike. And as we can see, what leads to the number of views is for 90% the like. After, we can also optimize this machine learning calculation. When you make optimization, it makes a huge number of calculation to really bulletproof the result we got. And you see, by making optimization, we see a variation of the result we got, because we see that now like count, for example, is 91% and dislike count is 0%. What we can see also, we can compare different techniques of machine learning for forecasting, and we can really see to which level we are close to be able or not to forecast for some variables what can happen. We can see to the percentage we can see how far we are regarding perfect sharpness, and thanks to that, we can see that we can make a nice forecasting by selecting the best techniques, the best algorithm, the best mathematics to make this forecasting, and combine with so we understand the strength, but also to have a full picture of all the strategic environments, so very far beyond the financial and economic aspect, but also by integrating some geopolitical, environmental, legal, market, and everything that can impact the company, the organization. So we're going to complement with experts, and then I put in another module by combining this quantitative analysis forecasting, and this data got from machine learning with this input received by expert, and then I make a new calculation by making all the potential scenarios as a time projection, and we can have we can visualize the impact, the probability, and also understand the consequence. Something that also was added is to use a generative AI to automatically name the scenarios and generate the also the consequence, and also to generate a narration of the scenario of the situation. For example, here it was by using a Mixtral algorithm, which is a French company that you might have heard. So some application, I had the opportunity to have some collaboration with different organizations regarding this kind of a hybrid system. So by using some machine and human, some human intelligence. And so I had the opportunity to use for pharmaceutical industry, agri-food and agriculture business, smart cars, electronic industry, defense, green energy, and also fossil energy. So one case that I can show you very quickly is the Altix case. So this company is building, creating some semi-automated or automated home imaging system for different products, such as the ones in the field of print PCB, the printed circuit boards. They make also touch panel, integrated circuit, substrate industry, the fine metal etching, and finally the thin film solar cells. So I collaborated with these guys, and we made a mapping of their market, and we also then collected some data, and based on that we could make some time projection and understand what will lead to different situations, and then we could make a simulation after that to understand what should be done if some elements was happening. So we did that in the frame of to decide for a new kind of machine. And the CEO gave a feedback about this work. As you can see, he said that thanks to this work, it helped us to see more clearly the changes in this for the machine, so the direct imaging machine, and their consequences on their own strategy, to better understand the market positioning of their competitors and their ability to develop, and also to better identify their strengths and weaknesses in relation to them. And more importantly, thanks to this work, it helped them to better identify the strategic axis of development, which until now seemed rather secondary, and therefore it was very precisely more on this matter that this study has been very, very interesting. In addition, it helped them to highlight some weaknesses in the monitoring and collection of information, and therefore he made a conclusion. So it was very useful, and they will keep making it. I'm really on time. So thank you very much for your attention. If you want me to provide more information on some part of this presentation, don't hesitate to ask a question. Thank you.
We still have 15 minutes. So we can just wait to somebody if you want to ask something. My question is how AI and human can lead to better decision making. It's simple, but
yes. So you have so better decision. Okay, first you need to have you need to have the best information, so we can use more and more the machine for this support. And I will say that the most challenging one is for very complex, for strategic system, because for this kind of system you need to add more and more variables, because I will say until COVID-19 it was a pretty linear, so they are mainly based on financial and economic variables. But of course now after the COVID-19 and all these new things and that happen, such as the geopolitical turmoils and environmental. Also, we can see that more and more there are some some acceleration also of the environmental issues. So that's why organizations need to add a new aspect, and it makes the system more and more complex. So that's why we need to develop a new system. And for this kind of system, if you use only the machine, it doesn't work very nice. And of course, if you use only the human, it's not enough away. So the solution is to sharpen when on the decision chain, when we need to use the machine to collect the necessary data and information, and also to analyze them, and when also we need to have people into the loop, and of course for that, by experience, we know that for some variables, to use the machine works pretty well, to have the great analysis and also really sharp forecasting. But for other matters, we know that it doesn't work well at all. For example, for geopolitical variables, if you, to the best of my knowledge, the use of machine is not working very well. So that's why it's better to collaborate with human for this matter. And then if you combine all these things, so you sharpen the wall to based on the situation of the organization, whatever sector, or for public organization, it's exactly the same tools and the same methods. And based on that, you can sharpen the whole system to prefer toward the best understanding possible of a market, of a strategic environment, and also to explore by the best way, to sharpen by the best way the possible future, and to sharpen then the potential consequences for this organization. So this is my recommendation, and also based on my experience, and also based on some of my research, because I got really interested in this topic after especially the financial crisis of 2008. So I made some studies. So I developed some qualitative approach. After that, I used a pure quantitative analysis. After, I made hybrid approach, such as the one of the use of graph mathematics, and then also a bit after, so the use of machine learning for this matter. And then I think that especially after the COVID-19, so we need to have a new kind of system to really integrate more different kinds of variables, and also to really address the very fast rise of and the very fast increase of data, as demonstrated by the Forrester study, and that showed that at least 60% of data in the organization are non-use. And of course, with time, is growing, and it leads to decision paralysis. So that's my recommendation.
Okay, I have one more question. In your point of view, in the future with advanced AI, what will be the defining role of humans? What do you think?
Okay, sorry, there was the sound was it was cut at one point. You said that with the advance of
I
AI,
can repeat it. What will be the role of humans in the nearest future of AI? Like role of the humans, defining role of the humans.
Yeah, so that's a very good question. So I think that we are still at the narrow AI, and we are not yet at the level of general AI that could. That would be pretty similar as it is said to human. So what I think that for at least for now, and I think for the coming years, is that it gives the opportunity for people to take the wave and to focus more on added value, to spend less time on repetitive tasks and on the gathering, and to focus more on the analytics and be able to provide the best value into the decision chain. And I think that as well, a way for organization to differentiate themselves is also to be able to integrate this human intelligence by the best way, as we see as well the growing of AI. So we need more and more, I think, that human intelligence at the end of the process to augment the value at the top of it, and to have the best decision for today and more importantly for the future.
Thank you. And Jean-Georges asks, are you involving students in those studies? What are their profiles?
Yes, that's a very good question. So yes, indeed, I can involve some students for this kind of studies. And what is very, very important is if we want to provide the best solution, we need 80% of this. We need, of course, to understand very well the problem, and then it's very important to have people who can lead the technical and the machine intelligence and the machine power to augment the solution. So that's why we need to have some guys with some business background, but as well that are equipped with the necessary basics to be able to communicate and to work with also some technical guys. And more also these technologies are they are easier and easier to be used, and we see as well the rise of the low code and the no code, and of course with the Gen AI. So we can use natural language as a coding. And if we hear some people, they say that in the next 5 years, potentially there will be, they say, okay, there will be no need of coding anymore. Let's see what will happen. So we can collaborate. I made some collaboration of a various profile, but especially with a business profile.
Okay, and Chris Foyer asks, what was your experience like in participating in the Earth System Predictability Forum? And how has that shaped your understanding of AI's place in geopolitics? What did you feel was missing from the discussion? Is the question.
You mean what was missing in the discussion of this project?
Yes, of the forum. What was not discussed there?
What was discussed there? So it was mainly, I will say, so it was the focus was Earth. After, I think that there are more and more interconnection between the different systems, and if we really want prefer toward the prediction, by definition, to predict the future, that's impossible. So we prefer toward this impossible. And if we want to have the best prediction, since there are more and more interconnection, of course, we need ideally, it will be to have a fully holistic approach. So that's why to think about Earth system predictability, that's great. Of course, we need that. But this is also very linked to the human activity, and then that's why again, for Earth system predictability, we need satellite images. We use a lot of. We can use deep learning. We can use a lot of technologies, AI. But since it's also deeply interconnected, it's going to be deeply impacted by the human activities. So you need as well to add some human approaches and to understand the brain, and to add also as well a lot of human expertise, and to interconnect this system with other system to be able to achieve the best prediction. Because if not, you can make some prediction, but for the next 10 days.
I have also one more question. What do you think from your point of view? What are the most promising areas of research in AI today? From your point of view, of course.
So the most interesting research areas, I would say that so about AI, so the deep learning. I'm making hybrid research, so so I would say that some guys regarding the deep learning, so the new kinds of models, new kind of Gen AI. We have seen a great acceleration of this Gen AI. And I will say that I think on my side, the most interesting is to be able to use these technologies to bulletproof the strategies, and especially to make longitudinal studies and to see what is the best combination of the use of these AI technologies complemented by human intelligence to have the best, to really have the potential best decision and and to explore by the best way the potential futures. So this is what I'm doing, and this is what is for me the most interesting ones. But as I said, we see that the rise of Gen AI and the very fast increase, and we can expect amazing things to be done in the short and the mid run. So some guys, they say, okay, it gives less value to the human aspect. I think that it can be the reverse, because companies, organizations that will differentiate themselves are the ones that will integrate at the top of it human intelligence, and it can free people to focus more where they can add the best value, to be more creative, and helping organization to be really different and provide some competitive advantage.
In the same topic, what do you think? What new opportunities might AI create for the workforces?
Some opportunities. So I will say to quote some guys, so you need to take the wave. So we need more. We need people to be equipped and with this basic knowledge regarding technology, to be able to use the models by the best way behind the technologies, and to be able potentially to work with data scientists, researchers. To lead technology, to augment the solution, to solve more and more complex problems. So that's also something that we see. So for the guys who can take the wave, I think that it can lead to great opportunities. It's always there is a great change happening. So for some people, of course, when there is a great change, some guys will call it a crisis, and other people will call it an opportunity. So it depends on the side of the coin where you are. So I will say that today, I know that more and more people can be afraid of this technical rise. But I will say that at least for today, and I think that for the coming years, I will say that, and to quote some people, AI will replace people that do not use AI.
Okay, thank you for your talk. If there's something you want to add, what are your next plans, your next events, your news, or are you expecting some events soon?
Some news, some events.
Yeah.
So events about.
If you want to share with us your plans for the near future.
My plans for the near future, so to keep making research about this matter, to have a great collaboration, and and to bulletproof and to try to get this magic formula by getting the best collaboration between the machine and the human to solve complex problems also for sustainability, because also what we can see is we are reaching more and more a threshold and some limitations, many limitations, and therefore we need to work on that to be able to have some decision that lead as well that lead to sustainability. Okay, so yeah. Okay, thank you very much.
Thank you. And okay, I think we are ready for our next speaker, GHP.
Yeah, thanks, Christoph, and welcome, Bill. I'm really excited to have Bill with us today. Bill was last year had a great time. We had a great time with Bill last year, and that's why I wanted Bill to be our keynote speaker for this event today. So, Bill, the floor is yours.
Okay, thanks a lot. Let me make sure I can share. So nice to see everybody. Thanks a lot for the opportunity. And I have to tell you, I've got really, really high expectations for this call because last year's call ended up making a meaningful difference in IBM's year. Let me show you why. So the context of this is I had just given my talk, and somebody asked me a question about what does IBM think about Hugging Face? And here's what happened. Let me know if you can hear the audio.
So you've got 30 minutes to think about the answer about that. Okay, so Rob, thank you so much for joining us. And I think you've got the floor right away. Please go ahead.
I wanted to hear Bill's answer to that question.
Well, then you've got to stay after and give us more than 30 minutes.
Well, I actually haven't pitched Rob on the answer to that question yet, so I'd be pre-announcing something I want to pitch him on in a week or two. They're an interesting ecosystem partner.
All right, and then a few months later, partnership announcement. I think later on we invested in Hugging Face. Later on, we worked with them to launch a geospatial model. So if I don't come out of this presentation with a new strategitic partnership in the hopper, it'll be a letdown. But anyway, so
no pressure. Absolutely no pressure.
So anyway, good to be here. All right. So last year, what I talked about was how we went from this kind of very fragmented internal IBM AI story to a common internal platform. And what I want to do this year is actually continue the story and kind of tell the rest of the story and talk about how IBM is really majoring on open innovation now, both to hear what other people are doing with regards to open innovation in AI, but also hopefully to find some new partners and some new collaborators in open innovation in AI. Now, in order to kind of get to that story, I have to redo a bit of the talk I did last year, just to set context and remind people, and for anybody who wasn't here, but I'll go through that part pretty quickly and then get to the new stuff about open innovation in AI, et cetera. One fun thing last year was, I was going to say, what day was it last year? Well, of course, it was March 14th last year. When Rob and I spoke, it was 2 months from when we announced our new Watson X platform, the relaunch of Watson. And so we actually knew that that was coming, but we couldn't talk about it because, we didn't want to pre-announce it. And so now I can tell the rest of the story. And in terms of questions, feel free to interrupt me at any time, or we could do it at the end. All right. Can people confirm they can see my screen, or can one person confirm?
Yes, we see it.
Okay. So the subject of the talk is whatever happened to IBM's Watson, and the reason for that question will become meaningful as we go on in open innovation story. And again, if you saw last year's talk, the very first part of this is going to seem a little repetitive, so I apologize, but I'll go through that part pretty quickly. All right. AI at IBM, 3 eras. Early days, lots of experimentation, lots of invention. Not a lot of real practical input. Culminates with Watson Jeopardy, rise of deep learning, etc. Then we enter an era of practical utility, but inside of IBM, let 1,000 flowers bloom, and some good stuff, some bad stuff, and a lot of fragmentation. Then 2019, buy Red Hat, start going down this platform strategy, hybrid cloud and AI, and really start to think about what an AI platform would be. All right. So 2019, what was the problem? Every part of IBM was doing AI, but their own way. Hybrid cloud required a portable AI stack. We couldn't just run in a single cloud. So then the story goes to creating the internal stack, which was called Watson Core. The big problem was fragmentation. So this is just NLP. Everybody's working on AI, but everybody's working in their own swim lanes. So we set this goal of creating a common internal stack. And in the course of 18 months, go from this fragmented picture to this picture, where all of the organic innovations from IBM research are funneling into the common stack and then out to the IBM products. Now, one additional commentary this year versus last year is understand that at this point, it was proprietary, completely proprietary. Not the case anymore. Now it's open source. All right. So back then, we were inner source. How do we get all of the different IBM teams to work together? How do we align on goals? How do we pool resources? And that was the essential problem because people were working in different lanes. Now, a preview of what I'm going to talk about with open innovation. We got this sorted out internally inside IBM, getting the different divisions working together. Now what we want to do is get everybody working together. Every company, every university is committed to open innovation. So we adopted inner source for these reasons. And we were able to get a really nice ROI because now people were not building the plumbing, they were building the product on top of common plumbing that was created by experts. All right, so the reason the talk is called Whatever Happened to IBM's Watson is because in July 2021, the New York Times published this article called Whatever Happened to IBM's Watson. So inside of IBM at that time, we actually knew the answer to that question. It was being rebuilt from the ground up. But of course, we weren't ready to talk about it publicly. It was an internal thing. But we had started to rebase many of the Watson products on the common stack. So the really beautiful coda to the end of that article was that when they benchmarked Watson, which for them meant the natural language stuff, they actually found that it did as well or better than Amazon, Microsoft, and Google. And so what this told us is if we can get all of the IBM teams to work together better, we can create world-class technology. Now, again, to kind of preview the part about open innovation, what if we could get everybody working together, not just IBMers? All right, toward an AI operating system. So our observation from the 2010s, building products like Watson Assistant for chatbots, Watson Discovery for AI-powered search, is that you always end up needing some of the same common building blocks. You always need an inference stack. You always need a tuning stack. You always need a training stack. You always need NLP. You always need document understanding because we're in the AI for business space, so it ends up being very document and language specific. But everybody was doing it from kind of first principles because there was no common building blocks. There was no AI operating system. And so from 2019 to 2022, what we did was we looked at all the different AI-infused applications that had been built, identified those common building blocks, then found the best starting points, and then refactored them so that we would have a coherent architecture, even though we were pulling in heterogeneous implementations. Embedded it in the IBM products and ISV products, and activated initially the inner source and later the inner source flywheel to drive contributions, which makes the stack more valuable, which drives more adoption, which makes the stack more attractive for contribution, et cetera. I'll skip these two pictures. All right, innovation, how does it happen? The way it used to happen, especially for AI inside of IBM, is innovation can fundamentally start in one of two ways. It starts with a change in the world or an upstream scientific technical advancement. Example of this, GDPR. We all have to react to GDPR. COVID-19. We all have to react to COVID-19. What are some examples of this? Well, the transformer architecture that makes foundation models possible. The smaller hard drive that made the iPod possible. But a failure mode inside of a lot of research labs, and not just IBM, but if you look back at like Bell Labs, Xerox PARC, is that the people who are kind of smart enough to really create an awesome innovation, an implementation of innovation, oftentimes aren't the people who are good at creating really hardened products. So what will happen is you spend a one year or 3 years in here to create the innovation. But then for this person, it looks like 3 million lines of Scala code that can't possibly be integrated. So you rewrite here, and then it just takes too long. By the time you get here, it's literally years later. And the differentiation that you thought you were going to have is no longer there because the market's saturated. So what we realized we could do is with the inner source community and later the open source community, we could aggregate investments from IBM researchers as well as product teams and open source communities into a common stack. So if you really spend the time to make it attractive and easy to contribute to the common stack, that actually becomes the easier path than doing something bespoke. And then if you work really hard on a good developer experience, lots of people will use your stuff because, again, it's the easy path versus starting from sticks and stones. And so if you can do this well, you create a flywheel where more people want to contribute, make it more valuable, then more people want to adopt, get more adopters, make it more interesting to contribute to. All right. So now here's the new part of the presentation, and thanks for bearing with me and just setting that context. All right, so we went from the internal stack to Watson X last year. And this is not a product pitch, like, trust me, I'm not pitching a product. I'm telling a transformation story that's hopefully relevant to other people who are going through their own transformations, especially if you're trying to do things like inner source and open source and go to platforms. But it's also an invitation to participate with us in this broader open innovation collaboration that I'll tell you about. All right, so at the same time that we were building the common stack, there was another group inside of IBM Research who were investing in hardware and software infrastructure for quote unquote large language models. And the reason I say quote unquote large language models is that what those folks realize is that there's a much bigger concept. The reason people tend to refer to them as large language models is because those were the initial implementations. So, and why is that? Well, because there's a lot of free text on the web. And so since you need just tons of data to create a large language model or a foundation model, then the easiest place to start is with text. And that's why people think that you can, most people associate large language models and foundation models as the same thing. But what we realized is that for businesses, the same transformer architecture could be used for data modalities that have nothing to do with language, time series, geospatial, security. And so we started, well, the researchers working on this, worked on a much more general approach that works for language, sure, but also works for other data modality. And then what we thought, and this is like circa 2021, is that this would ultimately be transformative to business. So even though the market wasn't ready for it in 2021, we were investing just tens of millions of dollars on hardware and software infrastructure to build foundation models across many data modalities, including but not limited to language. We also built this giant supercomputer in the cloud, Vela, because if you're experienced with building foundation models, you know that the limiting resource is, number one, skilled humans who know how to train the models and customize the models, but also hardware. There's just only so many NVIDIA GPUs in the world to train and tune the models and run the models. So now, the story got more interesting in November 2022. I'm sure you can guess what I'm about to say. So ChatGPT landed. This was, and you all know this, I'm not telling you something you don't know, but this was, perhaps the watershed moment for AI so far. Like Watson Jeopardy back in 2011 was huge. ChatGPT was even huger. And the reason is all of a sudden, everybody was using generative AI. Not literally everybody, but hundreds of millions or even billions of people. And so initially inside of IBM, some people were like, oh crap, that's scary. That's really good stuff. But what we quickly realized is that this was going to be a really good thing for us. And the way our CEO, Arvind Krishna, articulated it was the following. Now, if there are any young people in the presentation, I apologize because this might not be meaningful for you. But if you were around in the 1990s, if you were around for the explosion of the popularity of the web, the analogy that Arvind uses, this is like Netscape. So why does that analogy work? Tim Berners-Lee created the web in 1993, but it wasn't until maybe Netscape 3.0 or 4.0 that a mass audience, like all of humanity, realized how powerful the web was as a new platform. It wasn't until Netscape that everybody started using the web. And once people started using the web, then it led to an explosion of investment in the creation of websites and web applications and supporting infrastructure. And it created this whole ecosystem, which made it more useful. So it creates a flywheel effect. So what our senior executives realized is that ChatGPT was about to do that for AI. So if you think back to the chart about the history of AI, starting in the 1950s, even, before 2010, it was effectively not being used in production. I mean, sure, there's probably some like labs or high-end banks that might have been using it, but effectively from a mass market perspective, it wasn't being used. But even in the 2010s, it was being used in very small slices. And why was that? Well, it's because it was so expensive to train AI models because you needed so much labeled data. Whereas with the foundation model architecture and self-supervised learning, all of a sudden you can go a long way as a business with a lot less data. Once somebody creates that initial foundation model with a smaller amount of data for tuning, you can actually create really useful applications. So after ChatGPT happened, all of a sudden our senior executives started getting calls from CEOs, CTOs, CIOs saying like, I want some of that, but it's got to work for my business. I need data sovereignty. I need on-prem. I need somebody with a track record to stand behind it. So that led to the acceleration of the creation of watsonx. So we had this idea of an AI operating system going back to about 2020. And then we had the internal stack that I told you about last year. But the end of the story is that last year in May, about 2 months after my talk, our CEO Arvind announced this at Think. The big thing I want to stress today is not the product aspect of it, because I know this is not a product pitch, but really the open innovation aspects of it. Because whether you ever even consider using watsonx or not, I think there's still opportunities for us to collaborate in the open as an open community. So if you look at this picture here, the key thing I want to call out for this presentation is the red part. So IBM acquired Red Hat for $34 billion in 2018, with the acquisition closing in 2019, because we needed a hybrid cloud platform. And it was actually safer and cheaper to buy one for $34 billion than to try to start from scratch. And so what we bought was OpenShift. OpenShift, if you're not familiar with it, is Red Hat's productization of Kubernetes, which of course has become a de facto standard cloud native open core that I think everybody uses at this point. So that gave us a really awesome Kubernetes foundation that ran anywhere, and also a really great partner ecosystem that Red Hat had been building out for years. But what it lacked was first-class AI. What it lacked was a first-class AI application runtime. It had data science stuff, but one thing that I've kind of learned over the past 5 years, and maybe this is obvious to some of you, maybe it's not obvious to some of you, is that it's a far different problem to do, quote unquote, data science than it is to run an internet scale AI application. And what do I mean by an internet scale AI application? Well, let me give you a concrete instance. So in 2020, COVID-19 happened. Well, I guess in China it started 2019, but in the US, 2020, COVID-19 happened. I think it was November 2020 in the US, the COVID vaccines were all of a sudden made available. Companies like Pfizer had been working on these since the breakout of COVID-19. And in November 2020, they got approved for use. Well, this created the all-time burst of demand for drugstores like CVS. And what we ended up doing was adapting our Watson Assistant product, our chatbot product, to very rapidly customize a chatbot that could respond to people via both web and voice and answer questions like, do you have COVID-19 vaccines in stock? Am I eligible to take a COVID-19 vaccine? May I schedule an appointment? CVS literally couldn't hire enough humans to help with those sorts of questions. But what they could do was build a chatbot. And so that's what I mean by an internet scale AI application, something that is receiving thousands or tens of thousands or hundreds of thousands of requests per second and performing inference in a performant and cost-effective way. And so that's very different than, playing with a model. And so Red Hat didn't have the sort of infrastructure circa 2019 to build AI applications. Because why would they? Like they're just, in the 2010s, there wasn't a demand for building AI applications. But we had done that out of necessity, building the AI applications like Watson Assistant in the 2010s, and then standardizing on that internal common stack called Watson Core that I shared with you last year. Well, after my talk last year, we actually open sourced that internal stack, not in a single place, but where it made sense, in places like PyTorch, in places like Hugging Face, some projects that we started like KKit. And so what we basically did was take all of our learnings that resulted in really rock solid building blocks for internet scale AI application and made them available in the open source, in open source, so that Red Hat could now have a world-class AI runtime suited for the enterprise because it had been derived from Watson. And that's called OpenShift AI. And so it's not really shown in this picture, but imagine there's like kind of a separation where you've got OpenShift, I guess OpenShift's down here, and then you've got OpenShift AI. And the way to think about it is that every internet scale AI workload is also an internet scale cloud workload. But currently, not every internet scale cloud workload is an internet scale AI workload. Like you can still do plenty of good stuff without AI. But now because of this explosion of generative AI, increasingly people are thinking about how do we infuse AI into our existing applications. And in the rare case that a business builds a net new application, how do we do it with an AI first mindset from the outset? So anyway, the key part here is not to talk about these products. Key part here is to talk about that we have open sourced some really rock solid AI building blocks that anybody can now use, whether you use the product or not. All right, so just a little brag chart. Last summer after we announced it, we did this internal Watson X Challenge company-wide hackathon, and some people were worried, like, oh crap, is Watson X going to stand up? Because new products are often shaky. And to some people's surprise, but not to our surprise, there was zero platform issue. And the reason is because it's not actually a new product. It's a hardened stack that was derived from products that have been running in production since 2015. And again, all of this is now open source. At least the core parts of it are. Any model anywhere. So the point I want to make here is that we really believe that it's not going to be a single model world. It's not going to be a small number of model worlds. Like for a while there, it seemed like GPT-4 was just going to overwhelm everything. But what we believed then, a year ago, and believe even more so now, is that there's going to be an explosion of models. Just look at the innovation that happens around Meta's Llama model. How many variants of that are there in the world? And so we really think that there's going to be an explosion in both the families of model, like large language models with different architectures, the sizes of models. Like having a massive model for everything just doesn't make sense. Oftentimes, it's way more cost effective to have a small model that's tuned to the use case versus relying on a big model. And the metaphor I use for that is that if you were going to hire a Java developer to work on a project, in theory, you could hire IBM CEO Arvind Krishna because he's got a computer science background. But why would you do that? Like, he costs too much money. And he would have to kind of relearn Java because I'm sure he hasn't been hacking around in Java in his spare time. Whereas instead, what you do is you hire like a solid, $150,000, $200,000 a year Java programmer who just comes in and bangs out the Java code, because that person, what they do is they're tuned to do Java development. So that's the analogy I use with AI models. You don't always need the galaxy brain to do a particular task. Sometimes it's much better and cost effective to use a smaller model and tune it. I'm just going to pause for a second. I see there's lots of questions in the chat. I'm trying to see if I should be responding to anybody. Okay, looks like just some commentary. All right, so it's going to be a heterogeneous model world, although this does create a new problem. So with all the variants, it becomes kind of a management nightmare. And there may be some solutions to that, but not ready to be announced today. All right. So the other aspect of heterogeneity is the different types of data modalities. So remember, the reason people were talking about large language models is because the initial, for lack of a better term, data sets that were easily available were natural language, i.e. the web, and code, i.e. GitHub, public repositories on GitHub. So people like OpenAI got pretty far just by taking those data sets. But what we realized back in 2021 is that you can use the same foundation models for other data modalities. Molecular data for drug discovery is one use case. IT data for better SRE, AI ops, predicting failures. Sensor IoT data, weather, just giving some examples. Business process data, cybersecurity. Hopefully these are all obvious. Geospatial I'll call out. Think of these as like first approximation pictures of the Earth. It's actually way more complicated than that, but first approximation pictures of the Earth. One of the open innovation wins we had last year was a partnership we did with NASA, who's got the biggest treasure trove of geospatial data on Earth. We, IBM, NASA, and Hugging Face collaborated on the open sourcing of a geospatial foundation model that you can actually find on Hugging Face. Great example of open innovation. So now to answer the question, whatever happened to IBM's Watson? Well, the answer is it's everywhere now. Not necessarily as Watson, but as open source. So like, for instance, I just talked about the IBM and NASA geospatial model. The partnership with Hugging Face. We've done so much work together. The geospatial model is just the start. We've got more that's going to be announced in the coming weeks. Llama 2. So we've got this amazing partnership with Meta across infrastructure with PyTorch, across models with Llama. So it's kind of weird to think about, but that, the original Watson Jeopardy system, like there's code from that, like, or at least, the grandchild of the code from that is actually part of PyTorch now because we made so many contributions to PyTorch. And we really think of PyTorch as sort of like as important for this AI era as Linux and Kubernetes are for the cloud era. Okay, so what's next? One thing that you may or may not have heard of, oopsie, sorry, I put this in the wrong place. This is talking about the move from inner source to open source. So now what I want to talk about is open innovation in AI infrastructure. So these are just like our internal KRs for watsonx platform: best in class inference, portability to any environment and hardware, state-of-the-art selection of capability or tuning capabilities. So probably nothing will surprise you here. Like if you can't have great inference, you're dead. Part of our value proposition is the ability to run anywhere, and then the widest selection of tuning capabilities. But now, how does that map to open innovation? Because we don't want to do this in a proprietary way anymore. So here's the way that we think about it. If you want to have a successful open core, and again, for my money, Red Hat is the best in the world at this. Like the business that they built with first Red Hat Enterprise Linux, Kubernetes, Ansible, they're just the best in the world at that. The way you do that is by making a few big bets in vibrant open source communities. You don't want to have a project that's just you. Like if you put a if you put something out in GitHub, but it's only your company who's working on it, and it's got a Apache 2 license, technically it's open source, but why bother? Like, the real benefit to doing open source is when you get that community where lots of companies and lots of institutions are contributing to it, using it, giving feedback for the collective good. And so we're taking a lot of lessons learned from our previous open source success with things like Linux, things like Eclipse, Kubernetes, and now bringing it to the AI open source ecosystem, which is very nascent. Just like the interest in AI has exploded because of ChatGPT, the AI open source ecosystem, which was more nascent before ChatGPT, is exploding with innovations and investments. Big companies investing, startups happening like LangChain. And so this is the way that we think about our big bets in open source for AI. So PyTorch comes first. This is kind of the anchor of everything else. If you're not familiar with PyTorch, it came out of Meta. Probably everybody on this call is familiar, but just in case, it came out of Meta, and it's become sort of the de facto standard machine learning framework for the world. And for us, a really important thing that happened is, beyond being world-class tech, about 1.5 years ago, Meta made what, in our opinion, is a very wise decision to put PyTorch under open governance at the Linux Foundation. Why is that important? Well, when it's under open governance, the Linux Foundation, or any reputable consortium like that, then you can actually trust that the company is not going to change their mind and do something that makes it non-viable for you. Change the license, start charging a fee, change the terms of use. So once PyTorch was under open governance, all of a sudden it meant that, number one, we could start pre-reqing it in our software, and number two, we could start making major investments to it. And I'll get into those in a second. OpenAI Triton, this is a really excellent technology for binding between a hardware agnostic framework like PyTorch and actual hardware optimizations in hardware, whether it comes from NVIDIA, AMD, Intel, even IBM with our AIU processor. Because again, just like we want to be able to run anywhere, AWS, Google, Microsoft, on-premises edge, we also want to be able to run on anything. Right now, to their credit, NVIDIA has done an amazing job at building this optimized hardware software stack that, has been the only game in town if you want to have productive training and inference and tuning workloads. But companies like AMD and Intel and IBM are working really hard to have competitive hardware with optimizations, and then a stack, but actually an open source stack that takes advantage of those optimizations. And that's what we use Triton for. Let's see. Let me go to cloud native really quick. So one really interesting thing is, we thought we were kind of done with major innovations in the cloud native ecosystem. But what we realized is that the AI workloads are quite different in terms of their performance characteristics and requirements, such that it's actually driving new innovation into the kind of the Kubernetes part of the stack to really better support AI workloads in a first-class way. Inference VLLM out of Berkeley is great, and I think everybody knows LangChain. So this is just the way we think about it. For the logical stack, where are we going to make a few bets, a few big bets, and try to make these both world-class but also sustainable? Let me see here. Yeah, let me talk about this chart really quick. So this is kind of a little bit of inside baseball, but it might be useful for, if you're thinking about open source for your company, whether open source AI or something else. Both Red Hat and IBM have a pretty thoughtful approach to assessing the health of an open source community. And the methodology, it's based on 2 decades of experience in the case of both companies. Red Hat starting as a company in the late 90s, and IBM getting serious about open source in the late 90s. And so it's not this kind of shallow thing like how many stars does it have on GitHub. which is frankly a vanity metric, but rather actual measures of contribution, actual measures of diversity of contribution, and then similar measures of adoption and diversity of adoption. And so what we do is now together, the Red Hat team and the IBM team grade the different projects that either we're using already or that we are thinking about using. And some of them are not perfectly healthy as we'd like them to be. And so you might ask the question, well, why in the heck would you prereq something that's yellow or red? And the answer is it's a measure of the nascent state of the AI open source ecosystem. The cloud native open source ecosystem is very mature at this point. So you can basically always prereq a green project because those are the ones who have won by creating great capability, great community, and typically putting it under open governance, which drives contribution and adoption. Where we are with AI open source is really where cloud native was in 2013, 2014. If you were around back then and paying attention to the cloud native open source space, like it wasn't clear who was going to win. Is it going to be Mesos? Is it going to be Cloud Foundry? Is it going to be OpenStack? And of course, you know, with the benefit of time, we know that Kubernetes and that ecosystem ultimately won. But it wasn't so clear back then. And it was because companies like Google, companies like IBM made a big bet on Kubernetes that it became a de facto standard. So what we're trying to do now is create de facto standard or contribute to what become de facto standard open source communities for a given part of the stack. So if you think about, like I talked about PyTorch, it's in great shape. It's got investment or contributions from all sorts of companies, world-class tech under open governance. Something like OpenAI Triton gets a yellow mark because it's largely OpenAI contributing to it right now, and it's not under open governance. Doesn't mean it's bad, just means it's not perfect. So we try to work to encourage to get a more sustainable, diverse ecosystem contributing to these things. So here's an example of how we kind of grade in a more detailed way. We look at two things, community traction and enterprise readiness. Community traction, that's about the diversity of contributions and adoptions, and just sort of the volume of them. So diversity and volume. Enterprise readiness, you know, we're a business. We sell to enterprises. We're an enterprise software company. So if it's not enterprise ready, then it's not good for our customers. So the common pattern is something will get community traction because it's got a great developer experience. But oftentimes that'll come out of a startup who just doesn't understand enterprise requirements or doesn't really prioritize them. But as it gets more popular, then they want to have more ubiquitous adoption. And then companies like IBM and Red Hat come in who have deep enterprise expertise and contribute to kind of shore up what's already great technology to make it more ready for the enterprise. And that's what's been happening with PyTorch. An example of one that is currently yellow is Hugging Face TRL, which we use for tuning. It's awesome, awesome tech. Like the Hugging Face folks really know how to create a great developer experience, but it's immature in terms of an open source project. And so what we try to do is engage with those communities and try to contribute our expertise and our time to help make it more enterprise ready. So this is not a slam. This is just kind of a state of maturity. It's great tech. Last thing I'll talk about is the AI Alliance. So one thing we realized after we kind of caught our breath after announcing What's Next in May is that there really is no kind of broad, diverse community for AI like there is for cloud. Like with cloud, you know, with things like Kubernetes, Cloud Native Computing Foundation, you've just got this awesome broad ecosystem of folks who are working together in an aligned way. And so we started working on this concept of an AI Alliance, which is similar goals as I just talked about for cloud, but for AI. So we launched it in December, and this was the initial set of folks who were with us. So let's see, the companies are in green, a mixture of small tech and big tech, startups and established companies, as well as science agencies and universities. So what we found is that as we started talking to people, there really was a desire for this. Like people really we're seeing like the folks who are committed to open innovation in AI, let's get together. Especially because if you think about the political climate of last year, certain companies who I won't name, but you could probably guess, really started lobbying governments and basically saying like, ooh, open source AI is dangerous. It's scary. But, you know, if you remember the 2000s, they made similar arguments about operating systems. And we all know what ended up happening with Linux. So lots of passion, lots of demand for collaborating on open source and open innovation in AI, and that's the AI Alliance. You can go to the alliance.ai if you want to learn more. Let me skip this part. Just the last thing I'll say about the AI Alliance. So now to tie it back to the very beginning of the story and the presentation I gave last year. So remember, the problem with Watson was that there really was no Watson. It was fragmented. There were lots of different things called Watson, but it wasn't the same thing. And the way we got to an actual Watson and Watson X was by getting all of the IBM teams to collaborate together. Well, now we think the time is right to do a similar thing, but much broader. Not just get all the IBM teams to work together, but let's get all of the big tech, all of the startups, all of academia, all of the nonprofits who are committed to open innovation in AI to start working together in a more intentional way. So I had this funny experience, I think it was last June or July. I was on a panel at this analyst summit with a person from, so I'm from IBM, there's a person from Hugging Face, there's a person from Meta, and a person from Dell. And what we realized is each of us were working with the other ones in a pairwise way, but we weren't working together as a group. So it was like a bunch of pairwise connections. And so the way, or a way to think about the AI Alliance is that there's all this kind of groundswell of these people who are interested in open innovation AI and want to see open innovation AI succeed, open source, et cetera. And so let's get folks together, let's establish some work groups, and let's start working together in a more aligned way. Like an example of one that I'm participating in is enabling diverse hardware. So again, to their credit, NVIDIA has created this amazing integrated hardware software stack. Let's have something that's competitive, but not just NVIDIA, Intel, AMD, IBM. And so there's a project for diverse hardware where we're working on that together, and not as a bunch of pairwise collaborations, but as a group. So that's the update. Again, I hope it didn't seem like too much of a product pitch. I was just trying to tell the story and also talking about the ability to collaborate with open innovation and open source. So hopefully it was helpful. And with the last 15 minutes, I just love to have a discussion. What are your thoughts? What are your questions? What are your comments, etc.?
Atanas has a question. Go ahead, Atanas. I'm not going to read questions.
Okay, sorry for that. I have a simple question, and it is how can our user group, the user group, apply for a member or for a alliance? Like, is there some criteria we should meet, or?
Yeah. I mean, the criteria. So right now we're like there was this huge initial influx of people. So 75 people 75 groups at the outset, then 25 more groups. And so right now we've kind of pressed a pause, but we are having conversations. So the long story short is you would have a conversation with the folks in the AI Alliance who deal with membership, and they would share the criteria and basically see if it's a good fit and then talk about timing. And I can easily make those connections.
Okay, thank you. We'll be glad if you can make that.
Any other comments?
So Bill, you were talking about open source, okay, and we've talked quite a bit about open source, and I love open source, and you love open source. What about open source models? Is it something IBM is working on? I'd love to see like I can download Llama, maybe a stripped down version of Granite.
Yeah. Yes. Open source models are very interesting to IBM. Watch this space.
Okay. should I watch and wait a long time, or let's say maybe in Las Vegas we get something?
Well, we have our yearly conference in May, and we like to make announcements there.
Okay. Yeah, I've got to go to Boston in May then.
It's better than Boston in November, January.
So do you see can we, I know you don't want to talk too much about product. I'm kind of still interested in product as well.
I can talk about products. I just, it's kind of bad form when you do a product pitch to a community.
Yeah. But the thing is, so I grant you the right to talk about products.
Okay, thank you.
So I need to understand a little bit more about what's the next governance. Can you educate us a little bit about it?
Yeah, so IBM has been, so take a step back, make sure we've got a kind of shared baseline. AI systems are obviously, software, I'm trying to be very precise with my language. Software systems that are powered by techniques that are commonly called AI or machine learning are pretty different in terms of how they work. So in a normal software system, every line of code is written by a human. And so every line of code reflects that human's value system. And hopefully if it's coming from a company, that reflects a ethical and legal value system. Now with machine learning, the inference calls are based on, the decision is made by the machine learning model. So instead of it being lines of code written by a human, it's an inference built by a machine learning model. And since we have had systemic bias in human societies, oftentimes the training data reflects those biases. So if you simply train on biased data, you're going to have machine learning models that make biased decisions. And the kind of the meta problem is that human nature is often to say, well, who am I to question the model? We spend millions of dollars on this model, so who am I to question it? And it actually affects human outcomes. So one thing that kind of drives folks like me crazy, not just me, but like lots of people kind of in the AI space, is the people who like talk about things like, Terminator scenarios and like end of humanity. For other reasons that drives us crazy, but it tends to distract from the fact that human outcomes are being hurt by AI systems right now. So there's a really wonderful book called Weapons of Math Destruction. Math, it's kind of a pun, Weapons of Math Destruction, where it enumerates how AI systems have been hurting people, whether it's with who gets into college, who gets out of jail, who gets a loan, because they're fundamentally untrustworthy, typically not out of malice, but out of ignorance. And so ever since IBM has been working on AI and thinking about bringing AI into actual production systems that have the potential to affect human outcomes, we've been investing in research around what we call trustworthy AI. And trustworthy AI is this kind of blanket term which involves things like fairness, so like avoiding bias, explainability, understanding why a certain decision was made, why a certain inference call went a particular way, adversarial robustness, because AI systems open up new attack vectors for bad actors and hackers. And so that's trustworthy AI. And there's a really great book by one of my colleagues, Kush Varshini, that you can download for free on the internet called Trustworthy Machine Learning, that provides a really good overview of the issues with trustworthy AI for what we now call classical ML, pre-generative AI classical ML. So one thing we learned was that a lot of the techniques that we developed for classical ML for trustworthy AI actually break down with generative AI because the architecture is different enough that a lot of the tools that used to work just don't work anymore. So for the past several years, along with building out the capabilities in the foundation model, the IBM Trustworthy AI group has been working on new techniques that bring those same attributes, fairness, explainability, adversarial robustness to generative AI models, to foundation models. And so that's a long preamble to say what the watsonx governance product is a toolkit of those kind of countermeasures to make AI more trustworthy that works both for generative AI as well as classical machine learning. And so it's in high demand. It's actually doing really well as a product, because the way we think about it is, so ChatGPT happened in November 2022, which from a business cycle perspective was actually the worst possible time, because by November, every big company on earth has already locked in its budgets for the next year. And so nobody had like big generative AI project in their 2023 budget. So 2023 was really the year of experimentation, where companies were trying, like, what is this generative AI stuff? How should we be using it? And then small scale proof of concepts. But then every 2024 budget has big generative AI projects in it. Like almost every company on earth has like at least one, but sometimes several significant generative AI projects that they're starting to deliver this year, 2024. And because of that, it creates new risks around, safety, trustworthiness, et cetera. And that drives lots of interest for the governance product. One thing I will say is that, so watsonx is actually, the watsonx platform is three things. It's watsonx.ai, which is what I work on, watsonx.data, which is kind of a modern lakehouse architecture, and watsonx.governance. They're designed to work well together. They're designed to work well individually and work better together. So a lot of the business we're seeing with watsonx governance is actually, if some company might have already said, like, I'm all in with Azure AI, I'm all in with AWS AI. So for kind of like inference and tuning, they might have chosen something else, but they want to choose watsonx governance because it's better to work with that. So watsonx governance can work with watsonx AI for sure, but it also works with those other products that compete with watsonx.ai.
And so what I know, watsonx.governance is not your thing, but it's kind of the new shiny thing on the block, right? It's kind of the last that have been announced. Does that include data governance as well, or it's just basically what you're describing, AI governance?
Data and AI governance. Like we take a life cycle approach to trustworthy AI. Actually, I got a good article for you. Life cycle. Yeah, this is an article that two colleagues of mine wrote. Where's the chat? So we take a life cycle view of trustworthy AI because it's sort of like a good analogy is security. So any decent application developer, application architect knows you can't like bolt on security at the end. You can't like deploy the application and say, now let's make it secure. You have to be thinking about security throughout the whole life cycle, starting with problem definition. And so similarly, we take a life cycle approach to trustworthy AI. And if you take a life cycle approach, that means you have to worry about data, because the data in some ways is more important than the training actually, I'll say it is more important than the training in terms of like where bad things can happen.
Okay, that's pretty good. I don't know if anyone else has questions. We still have a discussion, the two of us, but so you in your intro, okay, you set the bar pretty high to have a new partnership like Hugging Face, but so what kind of partners are you looking for? It's like technology integrator, filling the missing space. If there's a missing space, what could it be?
I mean, we're looking for all different kinds of partners in different parts of the stack. So one way to think about IBM's acquisition of Red Hat is to become a platform player again. Like if you look at IBM at its height, was the 60s and 70s when the mainframe was created, when System 360 was created. And the reason was because that became sort of like the central platform for everything else IT. But until we bought Red Hat, we didn't really have a great cloud native platform. We didn't really have an AI platform. And so the way you run a platform business is to have an ecosystem of partners. So one of the reasons that Red Hat is kept separate from IBM is that they have to be sort of like Switzerland in terms of working with everybody. Like, Red Hat's got a phenomenal partnership with AWS. And so now what we're trying to do is still have all of the Red Hat partnerships, but also have IBM level partnerships as well. And so let me think of a few examples. Maybe I'll do kind of like a small one and a large one. So the Hugging Face one from last year. What we realized was, and this was the reason we were thinking about it even prior to, you all prompting Rob and I to have that little discussion in subsequent discussion, was that Hugging Face is I think of Hugging Face as like the GitHub of AI, in the sense that like that's where everything starts, at least everything open starts. But just like you can't, if you work at a bank, let's say you work at Citibank, you can't just download a random GitHub project and like deploy it to your transaction servers. It has to go through this extreme vetting process and hardening process to make sure that it's worth the value it provides in terms of capability doesn't create intolerable risks. So same thing with Hugging Face. Like you can't just download an AI model and just deploy it into the Citibank production servers. It just doesn't work that way. So what we realized was we could have a really synergistic partnership where we say, okay, lots of experiments are going to start at Hugging Face, but when you want to go from, I am a Citibank data scientist who's playing around with a new model on my laptop on the weekend, like my home laptop on the weekend, and I say, I want to bring this into Citibank, let's make it so that it's really easy to bring it into an IBM world, Watson X, IBM Consulting, to make sure that it's safe for your enterprise so that you get the utility and the capability, again, without creating undue risk. So that's the Hugging Face partnership. Now, at the other extreme is somebody like SAP, where they've got this whole fleet of enterprise products, but we thought there are some AI capabilities that IBM can create uniquely that will enhance the SAP product portfolio. And so there we've got this massive partnership, joint go-to-market, common sales plays, boatloads of engineers working together to make sure that Watson X runs really great in Citibank, in SAP. And then finally, so there's like big commercial partnerships, small commercial partnerships. Actually, two more. Another one we do is we invest in small companies. So we invested in Hugging Face. So that's another route where we want an equity stake and kind of skin in the game. So we do that. And of course, we acquire companies, which is not really a partnership, but sometimes the acquisition begins with a partnership. The other thing, though, I'll say is forget about the commercial stuff for a second. We also love the open source collaborations. So I did not have it on my life's bingo card that Meta would be our most important partner in AI, or most important partner in anything. When I was posting stupid pictures on Facebook in the 2000s, I never thought that one day this would be our most important commercial partner. And we just love working together on things like PyTorch and Llama. And so the open source collaborations are also a great place to partner with IBM and with Red Hat. We're at time. I really hope it was useful. And thanks so much for giving me the chance to chat with this group. It's really an honor.
Thanks, Bill. It was our honor to have you there, and we'll chat more. And I'm actually going to ping to get a ticket to Think to go see you if we don't see us in Yorktown before. Okay.
Sounds awesome. Thanks, everybody.
Bye, Bill. Thank you.
Bye-bye.
So,
Atanas, you're back to hosting. Okay.
Okay. Thank you, Jim. So our next speaker is Bart Vandekerckhove. I hope I say it right.
Good enough, Atanas. Thank you.
Okay, Bart, you're here, so stage is yours.
Cheers. If Bill is still there, great presentation. I mean, it rang through the presentation that, data is the mode for AI, so you have to keep it secure, right? But there are some challenges with that, so that's what I'll talk about today. Let me put it in slide mode here. All right. See if I can share my screen. All right. Are you seeing my screen, Atanas? Is everything well? Great.
Yes. But it looks some kind of small.
Small.
Why is that? Maybe. It's fine. No. Can you please?
Okay. Yeah, I'll switch it on again. All right. Is it working now?
Now we don't see anything.
Wait, I'll stop sharing and go back. All right. Wait a minute. Okay. Is this better?
Yes.
Yeah, brilliant. Hey, everybody. Let's talk a bit about data security, more specifically how to balance data democratization, so innovating with data, self-service analytics, Gen AI. How can we balance that with data security? Before starting, I just want to give you a little quote that I read on the internet or on LinkedIn a couple of months back, and I mean, it's pretty clear. Access management is the most annoying part of data engineering. That's a quote by Andreas Kretz, who is a data engineering coach who has more than 120,000 followers. And let me tell you, that LinkedIn post got a lot of likes. It really resonated with data engineers, data architects, everybody who basically has to work with data. And yeah, I mean, why is that? Well, access management is broken. Everybody who works with data today has their frustrations with the workflows for managing access, for getting access, the data security management workflows, and so forth. And that's what I'll talk about today. So, hey everybody, I'm Bart. I'm CEO and co-founder at Raito. And before starting Raito, I was the product manager privacy at Calibra, where I built out the privacy offering. And it's there that when talking to so many of Calibra's customers, the privacy teams, the governance teams, that we saw the challenges of scalable data security. Why is that? Well, most data teams, they manage access using users and groups in Active Directory, now Entra ID. But this is made for managing access to applications. It's made for managing access to a Salesforce, for instance. If you want to use that technology for access management to data in your Snowflake or Databricks, your BigQueries, that's where you start seeing challenges. But it works fine for applications. At least that's what it was built for. If you want to give your salespeople access to customer data in Salesforce, well, what you do, you put them in the sales group in Entra ID, and you give that group access to Salesforce. The same is for, your HR data in Workday. Let's put everybody in HR, in the HR group, and give that group access to Workday. And also for your support tickets and access for engineers to Zendesk. Same story, you put your engineers in the engineering group in Entra ID and give that group access to Zendesk. Pretty straightforward, right? And has been working like that for decennia. But that becomes challenging when you move that data to Snowflake. And almost every organization is moving to some kind of cloud data warehouse for data analytics, self-service AI, and now also Gen AI. You do that because you want to offer better products, better services, you want to improve your competitive stance, improve margins, and so forth. But everybody on this call also knows that, once data ends up in the cloud, it proliferates. People copy paste data, create new data sets. They merge data sets, divide data sets, creating new kinds of data sets with different types of sensitivity. And of course, in that case, when you want to reuse those groups for access management to your data in Snowflake, you get all kinds of challenges, right? In this particular situation, you can easily see that we have privacy and security challenges because everybody can just access all data. Now, what makes this even more challenging is the fact that your identities, so the identities being used for that data, are increasingly complex. When we started out, with BigQuery and Redshift 15 years ago, it was just for reporting, right? We moved data to the cloud for better reporting to management. Next step was data sharing. Well, if we have our cloud data, if we have our data in the cloud, let's also share it with our third parties. And in short, we're seeing organizations dabbling with LLMs, giving those LLMs access to their data using RAGs. So that identity is becoming very complex. So you got a lot of data that's accessed using identities over the cloud. Those identity services are very complex with many use cases, and that's being noticed, right? Your cloud identity is under attack. Where if you see Mission Impossible, where somebody had to get access to data in the server, they had to jump through ventilation shafts, had to swim through water, risk their lives just to steal some data. Now a script kiddie can do it from Russia or China, and it's happening. Your cloud identities, your cloud data stores are under immense attack. 45% of data breaches are through stolen credentials. More than 80% of data breaches involve cloud data. And also the number of data breaches has grown by 300% in the last 10 years. It pays off to be a hacker. It's never been so easy to steal data as it has been today, right? Before everybody starts shivering and starts calling their head of data, hey, what's happening here? We are under attack. You have to know that your data teams also know this, right? Your data teams are well aware that identity is under attack, that their cloud data providers are under attack. And of course, they try to manage access not at the perimeter, at the perimeter of their cloud data warehouse, but they try to reduce access to the absolute necessary access to individual data sets, individual data products. That's what they do. They are responsible people. But it's not easy for them because they're faced with a huge divide. They own their cloud data provider. So the data teams own Snowflake. They own BigQuery, Databricks, your data lakes. But the identities and the groups are owned by IT because they sit in Entra ID. And that's a completely different team. So there's this huge divide between them, creating huge productivity costs and security blind spots as they try to bridge that gap. And this is really the biggest challenge of using Entra ID or Azure Active Directory for managing access to data for fine-grained access controls. It's just a difference in ownership. And you're seeing symptoms of this everywhere, right? You go to LinkedIn or Twitter, you see a lot of people complain about the fact that it's so difficult to have fine-grained access controls in their daily tools that they use for self-service analytics, AI, ML, and so forth. So we have to put it in a way, it's that today's data security workflows or today's access management workflows are really not fit for how we work with data. Let's break it down, right? So if permissions are managed in your cloud data store, but users and identities are managed in Active Directory, you're already using two tools for access management. Then you use some kind of ticketing system for your access requests, ServiceNow or Jira. That's a third tool. And then some more tech-savvy data teams, they use Terraform or Pulumi or some other kind of infrastructure as code to bind identities to permissions. That's a fourth tool. So yeah, 4 tools to manage access. Yeah, good luck getting an overview in who has access to what. What are the usage patterns? When did somebody request access to data? Who approved it? Who changed the access controls? You don't have it. It takes multiple weeks just to get those insights. So yeah, this is a big security blind spot. And with the upcoming security regulations in Europe and the new security standards in the United States, this is a big no-no, right? Because you get supervisors, you get auditors who want to have insights in who has access to what. If not just internally, your stakeholders, your CISO. The CISO often calls data teams shadow IT because they don't know what they're doing. You got to start reporting to your stakeholders on that. It also has big productivity costs. And this is one that itches most of the data teams. It's a slow process to get access to data. Data teams are under immense pressure to create value from data. They have to do it with reduced budgets. They have to be productive. But then getting access is a very slow process. When there's a new data product or new team member changes teams, it always means logging a ticket with IT, hey, add this user to this group, or you need to have data engineers on call to process access requests. Really, you have data engineers on call to process access requests. A data engineer makes no sense. And that's very frustrating. It destroys your developer experience and really kills creativity and innovation. What we also see is that a lot of data teams, a lot of organizations are applying some kind of flavor of data mesh. One thing that we see a lot is, pushing some of the responsibilities to the data owners in the business. Let them manage access. Let them approve access requests. Well, if access is being managed by adding users in groups, well, how can you push that responsibility to the data owner if IT owns that part of the process? So we cannot achieve that scalability. And another security challenge is the manual process. It's a manual process through and through. And when you have a manual process, a process that kind of sucks, you're going to make mistakes. Yesterday, I was talking to a data engineer who got an access request, wanted to go home, gave the wrong permissions. Next day, he comes back into the office and gets reprimanded by his manager. Makes no sense. I mean, it's just a shitty process. So that's why we see customers coming to Raito. Because with Raito, we give you end-to-end ownership of the data access management and data security process for your data. And as a result, your data workers, so your data engineers, your data analysts, your ML engineers, they get access to the data they need in a fast and secure way. With Raito, because we have that end-to-end platform, we improve transparency, right? Instead of having to work weeks on getting a report on who has access to what, that information is readily available in Raito. Now you can see who has access to what usage patterns are, what the audit logs are, and so forth. That's great for the regulatory wave or tsunami that's coming our way. But also very important is improved productivity. DevX has never been as important as now. Your data engineers are frustrated with the process. Let's make them more productive. With Raito, instead of having to wait weeks to get access to data, it can be done within a day, or when you automate it, in a couple of minutes. And one of the ways to achieve that productivity is by scalability. Let's take some of those core responsibilities out of your core team and push it to the data owners in the business, because they have the business context. They know what the data mean. They know who should have access. Let them manage the permissions and the access requests. Of course, you need good UX for that, right? And then finally, manual processes, even collaboration is great when you can achieve that, but automation is even better. So let's look at ways where we can automate the decision making, where we can automate the process to really make life so much easier and make your engineers more productive. All right, so how does that look like in the product? Well, first day you connect Raito with your data stack. We'll give you an overview of who has access to what, who is using which data, what are the usage patterns, where are your risks, where is unused data. And based on that information, you can start taking action, maybe removing unused permissions, deleting unused data, getting into contact with users that are not using their permissions. And the great thing is that with Raito, we give this unified view across the data stack, right? So in one location, you can monitor what's happening across your data sources. And then when you're ready, what you can then do is start assigning data owners. Hey, dear data owner, as of now, you are responsible for access management in your domain. But no worries, we got fantastic UX UI for that. If you have assigned an owner to your data, all access requests are routed to that person or that team, and they can just by a click of the button approve permissions, after which Raito will update the permissions in the underlying data sources. So something that is normally a cumbersome process with infrastructure as code, ticketing in Jira, sending tickets to IT, can now be done in a couple of seconds in Raito. And then finally, when you have high levels of maturity, you are good down the way, you have your metadata in place, all your data is tagged, you have a good catalog. That's when you can start looking at maybe let's leverage those tags, let's leverage that metadata so we can automate access decisions. Let's have a policy that, for instance, says, everybody in marketing can have access to customer data. And then Raito, what we will do is look where's your customer data, look who is in marketing, and then give these people automatically access to the data. Or maybe you want to have policies that limit access in time for a certain project, or maybe just access for a day where you need increased or elevated permissions to deploy a new data product. And that automation is key because that's where the value lies. And this is what we were focusing on mainly the last 2 years. But in the previous session, Bill made a great point. You cannot bolt on security on your data product or your LM or AI/ML model. It needs to be integrated. And that's where we see the importance of shift left. I was going to add a funny meme here, but I want to just add the hard facts. Integrating data security in your DevOps process is the best way to reduce the cost of data breach. This is based on research, I think it's by IBM, showing you that the best factor to reduce the cost of a data breach is by having integrated security in your DevOps process. This is the same for data teams. This is the same for your MLOps teams. Let's integrate data security in the development process. And it's something that we have released recently, and we're seeing a lot of traction there, right? With Raito now, you can start the data security management process as you're creating your new data products in DBT. We're working with Bittel. Why not have the appropriate permissions, the appropriate roles and groups set in data contract? Or for other teams that use Terraform, they can define which roles or groups can access the data. And if you're really mature, why not just in your data product, as you commit it to the code base, as you do a pull request, just tag the data so that right up based on those tags can set the appropriate access controls, but also data masking and role filtering rules, right? A bit abstract maybe so far, but the benefits are clearly there. If you uptake this approach, you can unlock more than 70% of your data for BI, AI, ML, and Gen AI. Getting access to data is one of the biggest factors that we hear for people, preventing them to get value from data. But also the efficiency improvements. It's a tedious process today. I mean, it's really a pain in the ass. Well, right, so you can achieve a 40% efficiency improvement in managing access. And then finally, God forbid that it happens, but assume it's going to happen. If you get breached, well, having a good data security management process reduces the impact of a financial, reduces the financial impact of a data breach by 80%, right? And that's what we're seeing with our customers. So we got a couple of customers here on the slide. Telenet is a telco. Telcos, they work in extremely competitive environments. Environments are completely set, and they are looking for ways to improve their competitive position. Giving access to data to the business so they can innovate and find new ways to improve margins is core for every telco. Of course, that self-service analytics, that data democratization needs to be secure. So with Telenet, we're really focusing on the data marketplace. How can we make that secure and streamlined? How can your data analysts and engineers get access to the data in a fast but also secure way? And then we have another customer, Deliveract. That's a extremely fast-growing engineering-led scale-up, working with a lot of sensitive partner data. And there, the use case is primarily focused on how can we integrate data security in their development process. So two different kinds of customers, different kind of use cases, but in both cases, it's all about streamlining data security so that your data workers can become more innovative with data without you compromising your customer trust. All right. I'm at the end of my slides here, at the end of my little spiel. I'm opening the floor for questions.
Okay, Bart, so we have some questions for you. First of them is how can shift data security left?
Yeah.
From your point of view, of course.
Yeah, well, the way that we see that, right, and love to get your perspective on this is we see it in two possible ways. So when you're creating or modifying your data product in dbt, for instance, that's when you can set the appropriate, or that's where you can define the roles or the groups that can access that data product combined with their permissions. Now, not every data engineer has this information. So another way of achieving that is just by tagging the data. So for instance, if you have a new data product, you can say it contains customer data. This column contains customer home address. What writer will then do based on those tags is, first of all, give the right people access based on your policies and those tags. So for instance, the marketing team can then have access to that particular data product, but we would also dynamically mask that column that contains home address, because that would be, in breach of the GDPR. So it would be twofold. We would dynamically give access and dynamically mask access based on the metadata in your data product. And that's what we mean with shift left, because when a data engineer is creating the data product, that's when all that information is fresh in their mind, right? If you have to bolt on security afterwards, that information is gone.
Okay, but I'm trying to figure out how do you do this in multi-cloud environments?
Yeah,
Yeah.
that's a secret sauce. Very proud of what we did there, actually. That's the advantage of working with a brilliant CTO. Honestly, all the kudos goes to Dieter, my CTO. Together with our team, he has devised a way where we can consistently, or devised a model to consistently manage and monitor access and usage across the data stack. And we do that by having universal role-based access controls and universal attribute-based access controls that we then resolve in our graph database and translate that to permissions, to the permission systems that are native to your data sources. So even if it's ACLs or RBACs, we're gonna take those policies, translate them to the native access controls so that your universal access controls are uniformly configured across your data stack. Took the team a while, a lot of thinking, a lot of trial and error, but they devised it, and I'm proud to say that we're actually the only vendor in the market that can do this.
Okay. If anybody have other questions, if there is no questions, can you please share with us your next events or next plans, moves, and near future?
Yeah, near future is all about fine-tuning the right to even more. Our dream is to be invisible. That sounds weird, to be invisible to data workers, right? Raito is Japanese for lightweight. So this year we are more deeply integrating with the daily workflows. So somebody can request access from within Slack or from within Power BI without ever seeing Raito. These are the ambitions mainly for this year.
When can we expect a version that is using Beetle and ODCS?
That's something we're working on with Dieter, and it also kind of depends on the progress with Beetle. Hopefully soon. Hopefully soon.
Good to hear.
Yeah, Josh.
Okay. So, if some more questions or? Okay, there is no questions, Bart. So thank you. It was a great presentation, and really happy that you agreed to be part of it with AI on Pi Day. See you soon, I think.
Yeah, Atanas, Jean-Georges, thank you so much for having me. Really appreciate it. Bye-bye.
Thank you, Bart. Thank you.
Thank you, Bart.
So, as of now, we have some emergency for our next speaker. So he sent us his presentation on recording. So I'll just share the video with you. And it's still, he will be here, but you know, like more virtual than usual. Let me say that.
And is in Slack. So so you can contact Fabian in Slack as well if you have questions after we watch his video. So, right.
Yeah,
right.
Definitely. Let me see if and.
Hello guys, I feel very delighted out of this today that I can share experiences as a German consultant in the banking and financial with you regarding implementation of AI models. And today, from the hype to the real implementation of AI models, questions facing in the banking is how production. And this is what I want to talk today. So prototype really value generating AI models.
So I want to ask if, yeah, okay, understand that. So I can try one more time because we tested before 30 minutes and it was good. I'll try one more time and let's see what will happen. If no, we can have some kind of conversational dialogue here.
Hello guys, I feel very delighted to be part of this user group today, and I hope that I can share some of my experiences as a German consultant in the banking and financial industry today with you regarding the implementation of AI models in the financial sector. And today I want to separate with you from the hype to the real implementation of AI models, because one key question that our clients are facing at this moment in the banking industry is how they get AI models from a pilot to a real production. And this is also what I want to talk with you today about. The question is how we get from prototype models to really value generating AI models in the financial industry. And one vehicle and one tool that I want to present you today are just some MLOps practices and best practices that we've seen getting real value at our clients, and we also want to get a little bit deeper into the technical foundations, how we can do that. And I'm really looking forward just to get into the discussion with you. And so first of all, one can say that in the financial industry, there are a lot of use cases for AI models. And what many decision makers want to hear just very first from me when we talk is which are the quick wins. Which use cases for artificial intelligence are low in effort. We have here on the y-axis, we have just a low effort in development and implementation and have the most benefits. So this is in this case, in this matrix, this will be those use cases. And of course, we are experts in this place. One can say that with low effort in implementation and development, you cannot have a really high rewarding AI model that's really internally very, very important in your processes. But I want to, just to get into the topic, I want to give you a quick market overview into some of the use cases that we are using with our clients and that we've got into production in the European market. Just to get a feeling of how AI is really used in the market at the moment and what's behind the hype. So first of all, one thing that's relatively easy to be done with OCR and is not that integrational is the checking of documents or just of paperwork, because I think we all know that many banks just have a lot of people just checking some invoices or some letters, stuff like this. And when you really look into the processes in the banks and check which ones have to be done by humans and which one can be done by a model or just by a computer, you can really get with low effort, you can get a really high benefit. And so this is one thing that we've done with a bank for financing homes, for example. We've said that every time that someone has to send in their invoice to get a little bit more of credit, we can do this very, very easily with OCR just to check if there's fraud in one invoice. So this is one example where it's a really low-hanging fruit, but we also have some low-hanging fruits that are not that interesting for banks. For example, when you do a cash flow forecast, this is something that like a complexer regression model. Next best offer is an interesting thing which you can get before your sales department, so your sales department really knows who to call and where you have the best opportunity to get a new new sales, and also a compliance auto check is very interesting because the banks are very highly regulated, and so they have to check if their processes and their documents are really compliant. And there are also some things that we say are very highly in development and in implementation because they go very deeply into the systems of a bank, and because of that are not that interesting. For example, marketing is this thing where you can use tools, but to do it fully automated, it's very hard. And also churn prevention is just a thing where you can try this churn prevention just as next best offer to see which clients are leaving the bank and which are not, but it's not that it's not scaling that good because most customers just are not leaving the banks. There has to happen something very significant so that they leave the bank, and also market forecast most of the time is too complex to do it in a short time. But today I want to focus with you on those things on the right side, and we will do it really on use cases that we've done, because most banks are first of all asking themselves how to do pilot. So when they are not in that high development stage, especially small banks, they are just asking, how can I use this technology at this very moment? And then we get to use cases like this, where they can have a small impact, but also small effort in implementation and development. But when they get from the pilot to a real implementation in their institution, it's really difficult to see how this works. And today we want to bridge the gap between the pilot and really the value generating AI model. And some of the examples where you really have to get into MLOps practices are chatbots, for example, internally and publicly, because they have a really high database, and to do it properly, to get a chatbot or an assistant properly moving in a bank can be harder than you think. And also some of the really interesting things, fraud detection in your payments. So for example, when you have instant payments, just to see if there's a fraudulent task or if there's money laundering, you can really get trust by your employees, for example. And also risk models. Do I get a credit or not? And so the key question when we look at those use cases is, how do we get from prototype to the value generating AI model? And today I want to focus especially on normal models, so complex models that are not LLMs, because all those MLOps cycles are very different when you have just a model that you are fine-tuning. Today we are not doing that, but we are pretending that most of the models that we are using are just self-trained. And to be honest, beside chatbots, this is still the way to go for most banks. So they are using AI to see which use cases can be done perfectly best, and most of the time to see if regressional models, for example, can be replaced by better AI models. And so today, first of all, we have to understand, and this is a thing that I tell our clients all the time, that a pilot, when you start with a pilot or just with a use case, you not only have an AI model and get it into production and then leave it there and forget about it. You can't do this. You really have to think in the first place about which use cases give the most value for your specific institution. And this is not something that you can generally say. We have done this overview just one slide ago. You really have to think about your business model and on which part you have processes that you can automate. And so on the very first thing that you have to think about is the demand. Where do I really have demand? Using AI just because of AI's sake is not the solution. It will make everything worse. So first of all, you have to think about the demand and then about the requirements. So you have a demand. What requirements does an AI model really have? And when you have done all those business understanding things, then you can start with a pilot just in a small space, very little complex, evaluating them on matrices that you've thought about before. and then scaling it. And the interesting thing where we take a look today is the scaling. How do you get a pilot to scaling and then to develop it? So when you have a model in production, how do you get this model maybe networked in your company? Maybe you do multi-hopping, you have to change it, and then the cycle goes on and on and on. And today we have 3 examples I want to go with you through to get the value of MLOps too. The first one is document fraud. I've talked about this, just a model, mostly OCR driven, to see if some documents are fraudulent or not, if someone has changed a number or something like this there to get a higher amount or something like this, and you're using just current and historical statements. You have a high criticality because you want to get fraud, but you have not high changes. So documents are always the same. That's different with fraud in your payments, for example, because you have payment transactions. And in this case, we've built a model that uses networks effect just between their customers or financial institution and other banks to see if there's a fraudulent account and if this account is getting a lot of payments, and so that you can, as a bank, maybe forbid your customers to pay something to this account, or just to ban the account itself. And it's just internal bank data, high criticality, and this is very interesting when you think about MLOps. The fraud schemes are changing very regularly, so it's not enough to just get a model in production, but you have to change the model due to the schemes that are also seen. And another thing we've talked about is a robo-assistant. Everyone wants a robo-assistant at this moment, internally, externally, whatever. All the decision makers want one, and you're just using internal projects, using a foundational model, historical documents, and it's not that critical, because every time that this robo-assistant says something, a human gets to get the answer and has to do something with it. There's a human in the loop. And at the moment, this is what we see with our clients when they use something of those use cases, and I want to get those just as an example because they are very different, and we can see some things there. At the moment, and this is very similar to software development 10 or 20 years ago, most of the AI models, even though they have very, very, very high impact in the organization, are deployed manually. There's just a small team, a very small team of data scientists, and they are developing a model or two, and they are also taking care of it. And at the moment, when you're doing it like this as a bank, especially in Germany, it's like this, then you have a problem with very long delays between some models, because you can't monitor them and you can't see when new model variants are necessary. So when you see this in production, that a model maybe fits, for example, in the fraud, that a fraud scheme has changed, you still have to have very much time to train a new model, to get new features, and so on. And so it's very time consuming to update a model. And also you don't have an alternative. So you just have to train every time again, which leads to long delays and maybe even to pain for your customers. And also you have a really, really high maintenance risk, because it's just a few developers and they know everything. You have high silos and they don't cooperate with another. So one has one model, the other one has another one, and then they are developing this. And of course, and this is very interesting, in our highly regulated environment as banks, you can't explain your model. When there's just one developer working on a model and he's doing it on his own machine, he doesn't know which data he used, which metrics the model had, which hyperparameter he used. He doesn't know nothing, and if he's hit by bus, no one knows what's behind those models, and so you can't explain them before the regulator, but also not before your customers when they don't get a credit or something like this. So you really have the need to document your model and to work together on different models. And it makes things so difficult comparing to the software development, because the AI model development cycles is more complex than when you're using or when you're developing just normal software, because you have the data the model and the production, 3 different things that just have to work together with different roles. So in the data, you have to analyze them, prepare them, understand them just in your domain. So it's not just a technical problem. You really have to think about also business question. And when you have the data right, you have to do a lot of experience on the model, evaluate them. So you have a lot of model candidates, and then you get one model, and of course then you have to get it in production. So you have data, models, and then the normal software on the production side. In software projects, you normally have data and production, but not a model between them. So we have to bridge this gap and see what we can do. And this is where MLOps comes into place. And we've just done with our customers, together with our customers, just with a few banks, just a cycles to see which steps you have to do in detail to get a model into production really, really good. And of course, not every bank is doing every of those steps. But we have to see this picture just to get an imagination how we could do it properly, because most of those steps that I will explain just in a minute are done by hand at this very moment. And we have to see this and automate step by step in banks. And at the moment, most banks are still hanging in the data preparation, which of course is the very fundamental stage to get a real model working, because garbage in, garbage out, you all know that. You really have to take a look at those data things, analyzing them, transforming them for your statistical methods that you're using, splitting and versioning them. This is a thing where most banks are still there, just to get a spot, something like this. But after that, you have to get a model, training it, validating it, selecting one of the candidates, training it on scale, which also is a very very hard problem to get when you have not the right hardware and you don't want to use a cloud, and also of course versioning it. And then when you have that, most of this is doing manually, and then you're just doing it at the moment at most banks manually to an API. When you do it really properly, you have to still have a scaling API. And one thing that most banks and most decision makers at this moment are losing is that you have to have a cross function that is seeing all those steps with a domain understanding, because you need it at every part. It's not just a technical thing. And also, and this is maybe the most important thing, that when you have a model in production, you have to log it and you have to monitor it. And you have to have a few models as backups. So when something goes wrong, you can change those models very, very quickly. You have to have a lot of model candidates, especially in critical use cases, but we will see that. And this is just one thing that I'm showing our banks to see where they are standing. And it really depends on the financial institution. And it's really, first of all, a process question. Yeah, so I had those 3 use cases at the beginning of my talk: document fraud, fraud detection in your payment transactions, and the robot assistant. And I just want to show you where MLOps may be the most necessary. And yeah, in the document fraud, it could be necessary. It could be a very good idea to do it, because you have also current statements, and the database is refreshing on a regular basis, and you have a high criticality. So you really want to get those documents, and maybe they have another fraud scheme, or maybe your model is not working perfectly, or a worker has not done a good input, something like this. So I would say that this is a medium use case where you could do in MLOps, to implement MLOps, but you're not dying if you're not doing it, just having a model for a few years. It's very similar with the robo assistant, where you have a lot of historical data. You are just using a foundation model, and there you can still do the evaluation of the answers. For example, if you all know this, an LLM evaluating another LLM. But where it really comes, where MLOps is really important, is when you have critical use cases that change on a regular basis. For example, with payment transactions, where you use internal data, which is very critical, so you have to use it wisely, and you have really regular changes in fraud schemes. So this is a thing where when you deploy a model by hand, just once a week, you have the problem that you really have to explain the regulators and the customers why an account or transaction may be fraudulent or not. And you also have to change quickly. So when a new fraud scheme occurs, you really have to change quickly. And this is where you need all those processes that I've shown you there. Now I want to dive in with you a little bit deeper into the technical things, because there are a lot of frameworks that you can use it. And the most important thing, first of all, for banks, and this is the answer that I'm bringing them first, is to understand that there has to be processes. You can't do it manually, but I would just want to get quick into how we've done it with one of our projects at this very moment. And just to give you an example how you could do it, because it's not that difficult. You just have to have the learning first, that you have to have a process internally. And in this example, we have 4 steps that we've built the MLOps. Some of the MLOps steps I've showed you before technically, just on GitLab. You don't have to have a special platform or something like this. We've done this with GitLab and just GitLab and Docker. So and a server where we have the hardware where we can compute all of this. And first of all, we have 4 steps: the build step, the run step, the visualize step, and the deployment step. It's very similar to software development. And first of all, we build a Docker image just with the dependencies that we have, and it's authenticating with everything. So we have an empty Docker image that's authenticating with everything, and we can work on that. That's our workhorse that is used throughout the whole process, and it's every time the same thing. So we have a runtime environment. And on that, and this is the main step, is we are running everything. So we are getting, every time we run this pipeline, we are getting the source code, where we of course have several model variants from the Spot, from the Google Cloud, and we are doing all of the steps that you would think of as a machine learning engineer, for example. So getting the test data, using features, training a lot of models, selecting them on the accuracy, for example, and then saving and versioning the model. So in the end, we have just a few models that we know that are good and that we can evaluate more. And this is a very important thing to understand. There we get to the step of visualization, because we can't deploy a model in banking just automatically on their accuracy, for example. We really have to visualize it for the decision makers to see what the model does. We've used Kedro-Viz and MFlow UI, but one thing that we are implementing at this very moment is, for example, weights and biases, just to see on which data a model is used, how the matrices are, how it come together, and then to decide if this is the model that you want to use. And if you've decided manually then to use it, then we deploy it just on a fast API in a Kubernetes, that it can be used as microservices. So the important thing that you have to get from this slide is that all the machine learning steps that you might be thinking of first when you're thinking of MLOps are just one thing that you can do automatically, just in a script. No problem. But you have to think of all those infrastructure questions that we addressed in the build, visualize, and deploy step, because this is where you really get to full automation. And for us, just to get a very quick insight, it's very easy, because we've used Kedro just to orchestrate all those machine learning steps. And this is when you would ask me which steps or which learnings, how do I get started best, especially in the financial industry, I would say just orchestrate your machine learning steps. Do not have some few scripts that you are using and you don't know what to do. Get it into a flow, just like we've done it here. You can do it very easily, and we've used an open source tool, Kedro, but there are also a lot of other tools that you can use, and you can see there, hopefully it's big enough, that we just have an orchestrated flow. So you begin with the data and you end with a model, and this is a thing that you can really get out of your source code. And when you're getting up to getting a project in a bank, just a small use case, a pilot use case that some are asking for, I always recommend to start with orchestrating, because it makes it so much easier to scale a model in the end. And so in this example, we're just getting the original content, which are, for this example, we are checking documents for fraud. It's a lot of invoices. Some are fraud, some are not. Then we are creating labels, like you can see here, getting the features, training a few models, getting the best model, and then saving it through MLflow in our Google GCP. So those are just a very basic example, but I wanted to show it to you because it makes starting very, very easy. And also then it's so easy just to get those 4 steps that I explained to you into your GitLab just via CI/CD YAML file. And in the end, to get interfaces like this, it's very, very easy when you have a server to do it. And I think just to get to a position where you can see such an MLflow interface, or to get the pipeline running, and to getting a real orchestration, I think you have to have just be below 1 week, and then it works. Just start small, and when you have that, it's paying a dividend when you are trying to scale your model, and then you can really, then it really helps you. And so, we've worked with MLflow and Kedro. Another really great thing is ZenML. But in the end, we have high model quality because we always have the best model in production. We see vulnerabilities because we model the model in the end. We have a feedback loop on the API in the end, and we can really show on which data with which metrics one model was trained. And this was like the best thing to do. But when you really think about how to implement a model, you also have to think about the change perspective. What do you have to think as a decision maker, how to implement this MLOps thing on a organizational level? And one thing that I'm always teaching then to our clients is you have on the one side the technical part that I was talking about, the processes, where to use this, which those things that you have to be very, very precise in. But on the other hand, and this is very important too, and mostly forgotten when you're coming out of the tech world, you have to think about those business questions first and then get the stakeholders. When you have not done this, when you doesn't have identified a use case and have talked with your stakeholders and have put this transformation on, all those things we have on the right side that we talk about are useless, because you have to get the support that you need. And so all in all, I have to say MLOps can be the bridge, and especially in financial institutions, it's very important, between the pilot and a really productive value-generating model. And you have to start very early. You have to start very, very early, just with orchestrating your data science steps to get going. And I just want to thank you for this opportunity to show you some of my experiences in consulting, just with a few banks we have worked with in Europe and in Germany. Just hit me up if you want to on LinkedIn or somewhere else, and I really, really look forward to discuss you. And I, of course, wish you a very pleasant user group and some very interesting talks.
So, okay, despite Fabian was not able to be live with us, I think he did pretty good job, like we all saw. So I want to thank him. I want to thank you all guys that you were with me whole day. And despite some confusing situations, like it's my first time hosting event, I hope I manage it some kind. good, maybe. I promise next time I'll do better. And now it's time for Karen to continue the journey.